Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
All right, what's up, everybody? Yes, we're starting off 10 hours. There you go. That's it. 10 hours. 10 hours for 10K subs today. Oh, man. Zach says he's done this before, though. So, you know, I think we'll be okay. You crazy. I'm crazy when I do 24. I wanted to make sure to celebrate something this week. I'm still talking to like some other like corporate people about like sponsoring a 24-hour one. But I want to make sure. I'm a very big advocate for like do something when it happens. I hate like late celebrations for things. I've never done a 24. I mean, I've definitely stayed up for 24 hours. Yeah, I've done that for sure. 10 hours? You're fucking poggers. We are poggers, dude. Welcome. All right, and then let's get tiki-taki working. Also, let me make sure all this is working fine. No, see, Discord, you silly girl. All right. Where's the stage at this point? The stage is too far. There we go. Okay, that's fixed. Dude, what the hell? What the hell, River? What's up, dude? Been a minute since I've seen you. There we go. All right, now we're good on that. Let me make sure we're okay on YouTube Live. 10 hours, yeah. Strap in, it's gonna be a bumpy ride. Yeah, I know you use Discord, River. Yeah. And, it's been a while since I've seen you here on YouTube. That's what I meant to say. Sorry. Let me make sure my YouTube's actually running. So I did a lot of beefing up the system. So I have like redundant internet running. I also set up like a dedicated like event on YouTube. So even if this crashes, it won't auto end it. I can rejoin it again, I think. So just want to make sure this is running. Make sure this is running in the shorts category. It is. Nice. Okay, great. All right, sweet. All good. All right, yeah. What's up, everybody? It is Thursday. Last stream of the week. Glad to have all you guys here. Let's get TikTok chat working real quick. Connect. TikTok should be running in soon. Am I gonna just do 10 hours of pure math? I'm gonna just do 10 hours of problems. I don't know if it'll be all pure math, to be honest, but it will be a lot. We always end up having like leftover questions. I mean, I am gonna have to go to the bathroom at some point. Yeah, so those breaks definitely count. But no extended breaks. I do have like I have a special thing if I have to take a break. Where is it? I have like a button for it. There we go. We'll be right back. I built that in. That's if I have to, you know, go get myself like a coffee. 10-hour live stream. Yeah, we're gonna do it. Yeah, so kind of my motivation behind this is, man, we've gone 4 hours, 5 hours, 6 hours, and I always have more questions to go through. So I want to see if we can go 10. Also, it'll be cool because as we get later in the night, I start hitting time zones that are at different parts of the world. So we start getting audiences that we usually never see before. I will be here till 2 a.m., yeah. 10 a.m., technically. I started 10 minutes late because I was trying to get some other stuff like up and running. Yes, Bing Bong, do you want to be the first question of the 10-hour stream? Submit it, please. Do it, dude. You want to be the first one? Go submit. I don't care about privacy inspector. Your channel, yeah, and that's honestly that's really what I'm doing here to celebrate. We have had an insane amount of growth, which I'm really thankful for. This last month, it has been quite crazy. Yeah, I'll show you guys for you up and coming YouTubers if you want to see like what it means to try to play the YouTube game. Let me. Oh, and I need to get air going in this. This is about to get really hot. Big ass spike. I started watching you a month ago. Yeah. Yeah, all good. Yeah. So yeah, if you see our analytics, we have had 1,700 subscribers in the last month. I don't usually get that. I usually get like a couple hundred. We've had 1,700. If you look at, for instance, in the last 90 days, this is actually kind of fun to look. I always love looking at data this way. Here, if we look at, like views and stuff, it has really, it started spiking up a lot recently. Starting in September, and I know why this is. Well, we made partner on YouTube. So like YouTube knows now that they can make money by selling advertisements on our streams. And also the school year started. So, we've had a lot of people join. Last week was insane. I had the most I've ever really had on a live stream. If we look at the last year, this is always kind of fun to watch. This is the end of the spring. This spike here. This is the end of the spring, end of the school year, which is this was earlier this spring. We did also have like some massive spikes, and that was because I was doing AP class review streams and stuff. All good, Bing Bong. Bing Bong. We're gonna do it. So yeah, the summer's always kind of brutal for anyone who's in education. Streaming during the summer, you just got to keep pushing. But it starts picking up now during the fall, and that's dope. I didn't think we were gonna hit 10K this quickly. I thought maybe by the end of the year, but yeah, here we are 2 months early, so I'll take it. But yeah, welcome to Actual Education Office Hours. We're the math stream that helps you out with math homework, science homework, all sorts of other fun stuff. Congrats, bro. Yeah, well, yeah, 10K. We got a lot more to go. 15K by the end of the year. I would take it. Yeah, well, we'll see how many we get during this stream. I'm going for 10 hours. Maybe we'll go viral at some point. I don't know. Couple announcements. Some cool stuff I've done in the server. I've been vibe coding. Yeah, I did not set myself up for success for this stream because I went to bed at 5 o'clock in the morning last night. Or maybe I did because I can stay up later. Yes, that was YouTube revenue. Yeah, we've made about $100 on YouTube in like the last month. It's not really much money, but it's a start. And how do you get started with YouTube? You just got to keep posting. This is probably the 5th year I've been streaming, and yeah, it's only now that it really starts like picking up. You have to just be very perseverant or have like really pretty feet. My toes are not desirable apparently. But anyways, so in the Discord, I'm gonna make an announcement about this. We have this homework help forum, and this is where everyone who submits questions during our stream, if I don't get to them, they eventually get put into here. And what has been happening is we have these awesome other partner friends, which I call my actual educators, who have been coming through and solving them for people. Like, we've had people, for instance, well, this was me, but some other people, like Fazy, I think, and whatnot. Yeah, I've had people come in and solve them. But I've also noticed that after like a couple days, there are some questions that still haven't been answered. And I only foresee that problem getting worse as we start reaching more and more people. So what I have vibe coded, what I have built, is I've built a Discord bot. And that's why I was up for 8 hours last night. I built a Discord bot. And what that Discord bot does is it looks through all of the like leftover questions that are in here. And if any of them haven't been solved, if it has like the unsolved tag and it's been more than 2 days, so there's like a waiting period, it will go through and it'll actually produce a full like ChatGPT solution for it, and then it will export it to a PNG. So I've talked about this many times about how much like I think AI is great for learning if it's used responsibly. This is my like attempt at like using it responsibly, where if your question doesn't get answered during the stream, but you at least tried, and it doesn't get answered by one of our actual educators because, again, there's a lot of questions coming in and they can't get to everything, then after 2 days, I will spend money to have ChatGPT use whatever its nicest model is to solve your question for you, and then you can use that as a reference sheet to look at. I put, like, big warnings at the bottom of things here. I say, like, you know, where is it? Sorry, there. At the bottom, I say, like, here, this is it. Let's put it up here so I can show it to people. How much does it cost me per time? Honestly, not that very much. It's like pennies, but it's still money. But we have this nice little thing. It says this answer was generated by AI. By AI. It may contain mistakes. AI does make mistakes, and I say use it as a reference to double check your work, because yeah, AI is great for learning if you can also correct the AI. If you go through the steps and you can figure out where AI messed up, then congratulations.
That's dope.
That means you know the subject pretty well. So I think it's great actually to try to like look through these solutions, see if they make mistakes, make sure everything makes sense. And again, if it doesn't, come by the stream and we'll help you out with it. BK said, I was wondering if you could use AI or something to see if an incoming question is similar to a previously one. That's a good idea, BK. And then I could point it. Yeah, so a thing that I also do a lot of the times is someone will say, hey, I have a question about related rates, right? What's up, midget? And I will say, oh, but I have a video on that. So it would be really nice to have like a chat bot that reads like student questions being like, hey, can you do a related rates question? Be like, well, while you wait, how about you go check out this related rates video that we've already made, and you can go through and see it. That's a great idea. I like that, BK. Nice, Roar. How'd you do on the PSAT? How'd you do? But I like the idea, BK. That's great. Yeah, there's infinite possibilities running forward. Yeah, it's great. You want to tell us? You want to tell us, Roar? What's up? Almost 1,400 as a 10th grader. Wow, that's great, dude. You know, my SAT score was a 1420. And that was me as like a senior in high school. I have a homework question. ChatGPT can't answer as well as a human. We'll submit it and let's see what happens. 1,400 is still great. All right, let's have up Bing Bong. He's scared for his chem exam coming up. So let's go help his question out. All right, and let's start off the stream. All right, welcome everyone to Actual Education Office Hours. My name is Dr. Gold. This is a stream that helps you out with math homework, science homework, all sorts of fun stuff. Today we're doing a very special 10-hour tutoring stream. So I will be going through 10 hours of questions on the stream. Please submit everything and anything you want help with, and we will try to help you out. Bro, I need words. No, dude, 1420 out of the old. No. 2120. 2120 out of the 2400. 1420 out of 1600. Jesus, what? No, dude, I think the minimum score they give you for writing your name is like 400 per section, right? Or is it 300? Yeah, we're going to do 10 hours today. Well, there's the timer. Do you see the timer? Timer says 9 hours and 47 minutes left, so. Half of it is going to be intermediate algebra, so I can send my questions. Yeah, you can totally do it. All right. Using standard enthalpies of formation, calculate the standard enthalpy change for the reaction. Okay. So first thing you got to do here is you got to balance this, right? Where did I study? I did my undergrad at UT. I did my PhD at UCLA. Was I always as smart? I wouldn't say I was always as smart, but I always liked math and like science. I thought they were cool. I was a nerd, 100% a nerd in like high school, but I was like a party animal in college. So I don't know. Take that as you will. What's up, Scrimbo?
Bing bang.
All right. I definitely have had bad semesters. Yeah, my first year of college, I got a 4.0.
My man.
I was so happy. And then everything was downhill from there. I've definitely had bad semesters. I failed a class in grad school. Like, I failed quantum. It happens. You can't be good at everything forever. You will eventually hit a wall of like shit. Like, I can't use my natural talents anymore. Show that an orbit can only be hyperbolic. Are we gonna do the two-body problem? No, I don't want to do that. All right, let's balance this, because then this should also be like a keyword here, right? If they say unbalanced, we got to go balance it. So how I like to balance things, I write out what the species are, CHO, and then let's write out what we got. So I got 2 carbons here. I got 6 hydrogens. I got 2 oxygens. Here I got 1 carbon. I got 2 hydrogens. I got 3 oxygens. It's okay. The wall starts at all points. Yeah. The 3-body problem. Dude, Noise was telling me he wrote a simulation to simulate all the planets in the solar system. I'm like, what is that? Like the 8-body problem? Is that the 7 or the 8? Yeah. Classical mechanics. Yeah, I know. Yeah, upper div. That can be rough. Okay, so let's balance. I always say balance the most complicated thing. And then whatever is lonely by itself, so in this case the oxygen, you're going to balance that last. So I'm going to balance carbon first. So I need to get 2 somehow, right? So I'm going to put a 2 in front of this. So that's going to change this. And now we're going to have 5 oxygens. Okay, great. Okay. Let's balance the hydrogen. I want 6 hydrogens. I can do that by putting a 3 in front of this. Cool. Now we got 6 hydrogens. All right, so how many oxygens do we have now? I have 4 and 3. I have 7. You could balance this like a redox reaction if you wanted to. No, this is general chem. This is chem 1. Okay. So where this is an issue, right, is I need to get 7 oxygens, but I only have like an O2 thing here. Okay. When this happens, what I like to do is, and especially if oxygen is by itself in the last thing, just put the number for the amount that you want and then put divided by whatever this like subscript is. So this is like 7/2 O2. The reason for this is that 7/2 times 2, these will cancel, and you'll end up getting the 7 oxygens you need. Okay, so that's my trick. All right, someone said, how did I get 5? 5 what? Oh, well, okay, so 2 times 2, this is 4 oxygens. And then 3 times 1 is 3. 4 plus 3 is 7. This is 7 oxygens. Omar says I'm lost. Okay. Do you want me to, how do you balance? Okay. Well, here, let's move it back. We'll move it back. It's okay. I appreciate you guys like following along. Let's start at the beginning. We got 10 hours. I got a lot of time here, dude. I'm totally fine with going over steps again. 67. Get out of here, dude. Stop it. Don't do it. Don't do it, bro. Yeah, if you have no school, yeah, stay for all 10, dude. Yeah, let's do it. Okay. The G means it's a gas. Yeah, that's just the state. We don't really care about that right now. Okay. When I'm counting how much we have of things, okay? We assume everything has just a 1 in front of it. So I have 1 carbon 2. Carbon 2 is the same thing as a carbon attached to a carbon. So that means there's 2 carbons. So that's why I write here, oh, there's 2 carbons on this side. Now there are 6 hydrogens, and there are also 2 oxygens. Yeah, gas phase. All right. I have a friend that does OChem. If you want to ask OChem questions, I will pass them to him, dude. 100%. Send them my way, dude. The queue's only 2 questions right now. It's not going to be like that for very long. Okay. Now look here. I have 1 carbon. I have 2 hydrogens. And then for oxygen, I have 2 oxygens from here, and I have 1 oxygen from here. 2 plus 1 gets me a total of 3. Yeah. That's the key right there. Yeah. It's not very long. What's up, JC? Someone was talking about OChem. I was like, send us some OChem so I can go send it to JC. Yeah. Alright. Now our job is to try and balance things, okay? This looks complicated because it's got a bunch of numbers and letters and shit on it. So I'm going to try to balance the things here first. So that means I want to balance the total number of carbons. On here, on this left side, I have 2 number of carbons. Whoa, what's up, Jamarcus? Oh, send them over. Yeah, please do.
Good job.
Oh, Science Olympiad. We'll try them. I may pass on Science Olympiad. Okay. Yes. So we're gonna try to make the sides equal here. So because I have 2 carbons here, but I only have 1 carbon here, I'm gonna put a 2 in front of this. What this coefficient does is it multiplies everything here by 2. So it makes this like 2 C's, and then it's also 2 O2s. But each O2 is 2 oxygens. So that's like 2 of these. And 2 O2s is then going to be 4 oxygens. Okay? Do you see how that's going to give you 4 oxygens? Or I should probably make this like a big O. There you go. 4 oxygens. Alright. So we're good. 2 carbons. 2 carbons. Money. There's Olympiads in Canada. Yeah. They have in the US too, I thought. All right, and then how many oxygens do we now have? All right, so I have 2 times 2, so there's 4 oxygens from here, right? And then there's another lonely oxygen from here, so 4 plus 1 is 5. Okay, so now the total number of oxygens on the right is 5. Is this? Yeah, this is photosynthesis. Yeah, this is right. This is what is this? Glucose plus oxygen gives you CO2. Yeah, this is respiration, I guess, or something. This isn't photosynthesis, sorry. Photosynthesis takes in CO2 and gives out O2. This is cellular respiration, I think. This is breathing. Someone gave me the equation for breathing. Good thing to remember to do. Alright, let's balance the hydrogens next. Okay. So here I have 6 hydrogens. Here I only have 2. How do I get to 6? Let's put a 3 on this, right? 3 times 2. So this is like H2 plus H2 plus H2. So that's the same thing as 6 H's. Yeah, I don't think it's glucose. It's something. It's some carbohydrate. But it doesn't have oxygen in it either. Oh, maybe it's... Sorry, this is burning. Is this burning something? Are we burning something? It's funny how like combustion reactions and breathing are also like kind of the same reactions. Yeah. All right. So 3 H2s makes this now equal to 6. But let's see how many oxygens I have. So I have 2 times 2, so that's 4. 3 times 1 is 3. So now I have 7 oxygens. Okay. Now we have to deal with the O. Exactly. But the nice thing about dealing with the O is that the O is by itself. So if I like put numbers on this, it doesn't fuck up like the C's and the H's. A common thing that gets like really annoying in doing this is if you start like balancing one thing, but then you have to put numbers on another thing, but then that affects another thing. Like let's say for instance I was like trying to balance the O's here. If I change any number here, it also messes up the number of hydrogens. So that's why you always want to balance this thing last. Because whatever number you put on this, it won't fuck up the carbons and the hydrogens. Anyways, so I would like to have 7, right? So I asked myself, what number can I put in front of here to get 7? Given that this is 2. And the answer for that is 7 halves. Because 7 halves times 2 gets you 7. Yeah, no, I'm glad you're trying to learn. Yeah, keep asking questions. They're good. Okay. Oh, we're burning ethane. Yeah, okay, I guess that is ethane. It's not methane. Orgo's a lot harder than Gen Chem. So this is technically balanced because now I have 7 and we're good. However, there's a little bit of a problem here. In chemistry, you're not allowed to have fractions. You have to get rid of them. Okay. And our solution for doing that is to take this whole equation and I'm just going to multiply each side by 2 or like whatever the denominator is. Yeah, everything by 2, exactly. Exactly right, Mucker. So I'm going to multiply this all by 2. I'm going to multiply this all by 2. And it's literally like algebra, right? This now becomes 2 the data sheet. Yeah, I'm gonna probably look stuff up, but yeah. Bing Bong, do you have a data sheet for it? Usually you need a data sheet for standard enthalpies. So 2 times 7 halves just gets me 7. Alright, cool. Yeah, go get it and submit it. And then this is going to be plus. Now, these are all multiplied by 2. So this is going to be 4 CO2 plus 6 H2O. Nice. And there you go. That is the full balanced equation. Combustion is exothermic. Yes. But, okay. Standard change of enthalpy, right? So we're saying like, I think we call that like delta H 0. Is that what we call this? Is this standard enthalpy? Is what it's equal to is to the sum of H products minus the sum of H reactants. And actually, sorry, I think they put the 0 here. Yeah. Superscript. Thank you, Cross.
Good job.
Yeah, okay. So yeah, for this, I do need a table. Which, nice. It's loading. It's a big image, I guess. She's a big girl. Damn. Where's that image? Come on. It's still trying to load. How big is this image you sent me? There we go. Okay, I found it. Okay. All right, it's quite large. Yeah. It's quite a large image. Okay, we're going to just drop it here. Uploading. Let's see how long this takes. Okay, actually not too bad. Okay, cool. Yeah, all right. Good. Standard enthalpies. Right. Okay, it's of formation. That's what I technically want. Yeah, okay. Yeah. This is F. Right, standard heat formation. Cool. Reaction subscript. Oh, sorry, that's right, for the reaction. Okay, yep. Sorry. This is delta H for the reaction. Yeah, so the reaction is the difference of the heat of formation for the products minus the heat of formations for the reactants. Yeah, okay, that's what it is. Yeah, Colby, did you submit the path integral one? I probably can. It doesn't look that bad. What does heat of formation mean? Right, so this is the amount of, it's a good question, actually. What the fuck does enthalpy of formation mean? I don't know. I think it's the heat associated with making this thing. So, for instance, like BR2, I think it's the heat associated with, like, putting 2 BRs together and giving you a BR2. Yeah. Yeah, it's how much energy, like, it releases or whatever the fuck in order to create things. So notice how, for instance, the standard heat of formation for just, like, pure carbon is 0. Right? Because it takes no energy for carbon to just turn into carbon. But for like two bromides to form like BR2, that takes like energy. I got in everything but math. I unfortunately have a D. Well, if you need help with math, Lulu, like we're the stream to help you out. Like, come by. Submit a screenshot of one of your questions. I'll do it. JC, yes, our CEO of chemistry says, more precisely, enthalpy of formation is the energy required to form 1 mole of a substance from its constituent elements in their standard states. Yeah, so people were asking me earlier, like, what the hell is all the G's and the L's and the S's? These are the states of things. So S means solid, G means gas, L means pure liquid, AQ is aqueous, which is like in water, basically. The fuck does that even mean? It just means that it's like the energy associated with making things. Think of it as like the cost. It's like, how much does it cost me in the universe to make ozone, for instance, which is O3. So ozone O3, which is the stuff in the air that like protects us from dying, does have an associated enthalpy with it, enthalpy of formation. O2 is 0, right? Because O2 is free. Because oxygen exists in the O2 gas state naturally. Yeah. Exactly, JC. Yeah, it's the cost of making molecules from elements. Yeah. Can I explain the mechanism of SN1? Ooh, if you submit a screenshot, I might do it. Or if I can't do it, JC will do it. Because he's very smart with OChem stuff. Studying for the SAT. I have a test on Saturday. Ooh, go check out my videos. If you go to my TikTok, SAT. Good luck on the SAT, by the way. Let me see. Dude, my TikTok wasn't loading earlier. There we go. Okay. I literally have a video here called, because the SAT is time-based, right? It's a tricky exam because you have to get through it quickly. Where did I do it? Here we go. I have a video here called, like, how to speedrun the SAT. So this just, like, kind of shows some cool tricks for solving SAT problems. And then here are also, like, 4 equations that I think are really useful to memorize for the SAT. I think some of them are given to you on your equation sheet anyways, but it's good to just know them in the back of your head so you're not looking them up. So yeah, go check it out. Holy fatigue, dude, I had to miss the gym today, Odin. Sad. Had to miss the gym for this. Yeah. It's okay. We're gonna get the gains tomorrow. I miss chest day, my favorite day. All right, let's round this out for Bing Bong. So I'm gonna look up the delta HF for the products. Let's remember that the right side. Yes, you can totally do that, Star. Submit it to that website. These are products. Products are always on the right. They're the things you produce. And then the reactants are on the left. These are the things you react. Right, these are reactants. Okay, so let's sum up the HFs of the products. So, I have CO2. And CO2 has a delta H of what? There we go. Negative 393.5. So I'm going to say, cool. Negative 393.5. But then here's a key thing. Be careful. I have 4 of them. So you got to put a 4 in front of that. 4 times negative 393.5. We also have H2O, which has a heat of formation. Where's H2O? There you go. Negative 241.8. Oh wait, and you gotta be careful here. You have to pick the right state. So I accidentally picked the gaseous state. That's not right. That's steam. We want the liquid state, which is water. Water's great. So negative 285.8. Oh, you gotta be tricky. Make sure you put in the right state. That's why moles are in formulas of N. Yes, you're right. You're so right. Cross. No. Oh, you are right, actually. Fuck. I was actually correct. You're right. This is a gaseous state. Thank you. Good catch. Okay, good. So, yeah, I actually had the right one. I just thought it made liquid. Combustion usually makes liquid H2O, but whatever. Okay. So, negative 241.8. Thermochemical. Ooh. I'll take a look at that. Maybe JC wants to take a look at that. JC's smart with chem. Okay, so this right here, this is the sum of products. Okay, so now let's do the sum of our reactants. So C2H6, which was in a gaseous state. So C2H6, where is it? Oh, they don't give it to you. Okay, so you can't really do this question. Yeah, you need the table for C2H6, unfortunately. It's okay, we can go get it. We'll just go grab it. I should put it in the formulas? Okay, I can do that. It's just getting big is the issue. She's getting like kind of big. All right, so here we go. Here we go. Okay. All right, so these are products. Or sum of products. Oop, wrong color. Sum of products, and then we're going to do minus the sum of the reactants. And so you don't have C2H6, so I have to go look that one up. Oh, it's negative 84.68. Okay, cool. So we have negative 84.68, and then how many of those did we have? Right? Be careful. We had 2 of them. So it's this times 2. And then it's also O2, but O2 is a gas. I think is 0. Yeah, look at that. We get a free one. O2 is a gas is 0. Cool. All right. So then this is my sum of HFs for my reactants. So now the last thing to do is to do some math. And then don't forget this minus sign is going to like cancel this minus sign. Okay. Let's get our calculator out. Yeah, any element in their standard state is 0. Correct. Yeah. Okay, so we have 4 times negative 393.5 plus minus, so that's minus 241.8 times 6. And then we're going to minus, so that's plus, not Z, plus 2 times 84.68. And that gets me a total of negative 2855.44. Negative 2855.44 kilojoules per reaction, I think is what we say. Yeah, right? These are all in kilojoules, I think, yeah. Right? Yeah. Per... Is it per mole? Oh, sorry, it is per mole. Well, you're right, it's not per reaction. Per reaction, I think I'd need to divide it by 2, right? Or no? I think it is per reaction, sorry, because this is balanced, no? Yeah. Okay, cool. All right. Or sorry, they say delta H of reaction is equal to this. Oh, what's happening with my thing? Good. Nice. You've never seen reaction? I think I have seen that before, though. But maybe not. Okay, cool. Does that make sense to you, Bing Bong? How we did that? What's up, DMs? Yeah, I think you're right. You're right, Cross Oatmeal. This is suspiciously easy. Okay. Go find me a harder one. But in the meantime, congratulations.
Bing bong.
Bing bong. Good job, Bing Bong. First question to start off the 10-hour stream. And we're already 30 minutes in. Yes, I can definitely do potential and kinetic energy with a pulley. Yep, send it to me. Send it to me. 6 questions in the queue. Well, we're gonna mark this one off. I thought Bing Bong was one from Inside Out. Is he? I just know from that video where he's like, tell Joe Biden what's up. Take me to dinner. What is calculus? Can you go over ideal for real gases? So ideal gases are relatively small and don't have intermolecular forces. So they don't affect each other when they get close to each other. And that's why PV equals nRT works. Non-ideal gases are usually pretty heavy, or they're big. And so the forces between them as they pass each other do affect things. What's the temp and pressure? I think it's just PV equals nRT. There's like a weird factor if it's non-ideal. I think it's like, I forget what some exponential or something. Okay. How are you not tired? I just started. Ask me in 9 hours if I'm tired. I probably will be. Okay. Next question. So again, anyone who's watching, if you want to see how you submit questions here, you go to www.actualofficehours.com, drop your screenshot in, enter your username, click here in the live queue. You can also see the questions we're going through. So if you click on anybody's username, they'll show you what question they want to know. Okay, cool. Oh, we're doing convergence. Ooh, I love these. How can I know to check for conditional convergence? I think conditional convergence happens whenever it's alternating. Maybe. Conditional convergence. Well, that usually means convergence like depends on something equaling something. Like usually there's an X, like there's a radius of convergence. To ask for feedback on an econ paper. I unfortunately don't know very much about econ, so I don't really know what I'd help you on there, Laz. But good to see you. I can definitely do kinetic and static friction. Yeah, 100%. Yeah. I think what we're talking about is absolute convergence. Absolute convergence, which I guess, yeah, if it does not converge absolutely, then it converges conditionally. That mainly happens when you have alternating series. So whenever you have like negative one shit happening. Yeah, I can do Fourier too. Yeah, I can. Try me. I say submit a screenshot. I'll try to do it. Okay. Wow. Thanks for the hype train. We got our sub goal.
Bing bang.
10 gifts, dude. Oh, thank you, Laz. Oh, 10 gifted subs. That's fucking dope. Wow.
That's dope.
Wow. We got a hype train started on Twitch. Thank you, Laz. That's sick, dude. Thanks, bro. Yeah, shout out also, Zach, I didn't know you were lurking in here. You're the series master. More series. It's a party. Yes. Okay, so you can say that this converges by limit comparison into the P series, I guess, right? Converges. You can say because 1 over n squared plus 4n plus 3 is always less than 1 over n squared, and you know that this converges. This definitely converges, right? I am on Twitch, yeah. So the same, Twitch is also a better way to watch it, by the way, because it's horizontal. TikTok and YouTube are vertical, but where you went to go submit your question, if you click watch live on Twitch, you can also watch it on Twitch and join the fun. There's lots of perks and things. You can make my voice go squeaky and stuff. Like, there's a lot of interactive things. You have a test tomorrow and you're cooked. Oh no, Bella. I have videos on friction if you need help with those. Also, the sum of
yes, n to the 1.0. Yeah, there you go. There's the baby voice. He got baby voice activated, so now my voice sounds like a really high pitched person. Am I good at U.S. history? Not very much. I mean, history's kind of just like memorizing, no? Okay. All right. This one. Nice. This one is fascinating. I think this. Correct me if I'm wrong, but I don't think this converges. I think this does
not converge because the limit as n approaches infinity of this thing basically goes to 1. Right? This just alternates back and forth. I could give a fuck about that. But n squared over n squared is basically 1. It is alternating, but in order for alternating series to work, you have to prove that the terms are also decreasing, which they're not. Because if this was n squared plus 2n, I might give it to you. But this is n squared minus 2n. So the denominator is actually getting smaller. Right? Yeah. Right, yeah, so I think this one doesn't converge. Yeah, what's up, Master Chief? Money T, good to see you, dude. This also converges. Similar to A. Because 1 over n squared plus 4 is smaller than 1 over n squared, and 1 over n squared converges. This one, ooh. This doesn't alternate though, right? This bounces between -1 and 1, which I don't think is good enough to say it alternates. You think A telescopes? Yeah. It probably does. Oh, because it's n plus 1, n plus 3. And then if you do partial fractions, it probably does that. Yeah, you're right. I want to say... This one's kind of tricky. I mean, 10 to the n is huge. Right? 10 to the n is huge. I think this would converge. Because... I guess, like, the average of this thing basically comes out to, like, 1, right? I mean, this average is between -1 and 1. So the average of this thing is between 0 and 2. You want to say this is a geometric series? I just wonder about the sine n part. I know it's 1 over 10 to the n. This definitely converges. This converges for sure. Oh, as an upper bound. Oh, thank you, Sidud. That's actually really smart. Very good job, Sidud. You know, Sidud had a great idea here. They said that, yeah, because sine of n goes from -1 to 1, right? This is where it helps to, like, kind of understand how these functions work. This goes from -1 to 1. So the whole top goes from 0 to 2, right? It's bounded at the top by 2. And 2 over 10 to the n is certainly smaller than 2/10 all to the n, right? And we know this converges as well. Oh, I got a hype chest. What's this chest I got? Nice. How do I get 2 over 10? So, yeah, how I got that is sine of n alternates between -1 and +1. So the numerator at its most, let's say sine was, like, broken and, you know, just was always exporting 1 for whatever reason. That would be the way for this series to be the biggest thing possible. But even if it was its biggest, like 2 over 10 to the n, this is still gonna be less than 2 over 10 to the n. Yeah. Well, no, it's okay. I mean, yeah, choo-choo. Thank you, lads. I appreciate that.
Bing bang.
I don't think I've ever gotten 10 gifted subs. That's crazy. I think 5's the max I've gotten. But yeah, that's where I get the 2 over 10. I can, Alistair, submit one. Okay, so this, I agree, this converges. Yes, or you could say 2, okay, that's another way to think about it. Yep. Yeah, or you could say that, right, this is 2 times 1 over 10 to the n, and then this is a geometric series, right? This is geometric. Exactly. No, you're totally right, Sidud. Yeah. Again, it's kind of limit comparison. All right, let's see this one. What? So, alternating. I like alternating. But then, I have, like, the nth root of n. The nth root of e over n. Well, this is going to get smaller. This is going to get bigger. So, okay, yeah. So, I think alternating series is this. Oh, thanks for the rose.
Bing bang.
The exam is on infinite series. You're very welcome. Yeah. The algorithm knows everything. Yeah, so this is alternating series test. Alternating, or AST. I don't know why I said ASD. Isn't that like a disease? ASD? Asperger's or something? Alternating series test. Because it alternates. And e to the 1 over n over n. Oh, what you can really show here. Here's what you're really supposed to show, sorry. E to the 1 over n plus 1 over n plus 1 is always smaller than e to the 1 over n over n. Good. And then here's another one. This is also alternating. I do have some friends that know about discrete. I can do a little bit of linear algebra. But yeah, definitely submit the screenshot anyways. And if I can't do it, I have a wonderful group of other friends who can. And they will see it in our Discord. So yeah, submit whatever. This is alternating series, but it's greater than 1. So I think this just diverges. And then this one. Ooh, what is this? ln of 2n plus 3 over n plus 1. Well, as n approaches infinity, that goes to the ln of 2, right? So as n approaches infinity, f of n is equal to ln of 2. Yeah, log rules, exactly. Yeah, so this diverges. Okay. But then the other key thing that the person asked this, they asked about conditional convergence, right? Yeah, they said, how do I know? Here, let me just pull the screenshot real quick. How do I know to check for conditional convergence? Correct me if I'm wrong, Zach, but I think this is when the series is alternating, right? And what you want to do is you want to check if the absolute value of f of x, right? Or f of n, or whatever. Also converges. Right, it's when the absolute value, yeah, so, it's when the absolute value diverges, exactly. So, basically, you go look at the things that alternated, which I guess was this one, right? Well, this one we don't care about, because this already didn't converge, so who cares? You only really care about the ones that are alternating and they converged. I can do some linear algebra. This one, I don't think we said was alternating series. We didn't really worry about that, because this whole thing doesn't turn negative anyways, right? It goes from 0 to 2. This one, yes. Oh, this is actually really cool. What's up, Famished? Yeah, so the question is, okay, so if you take the absolute value of this one, that gets rid of this. So I feel like I was going to say the integral test. So consider just e to the 1 over n over n. Does that converge? I'm tempted to do this. And then say that u is equal to 1 over n. Then, well, but du is equal to negative 1 over n squared. Ah, fuck.
Disqualified.
I see the 1 over n. I want it. This shit's above my pay grade. It's okay. If you watch it long enough, it'll become part of your pay grade. I know how to prove this. Okay. 1 over n diverges, and e to the 1 over n is greater than 1 over n. So by limit comparison, this also diverges. Yeah. I'm doing Demi's question, or this is Demi's. I think I'm doing Sealed Universe next. So there's a queue. If you go to the website where you submitted questions, you can see the live queue. All right, so yes, this one right here is conditional. This one is conditional. And then that's the only one you had to worry about because everything else diverges. Okay, cool. Does that make sense, Demi? That's a fun question.
That's dope. Well done.
All right, good job, Demi. That's gonna get added to our Discord. So if you want to like see the solution for that later, make sure to go to the same website, join our Discord, and it's in the homework help channel. For those of you watching on Twitch, you can see me like put it in. There you go. Can you do more converging problems? Submit them. I'll go through them. Let's see what we got next. Next on the queue, sealed universe path integrals. Bruh. Okay. Someone's asked me some tricky ones today. Okay. Consider the propagator for an electron between endpoints t x0 t0 x prime t is equal to a second, where x is the direction perpendicular to the surface of the Earth. Using ideas from the path integral, estimate the distance delta x over which it is safe to neglect the effects of the Earth's gravitational field on the evolution of the electron. I don't know what a propagator is. What is this? I have a PhD in physics, but I don't know what a propagator is. This looks like some like... Alright, when this happens, I'm gonna throw it in a chat. Let's have chat like give me some inspiration at least. Not Connecticut, what? Connecticut? I'm gonna learn with you here. That happens sometimes. Like sometimes I come across questions and I'm like, I don't really know how to do this one. I know path integrals like Green's theorem and stuff is very useful for measuring like potentials. Okay, so it's talking about gravitational potential energy. Yes, because there's the big term, right? There's the big G m1 m2 over r squared. Potential action. Okay, here we go. Ooh, we're talking about action now? Oh. Here, fix the LaTeX. I hate when the LaTeX gets broken. Okay, there we go. I'm gonna try to understand this with you. Okay, so can you solve the Poincare conjecture? I would not be streaming here on TikTok if I could. All right. Gravitational potential energy only matters if changes in the action, if it changes the action by an amount comparable or greater to h bar. I see, because that's the spin of the electron. Oh, on the evolution. Okay, because electrons do spin, right? With what, h bar over 2 or something? Every time I ChatGPT this problem, it bugs out for me. Well, I pay for ChatGPT. Also, I've been vibe coding all day today. I came up with a fun little bot that if we don't get to your question and no one answers it in 2 days in my Discord, we spend money and we go sick the like best version of ChatGPT at your question, and then we post a solution. What's going on, clickbait? Let's fucking go, smart people. Sealed says, no, you need to take into account the acceleration due to gravity in the xt equation, I think. I mean, it's interesting. I don't know what the full propagator is. Well, let's just try to understand what it's saying. So it says action is equal to integral of VDT. Okay, well, I mean, this just tells me change in position or something. I have a PhD in physics. Yeah, but I don't know what this is. My PhD's in plasma physics. Okay. So, for a particle moving from x equals 0 to x prime, the average height, okay, is x prime over 2. So the gravitational contribution to action is, yeah, 1/2. Oh, wait. Oh, this is potential. Oh, potential dt. Oh, okay. It's quantum physics, Feynman's path integral. Yeah. Yeah, see, yeah. Quantum is like the one class that really gave me trouble in grad school. Am I naturally quick at learning math? I can pick stuff up pretty quick, I think, yeah. I mean, it's just practice. I've just seen a lot of it. Math is all pattern recognition and a little bit of inspo. Okay, so this thing's called action. I've never heard of action. I think it is something specific to quantum mechanics. But it looks like it's a time integral of potential, which I guess is something like energy. I got a 30 on this midterm, yeah. Yeah, sealed. My quantum mechanics class in grad school at UCLA, the grading rubric was 90% final, 10% homework. So you can imagine I was shitting bricks during that final when I just saw it and I was like, oh man, this is like Chinese, dude. What's going on here? Okay. All right, so in order to neglect gravity, we need the action on the electron to be less than h bar. I guess that's a thing. So then you get to here. Okay, great. And so that tells you that x, the height it changes, which I guess is the propagator, needs to be less than 2h bar over mgt, where t is the time it takes. Okay. So you know the mass of an electron. You know g. You know t. You plug it in. And this gives you x prime, which that's the maximum height change. Okay, so if you're on the order of microns, then you're okay. Yeah, up to 24 microns, I guess. Okay, cool. Yeah, that's why. Again, I haven't really heard of this action thing. I'm actually gonna ask ChatGPT real quick actually about it. I'm gonna be like, can you briefly explain what action is in this context? I get that we're doing a time integral of potential. Like, change in potential is like power, technically, right? Ding dong.
Bing bong.
It's the sibling to Bing Bong. Says, I have a neuroscience test tomorrow at 3 p.m. Should I do an all-nighter? It's 9 p.m. No, don't do that. All-nighters, trust me, will not serve you well. Oh, action is the integral of the Lagrangian. Very cool. I didn't know that. Says physics. Yeah, it's quantum mechanics. I'm learning alongside. A student asked a pretty advanced quantum mechanics question, and I'm just trying to understand it with them. Okay, the actual path of a particle that makes S stationary. This is Noether's theorem, no? Principle of least action. Oh, man. Make note cards. I would say write things down. If you do things, you'll learn things more rather than just like passively absorbing information. Didn't study? Time to study, bro. All right. Why we integrate? Okay, we're comparing the change in S due to gravity. Okay, why does the h bar come in? So if the action changes by much more than h bar, their phases vary rapidly. Oh, this is very cool. You know, here there's some Zach in here, dude. There's some e to the 2i pi here. Look at this. Because they say that the amplitude are proportional to e to the s over h bar. Okay. So if this, right, is on order h bar, then you start flipping things like completely by like 90 degrees, 180 degrees, right? Oh, that's very cool. Okay. So I think, you know, going forward in your test, knowing that action is the integral of the Lagrangian, and in this case, we're not talking about any sort of kinetic energy. I think we said just strictly due to the gravitational field. So you're just integrating the potential in the Lagrangian, and then you need that action to be on order H bar, and then you just solve for what that distance X would be. Given that the potential is okay, dependent on the height X. Okay, cool. This is quantum mechanics. But anyways, cool question. I appreciate it, Sealed. I can definitely do interpolation, yeah, for sure. Alright, so I'm going to download this for you, Sealed, and I'll post it in our Discord as well, so you at least have a copy of it. Yo, what's up? Justin, what's cracking, dude?
Playing Fortnite right now. That's what's cracking.
We're 1 hour into our 10-hour live stream.
Jesus fuck, you're doing 10 hours?
Yeah,
oh my, honestly, I'd go fucking mental. I'm sorry, man.
We're gonna see how crazy I go.
You crazy? I was crazy. I'm gonna shut up.
Let's see how crazy we go, dude. I'm at the first.
Man, you should totally, like, in the middle of, like, the entirety of the, like, you know, you just, like, play Fortnite or something.
No, dude. I'm not doing... Dude, some people do cheat on those, like, subathon things. Like, they go to sleep. I'm like, bro, that's cheating. What? You're not streaming if you're sleeping.
Yeah, the subathon thing, I feel like they should, like, pause the timer or some shit when they fall asleep.
Yeah. JC
so,
says,
like, it doesn't count.
Am I gonna eat? Yeah, I kind of fucked up on that one. I forgot to, like, make easy to eat food. I kind of screwed up on that.
You should, like, I don't know.
I should give people I'll give people my address and they can DoorDash me things.
Yeah, just send me your address. I'll DoorDash you like 20 pounds worth of McDonald's where you should be chilling.
All right, let's see. Next one is Ruxa. Ruxa says, yeah, send me your Addy dog. Oh, I like this. Here we go. This is cool. Some Delta HVAP. Bro's gonna starve. I'm fine. I can make it. Oh, we got our first requirement from TikTok to make sure we're human, and we are. All right, Rooks, here you go. We got some chem coming up for you. In one box, there are 75 iron nails. Wait, dude, why is this in pounds? God damn it. Are you sure you're a human? I don't know, blink twice. Blink twice if you're human. Why pounds? All right, we got some densities. Cool. If 30 nails are added to a graduated cylinder with 17... Oh, God, no, come back. God damn it. Okay, with 17.6 milliliters of water, what is the new level of water in the cylinder? I'm assuming... Wait, has stuff evaporated, though? Is this, like, instantly when I put it in? Okay, and then we talk about... Okay, so I don't think they're being too complicated, because I was wondering if these nails are, like, instantly going to evaporate some of the water, and then I got to calculate some new stuff. Just pretend every law doesn't exist. Okay. Well, 17.6 milliliters of water, that's the same as, like, a volume, right? So this is... So what we learn here, right? And I think, yeah, see, 1 milliliter is 1 centimeter cubed. So this is 17.6 centimeters cubed of H2O. So we just got to figure out how much volume gets added from the 30 nails, right? So I'm going to say, question mark, how many centimeters cubed? What is this syntax? Google Docs. How many centimeters cubed is equal to 30 nails? And then we're going to use these conversion factors to do like some stoichiometry, right? So every 1 nail... Oh, actually, no. So for every 75 nails, that gets us 0.250 pounds. And then for every 1 pound, I get 454 grams. And then for every 7.86 grams, I get 1 centimeter cubed. Yeah. So these are all conversion factors, right? So This tells me, for instance, you know, 7.86 grams in 1 centimeter cubed. That's a conversion factor. Notice I flipped it, though, because I need grams to cancel with grams. Here, I need pounds cancel with pounds, nails cancel with nails, and we're left with centimeters cubed. Following so far, Rooksa? All right, good. Awesome. All right, so we can then do some math here. I can try to help with fluid mechanics. If it's too tough, it'll just get added to my Discord, and I have other friends that do engineering stuff. They can maybe help you solve it. And if that doesn't work, we will use our recently developed bot to sick, like, really powerful AI at it. But I only have that hit after 2 days. So if you need the answer now, you're not going to get it. But if you're cool waiting for 2 days, yeah, that's fine. Okay, 75 times 7.86. Okay, cool. So that's 5.78 centimeters cubed. 5.78 centimeters cubed. All right. So the new level of the water. This is the same thing. This is called like bro, programs on this are so OP. Yeah. The new level of water is called like volumetric technique of like measuring like volume, I guess. Well, I call it the water displacement method. It's called the water displacement method. So we're gonna do this plus 5.78 centimeters, which is basically 5.8. So that's gonna be 23.4 centimeters cubed, which is equal to 23.4 milliliters in the cylinder. Nice.
My man.
Does that make sense, Rooksa? Why you would see 23.4 centimeters? It's actually a really cool thing in chem. You learn about this. If you have like a water level of a certain amount of stuff, and then you drop like another object in it, like say you drop this thing in here, the amount of space it takes up will then raise the water level up. And so if you look at the difference in the water level from like before you put the thing in until like after you put the thing in, and you calculate that volume change of the water, that's the amount of volume that's taken up by the thing. Yeah, it's lit. Yeah, they do this actually to weigh people or things that they can't put on scales. So if things are like really heavy or you know, bulky and they can't really put it on a scale, they just put it in a massive fucking tank of water and they see how much the water level goes up. Like a whale. Exactly, yeah. Yeah. I think they probably do this also with I want to say like boats. When they talk about like displacement of boats, I think they just put the boats in like massive pools and just see like how much does the water go up. Yeah. It's called the water displacement method. That's what it's called. Good job. Okay. How much heat in joules must be added to the nails in the box to raise the temp from 16 degrees to 125? Okay, so this is Q equals MCAT, right? So Q equals MC delta T. The mass. So we already got the mass, right? What was the mass? Oh, we didn't actually get the mass. Oh, we did get the mass. Well, the mass is up to here. Oh, wait, and it's only 30 nails, right? Oh, wait, no. It's 75. Sorry, the whole box is 75 nails. Okay. All right, so we have to know, like, how many, and then specific heat's giving in joules per gram, fine. So how many grams is equal to 1 box of nails? So then 1 box, 75 nails, and then oh, actually, we already know this, right? Sorry, 1 box of nails is already 0.250. So actually, I can just do this, sorry. 1 box of nails is there's a website down there. Shishagapam. I can't pronounce your name, I'm sorry. Actualofficehours.com. Just submit it. I'll do it. 1 pound is 454 grams. Okay, cool. So there we get that answer. So actually, if I took my 5.78, and I think if I just divided by this, we would have been okay. Yeah, let's just do that. Let's just do that. Divided by 7.86. Okay, so you have 0.7 0.73. Wait, that actually sounds kind of... Wait, what? Wait, 0.25? That sounds wrong, sorry. 0.250. Sorry, I need to multiply it by 7.86. Okay. This is why... Uh-oh, making mistakes. Uh-oh, no. We're only an hour and a half in. I can't be making mistakes. All right, 0.250 times 454 is 113.5 grams. I can do Diffie Q, yeah, for sure. Okay. So you have 113.5 grams. The specific heat of the nails is 2260. And then delta T is going to be T final minus T initial, so that's 125 minus 16. Make sure it's in Kelvin, but centigrade is okay for differences. Okay, cool. So then we just do this. Minus 16. Nice. Oh, that's huge. Let me divide that by 1,000,000. Okay, so you can say 27.96 megajoules. Well, that seems like a lot. I guess you are like dumping. Dude, a megajoule? That's a ton of energy, dude. Wait, what? 113.5 grams, yeah. Oh, that's delta HVAP. Oh, I fucked up. Sorry. 0.452. I was like, yo, what? That megajoule? Dude, that's like TNT. That's explosive amounts of energy. Right. HVAP is needed to figure out like when the water evaporates and stuff. Yeah, I was like, and also this is a very important thing. When you're doing questions, try to take a second to just consider your answer and whether it makes sense. Like a megajoule is a ton of energy. I'm pretty sure a megajoule is a stick of dynamite. So notice how like I did that. Like I was doing the question. I was pretty sure that number was ridiculous. So then you go back and see if you made a mistake. And I did. I used the wrong number. So 125 minus 16. No, dude, the nails do not change. There's no way what? The nails would need insane temperatures to change states. Okay, that's much better. 5592. Yeah, JC says, yeah, dynamite's like a megajoule. Yeah, I was like, bro, it's like 20. What? Gonna blow up the fucking nails. Yeah, so this stuff here is needed if you're trying to figure out if the water will evaporate. Damn, Mucker, what is that chemical compound? Yeah. I think if there's a further question, they might be asking about if the water evaporates and stuff, but for now, they just want to know how much heat do you have to add to the box, and it's that. Cool. Does it make sense where we're on? A little bit more sense? Yeah. Well, if you got more, submit them. I might do them. We only got six in the queue so far, so if that queue goes down. CP or CV? Depends if things are at constant pressure, constant volume. I think I'm more of a CV enjoyer. Yeah, CV. All right, let's save this. Cool. All right, what do we got next? Eric. Ooh, the pulleys. I do like these. These are fun. Maria, you were asking about friction and forces, right? Eric S. I think this is I forget who is Eric. Who is Eric in my Discord? I think this is Mucker. Mucker, is this yours? I think this is yours. ChatGPT completely agrees with me. Nice.
Nice.
Love that. Okay, No, you're okay. No rushing. Okay, block A of mass 2m naught, blah, 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 are on a string. Okay, frictional forces. What is the acceleration of block A after it's released from rest? Oh, this is actually really cool. So we're going to draw force diagrams on everything. All right? So, and this is the key thing. I do everything math and science from middle school up through college. You have to always think about what are the forces acting on the object directly, not what forces like indirectly through another thing or what forces it's acting on other things. So for block A here, this one just has tension. Wait, why can't I draw my tension? There we go. We're gonna call like, you know, fuck this. I just want the image. There we go. Okay. This one has tension pulling on it to the right. And that's it. Okay, that's all for block A. Oh, okay. Now. Ugh. Where'd all my windows go? Okay, there we go. Sorry, one sec. All right. Whose notification? Oh, did someone is there a name notification in it? Oh, they're number 4. Why is it going to S? My keyboard's doing weird things. One second. Okay. I was getting like some phantom clicks. It's annoying. How long am I live for? 8 hours and 40 more minutes. We're doing a 10-hour stream today to celebrate 10K subscribers on YouTube. Okay, sorry. Block A has tension pulling to the right. Block B is going to have that same tension pulling it to the left. Let's call this like T1. Is it still? Wait, what the hell? One sec. Am I getting key presses? Isn't tension the same on box A and box B? Yeah, those tensions are the same, but then there's a new tension, right? Because now we have this tension here, which we can call T2, and that is gonna be the same tension on this end. So tension in ropes is the same amount, but in like opposite directions on opposite ends. And this is gonna be like T2. What is going on here? Oh, one sec. I just gotta redraw this. My mouse is like fucking up, like hard. Oh, whoa, it's still doing it. What the fuck? Okay, one sec. I gotta fix this. It's my Wacom centers. I'm screwing up. Where is Wacom? Wacom. Where'd you go? Wacom. Pedal, Stream Deck. Yeah, there we go. Let me turn this off. Disabled. Okay, now this should work. Okay. Yeah, I've been using my pen for like so many years now. Like one of the buttons was causing another key press to happen. It was throwing me off. I couldn't like write anything. Time to update. Yeah, it's this pen. I need a new pen. Okay. T2 points this way. T2 points this way on this one. And then also on this block, you have the force of gravity. Great. All right. I like to always, we're finding the tension. We're finding the acceleration in block A. So, what you can do is you can write out some of the forces for all the different blocks. So let's look at block A. There is no friction. Pretty easy. So block A, and then always I like to define a general movement for where things are going. So in this case, I feel like the whole system is going to fall down, right? Because this is heavy. There's no friction keeping these things up. So I'm going to call this direction positive and this direction negative. So any movement in the Y direction here corresponds to movement in the X direction here. But more importantly, this is plus, this is minus. So then for here, this is plus, this is minus. And then for here, this is plus, this is minus. You have to get, the sign conventions are actually important here. All right. So for block A, you have the sum of forces, which is just going to be equal to the mass of block A times its acceleration. So 2m naught A. That's just equal to T1. For block B, we got some different stuff going on here, right? You have the sum of forces is equal to m naught A, because this only has mass m naught, and that's equal to this minus this. That's equal to T2 minus T1. And then finally on this one, block 3, we have the sum of forces is equal to m naught A, and that's going to be equal to Fg, or sorry, this is 2m naught, right? Because this one weighs 2m naught. Fg minus T2. Block. There we go, block 3. All right. Or I said A, B. Sorry, this is block C then. Let's call it block C. I don't know why I call it 3. Block. All right. So, also, I know the force of gravity acting on this thing is 2m naught G. Okay, so now I have 2m naught A is equal to 2m naught G minus T2. All right. The other key thing here is that if all these things are attached by ropes and the ropes are tight, like they're not loose, then the accelerations for all of them are also the same. So, for instance, this acceleration is A, this acceleration is A, and this thing is also accelerating at A. This was on my FRQ, and you actually passed it? Nice. The algorithm knows, dude. Okay. So from this, just like right off the rip, dude, if you divide by 2m naught, you get A is equal to G minus T2 over 2m naught. Right? If I divide this on both sides. Is that one of the answer choices? Let me see. Or was it? It was this question. Oh, so they want to know actually with G. Okay, so we'll be able to solve it. So watch. This is high school physics. Okay, so from this, right? Watch here. I can say, okay, well, T2 is equal to m naught A plus T1, right? If I rearrange this over here. And then also from here, right, we know that T1 is equal to 2m naught A. So that can come into here. So now T2 is equal to m naught A plus 2m naught A. So that's equal to 3 m naught A's. And so let's plug that into here. And actually, I'm not gonna divide yet. I'm gonna put that into here. So now you have 2m naught A equal to 2m naught G minus 3m naught A. Notice how all the m naughts are going to cancel. That goes away, that goes away, that goes away. And then if we move this to the other side, you're going to get that 5A is equal to 2G. So A is equal to 2/5 G, which was the correct answer. Correct answer was D. Nice. Good job.
Well done! Well done!
Fun question, Eric. All right, Eric. Let's post it. You're 10 years late for my math diploma? I'm sorry, dude. You know, they say the best time to plant a tree was 40 years ago. The second best time is today. We love it. Oh, why is my YouTube chat not working? Oh, there you go. It's okay. All right. Yes, I use a lot of ChatGPT. ChatGPT is great for checking answers and stuff. I'm a big fan of ChatGPT. I did not use ChatGPT for this. This was easy. I don't need ChatGPT for this. But some of them I definitely do need ChatGPT for like inspiration. Okay, this was Eric's. So Eric's is gonna go. How do you become comfortable with these types of questions? I have an exam on forces tomorrow. Like most things, we're comfortable with what we're familiar with, right? So if you want to get better at doing force questions, do more force questions. I know, but sometimes you're kind of crunched for time. You're like, I don't really know if I have much more time left. In general, I think being very confident with the method you use. So whenever you have questions with like forces and stuff, you can almost mechanically do these problems by just isolating each individual object and drawing the forces acting on that object. It should always be like, figure out what your objects are, write out the force diagrams, and then write out Newton's second law, whatever. I forget which one it is. The F equals ma. And then from there, it's math. I think the thing that scares students the most is probably the setup with physics, because you do have to kind of have like a little bit of an intuition to it. But if you just mechanically like set up force diagrams, only consider forces that are acting on the objects, not forces that are acting from the object onto other things, then you'll be good. Yeah, funny guy says practicing at math does not work for you. Well, what are you getting stuck on? I say, like, if math is giving you a hard time and practice isn't working, then it means the type of practice you're doing isn't working, which to me would indicate that maybe the practice is not addressing like core foundational things that you don't completely understand. So math is very, like, it builds on itself. And if you had, like, I don't know, a shitty teacher, or like tried learning math during COVID, you probably didn't grasp completely some very core subjects that are needed to learn more advanced subjects. So I would say maybe make sure you know the foundational stuff first. Okay, he says, I understand the theory, but I practice so hard I cannot apply what I know. So applying what you know is pattern recognition. So you just got to get better at noticing that, hey, this question looks like another question I've done, and the technique I did for that was this. And that should help you with doing things that you don't like. I say you should never walk into a question having zero clue how to do it. I do sometimes, because some of you guys submit some real like math warrior questions for me to do. And there is like kind of a strat to being able to figure those out. But for classes and whatnot, you should always have some idea of how to solve a question. Otherwise, your teacher sucks. No. And they're just asking ridiculous things that, you know. Yeah, I was learning this through COVID. Yeah, it's difficult through COVID. Do I do OChem? I have a friend that does OChem. And they're probably still here on my stream. So, yeah, submit an OChem question. I'll try to do it. Oh, okay, here we go. Any sources you suggest or like AIs to get better? Khan Academy has a lot of good practice questions. The Organic Chemistry Tutor has a lot of great videos. But in general, just doing questions and then using AI to check your solutions. And then sometimes being critical of the AI if it's wrong. Because it does make mistakes. It depends on the type of math you're doing. But yeah, that's... I would say if you're not able to do questions, try to ask yourself like why you couldn't. Like what part did you not get? What part was not clear to you? Okay, at 200 Kelvin, which of these two is most efficient, generates the most pressure? Oh, is this Le Chatelier's principle? I studied plasma physics. And at what temperature would the least efficient one have to be to generate as much pressure? I think this is Le Chatelier's, right? So, you look at which one has more moles of gas, right? Yeah, okay. So, like, here, let me pull up just the diagram. I could remember it off the top of my head. It's like, more moles means that increasing the pressure shifts the equation to the other direction. Yeah, it's Le Chatelier's. Here we go. And I need it with pressure. There you go. Yeah, Le Chatelier's principle. Although these aren't equilibriums, sorry. Okay, well then this is probably a PV equals nRT. So this goes from 27 moles of gas. So this one goes from like 27 to 34, right? This one goes from 7 to 6. So I already think this generates more pressure, right? Because you create more moles of gas. You don't really care about the size of the particles, honestly. It's like the number that are there. So, I don't know. I'm tempted to say that this one is the most efficient. 6, 7. God damn it. No, you made me sad, dude. Germ. Good, and JC, our chem expert, says that octane is a liquid and water is ice at that temperature. Oh. Well, this is combustion, no, right? We're like burning octane. So I think burning octane is pretty efficient. Or this is burning ethane, right? Oh, you go from 25 to 16. Oh, ooh. Wait. Great intuition here. Because, yeah, I didn't recognize that C8H18 is octane. Octane is gas. Gasoline. Which is usually in its liquid state. It definitely gets, like, kind of vaporized through, like, what are called, like, injection. Fuel injectors and stuff, carburetors, in order to ignite. Oh, Professor Leonard. Yeah, again, there's so many resources on the internet. Like this. This is also a resource. We need help. We'll be here for the next 8.5 hours. Okay, so this goes from 25 to 34. So wait, JC, why'd you say 16? The H2O is a liquid? Oh, I guess it is. Okay, it's 25 to 16. Okay. So then this one's the most efficient, right? Because you get the most pressure out of it, I guess. And then, I don't know about temperature. I don't know how you're supposed to burn things at 73 degrees, but yeah. Yes. I'm pretty sure this is also... Oh, okay, so this is 7 to 4 then. Yeah, sorry. You're right, Star. Yeah, here we go. Gas, 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 liquid. Liquid, gas, gas, liquid. This is 25 to 16. This is 7 to 4. So if we try to put them in like even fractions, that's gonna be 28 to 16. Oh, so wait, this one is more efficient again. Oh man, we're going back and forth a lot. Okay, so this is most. And then what temperature would it have to be to generate as much? Well, PV equals nRT. You assume the volumes are the same. Assume the R is the same. The N is not, right? So P is proportional to NT. So if you're deficient in moles, you need to make up for it in temperature. So, what? I need to be 3 out of 28 more efficient to get to 25/16? That's my guess. My guess is this is like 3/28 times T. Has to be equal to 1. So 28 thirds in Kelvin. Oh, but that's like, ooh, that's not good. Oh, but it's at 200. Sorry. So it's like 200. And then this is like 200 plus delta T. Oh, okay. Okay, wait. So like 200 N. Or this is what I want to say. Sorry. 200 times 6 times 25, because that's the NT for this one, has to be equal to the same pressure as using 28 over 200 plus delta T. Right? No. I have it flipped. Because then that means delta T is less. Ugh, I'm close. What's the difference between mass and weight? What's up, Maria?
My man.
Weight is a force. So weight takes into account what the force of gravity is on you. So weight is equal to mass times gravity, whereas mass is just mass. My man.
Bing bong.
Nice.
I don't know. It just says different things. Let's see what chat says about this one. Again, we have a little bit of debate in my we have debate in my chat. So I'm gonna ask the ultimate ChatGPT what it thinks. Or is it this one? Yeah. Well, I think he's also like trying to remember the question. This is also why screenshots are important, because sometimes we like misremember things. Why are we burning stuff at negative 73 degrees Celsius? I agree. Why would we do that? Maria says, I actually love physics. My teacher did the dishes. The dishes and tablecloth thing. I thought you said your teacher did the dishes. I was like, yo, nice teacher, dude. What? No, did the dishes and tablecloth thing today. It's so fun. Yeah, that's a really cool demo. Where he yanks the tablecloth and the dishes stay down. Oh, interesting. So we have to analyze the behavior of CO2 at 200 degrees Kelvin. CO2 might actually be a liquid at this point. I did solve some kinematics and dynamics yesterday. I definitely did. Okay. Oh, interesting. They kind of had a similar thing. So here, let's try to analyze this. This is chemistry. Yeah, someone's asking about chemistry. So let's see what they said. All right. I agreed that the octane made more pressure, right? Because this made 25 for every 25 moles. It made 16. This one only made 4 for every 7. Right? And they said at 200K, H2O condenses. Right? So this is a liquid. So the final moles you make are 16. It's actually interesting. They don't even consider the amount of moles you start with. They just talk about like a single reaction. JC says worst question ever, dude.
No, God!
Okay. This is cool. No, I kind of get this. So they're saying that octane is more efficient because it makes 4 times the amount of gas. And then, remember how I talked about this, right? P is proportional to NT. So if you need to make 4 times as much gas, you need 4 times the temperature. So, but then here's the tricky thing. Now H2O stays a vapor once you're above 200K. So you say you're making 6 moles of gas. This is fascinating, dude. N1T equals N1T1. So 16 times 200 equals 6 times T. Yeah, maybe. That would make more sense. And so, yes, this is 533 Kelvin. Okay. We had the right track. It's just, yeah, it's worded kind of poorly. Anyways. Okay. Hope it makes sense to you. Yep. Whose question was that? Star. Yeah, we think your teacher probably made a little oopsies typo. Mark is done. And let's go in the Discord. Yeah, maybe. Yeah. People make mistakes. I mean, I make mistakes all the time. Disno said biochem major looked right to me. Okay. Biochem says yeah. Ooh, we're gonna do some circuits. I fucking love circuits. Nice. Where's the image? So Star, if you go into our Discord under help screenshots here, you'll see your question got posted here. And then the solution that we got is right here. Cool. Good. Glad you found it. Okay, find the current in each resistor shown. Draw the circuit diagram with the correct magnitudes and directions. Assign V equals 0 to point C. And then label the potentials at each other point through F. Okay. So they want to call this 0? Ugh, alright, fine. Right off the bat, I'm just gonna write this as a single resistor. I really don't care that it's in parallel. Just makes life easier. We're gonna say that this is 1/3 plus 1/6, all to the -1. So that's just equal to 2. Right? Because that's, no. Yes. Yeah, 2/6 plus 1/6 is 3/6 divided by 2, 6/3, which is equal to 2. Oh, your name is Eric as well, Servo, so I didn't know that. Okay. So this is 2 ohms right here. All right. What makes this tricky is you have 2 battery systems. Your electrical engineering, this definitely applies to you. Yeah. I would definitely watch this. Okay, we're going to do a couple loops. I'm going to do... And here, I'm going to call this, like, RDE. We'll deal with it later. Okay. So if I start here at 0 volts and I go across the battery, I'm going to pick up 21 volts. So let's make some loops here. So let's call this a loop. And so I'm going to define current to be in this direction for RC. All right, cool. Let's see if we can all do it. All right. So if I start here at 0 and I go across that's 21 volts. Okay. Then I'm going to drop. Oh, we got to come up with currents. Oh, fuck. All right. All right. I'm going to call this equal to I1. Right. So this is also equal to I1 since they're all in the same series. I'm going to call this I2, which is going up that way. You're way better at explaining than my calc teacher. Oh, I appreciate that. Thanks, Nox. I appreciate that, dude. Okay. And then that means we're going to call this probably I3. And I think that's good because that covers the current here. We got the current here, and then we got the current here. All right, nice. Okay, so I got 21 minus IR of this. So that's going to be minus I1 times 2. Okay. And then minus I2 times 6. And then minus I1 times 3. And then this is all equal to 0, right? That's called a Kirchhoff voltage law loop. We did a Kirchhoff loop. That's what we did. Yeah, it's okay, dude. All right, so then let's go around here, right? So if we do this loop, okay, I'm going to first drop 18 volts. Then I'm going to drop 12i3. And then here's where things get a little tricky, okay? Because as I come across here, right, I'm now going in the opposite direction of what I'm calling current for I2. So that's going to be plus, not minus, plus I2 times 6. And then this is all equal to 0. I think that's correct. I always forget like how you share the currents here. I like just calling it like a single thing, and then it's minus on one and it's plus on the other. All right. So we got 3 unknowns: I1, I2, I3. But then I can use a juncture law to figure out I1, I2, and I3, which here. So we're going to use Kirchhoff's juncture law. So here, I have I3 pointing in. I have I2 pointing in. And I have I1 pointing out, right? So current in must equal current out. So we're going to say I1 must be equal to I2 plus I3. Nice. All right. Yes, seek the knowledge. You guys got it. Seek the knowledge. Okay. How do you remember all the steps? I just keep doing it a lot, I guess. I've been doing this for almost 20 years. So it's like you remember your name, right? Because you say your name all the time. Yeah. I guess that's how kind of I would see it. Do you do kinematics and dynamics? I do. Yeah, I definitely do. Okay. Let's see. So now this is a systems of equations because I have 3 things I don't know: I1, I2, I3, but I do have 3 equations. So what I'm going to do is I'm going to set up some matrices for things. So let's try to group some terms. So this is negative. Well, actually, these are all negative. So let me move them all over, make them positive. So I'm going to say 2i1 plus 6i2 plus 3. Oh, wait. Minus 2i1 and minus 3i1. That's going to be minus 5, so this is going to be 5i1. 5i1 plus 6i2 plus 0i3 is going to be equal to 21. All right, then let's look at this one. This is going to be 0i1 plus 6i2 minus 12i3 is equal to negative 18. Wow, Fembox got them all the way. You got them all already, dude. Wow. Thanks, Fem. The solutions manual, dude. And then this is 1i1 minus 1i2 minus 1i3 is equal to 0. Cool. In matrix form, right? This is going to look like this. 5, 6, 0, 21. 0, 6, negative 12, negative 18. 1, negative 1, negative 1, 0. Oh, I'm sorry, dude. Well, keep watching. You might learn some future stuff. I can help you out with quadratics. I am unk enough to help out with quadratics. This is circuits. We're doing a circuits question. This is a circuits question. Circuits question. If you want to be an electrical engineer, that's what you got to do. Do I want to do this by hand? I feel like I don't. I mean, it's kind of close, though. Right? It doesn't look that bad. Does it? That website, actualofficehours.com. And also, weren't your voltages were kind of nice, right? Yeah, alright. So let's rearrange this matrix. I think I can do this. I don't think it's too bad. Let's move this over here. We're not doing mesh analysis. No, I know. I'm just doing Kirchhoff. I forget how mesh analysis works. Okay, because this is like the new matrix, and then my goal is to like get 1 0 0 0 1 0 0 0 1. So I think I'm gonna do. Oh, this is gonna get messy, right? Oh, yeah. Well. Yeah. Yeah. Nah, fuck this. I'm gonna do this in the calculator. I thought this might be a nice. I thought some things might cancel, but they're not. Okay, so we're gonna go to the TI-84. So second matrix. We're gonna create a matrix. We're gonna make it a 3 by 4. We're gonna put some numbers in. So 1, negative 1, negative 1, 0, 0. The linear algebra stream. W linear algebra, yeah. Negative 18. Good. Then 5, 6, 0, 21. Cool. And then we're just going to go second matrix, and we're just going to tell it to RREF. And that just solves it for us. Super handy. There we go. Those are nice numbers. So you can say to your teacher, you can be like doing some linear algebra magic or really RREF. No, for anything math or science. You get this. Okay, so this is cool. This tells me that I1 is equal to 3, I2 is equal to 1, and then I3 is equal to 2. You aren't allowed to take linear algebra and then they tell you to do it? Dude, I hate that. It's like, bro, this is like such a beautiful tool. Why would you make me like dig in the trenches? Get out! All right. So I think we found the current in all the resistors, right? Great. You just assign like which resistor to which current. I did account for rearranging, yeah. Yeah, so this tells me since I2 is positive, that tells me the current actually does run this way. Okay, so RA, well, we have RB, RC, RD. Oh, and actually RD and RE are going to be a little bit tricky. RE. And then here, let's talk about like the current and the voltage on everything, right? So the current on resistor A is going to be the same as I3, so that was 2. The current on resistor B is the same as I1. I1 was 3. Resistor C was I2, and that was 1. Alright, and D and E are a little tricky. So across the whole thing, you needed to have a drop of 2, okay? But then the ratios of it are, one is 3 ohms, one is 6 ohms. So this one's going to have twice as much current in it as this one. I cover everything math, science, up middle school through college. So I need like 2x plus x to equal to 2. So what is that? X equals 2/3 then, right? So 2/3 and 4/3. So I think RD is going to have 4/3 of an amp, and then RE will have 2/3. Cool? No, this is college for sure. Okay, so we got the current, we got that. Okay, let's get all the voltages. Okay. So you can actually do this like going across the path, right? If this is 0, right? By the time we get to D, we've gained 21 volts, right? So let's just do this. So how A B C D E F, A B C D E F. Okay. So at D should be equal to 21. And then we go across E. Ooh, topology, maybe not so much. Topology's a little tough. But I do have a lot of awesome friends who stream like higher level math and science. And so if you submit the question, it'll get forwarded to them. Yeah, again, for everyone who's watching, if you want to submit a question to our queue, we're doing a 10-hour celebration stream for getting 10K subs on YouTube. So I'll be on for the next 8 hours just answering questions. You go to this website, actualofficehours.com, drag your screenshot in, put your username. Also, you can check out the streaming schedule. If you check out the streaming schedule, you can see who else streams. And so we have a lot of other really awesome people who stream like free help in math and science. So go check them out. They're on the calendar here. Zach is who I would think you should go to if you want to ask about topology maybe, or like some high-end math stuff. I got ID equals 2 and IE equals 1. Oh, yeah, I'm dumb, sorry. Yeah. Wait, because I1... Oh, because I1 is 3. Sorry, I thought I1 was equal to 2. You're right. You are right. Thank you, Fem. This is 2, this is 1. Great. Okay, there we go. Okay, so we're at 21 volts. And then we drop across RDE. So the voltage drop across here has to be the current times the resistance. And the current in I1 was 3. So 3 times 2 is 6. So I think at E you should have 15. Right? Yeah, 15 volts at E. Okay. And then you go across to B. So B, you're going to drop another RC I2. I2 is 1. RC was 6. You can drop another 6 volts. So B should be at 9. I think we're matching up, Fembox, so far, yeah. And then C is 0, obviously, right? Yeah, if we're measuring 0 here, the voltage there is 0. Okay, very cool. Interesting at A, though. Oh. I can definitely help with physics. Gold, did high school seem easy to you, like it was understandable and quick to comprehend? I mean, some of it did. Yeah. Some of it definitely didn't. I couldn't, like, figure out how to make my English teacher happy for, like, what... She just didn't like any of my stuff. Yes. No, we can definitely help with complex analysis, for sure. I have friends, like, that can definitely help out with complex. Like, one of the streamers has literally taught a complex analysis class. Okay, fam, I'm just curious how you get A and F. Do I have to, like, start here and start going this way? Like, do I start going backwards? So if I'm at 0, then I gain, right? 3 I1. So I gain 9 volts to get to B. Oh, actually, F is connected to E with a wire. Oh.
That's dope.
You're so right. Yeah. If these things have nothing in between them, then they're at the same potential. Oh, that's beautiful, Fem. Right, this is 15 volts. And then B, I already know, is at 9 volts, right? And then I know how much voltage drop needs to occur here. It's 12 times I3. So 24 volts has to drop there. So 24 down to 9 means this must be 33. Oh, fucking sick. Did someone say complex analysis? What's up, Penn Center? Yeah, shout out to Penn. Penn Center ran the class on complex analysis. That's who it was. Dude, I'm excited for your podcast tomorrow. That'll be super fun. Yeah, I was telling people on TikTok, because we have quite a few people. We got 40 people on TikTok watching. To go check out the calendar, because yes, Penn Center has a special event, Beyond the Blackboard, where I think him and Zach are going to talk about math, education, and like funny dad jokes. So I might be sleeping, Penn, because I end my stream at like 2 or 3 a.m. But I'll definitely come by for at least the halfway point. Yeah, for sure, Soggy. Yeah, we do a lot of shit. Yeah, and I'm not alone. It's not just me. We have a lot of other people that do this. I just don't think people know about it. So, hence I'm doing an 8-hour stream today to kind of celebrate it. Or a 10-hour stream, sorry. We're only 2 hours in. Okay, great. This was a fun question. Whose was this? Thanks, Harnon. Was this Barry? This was Barry. Good job, Barry. Good job, Barry. Gatekeep this, please? No, dude. No. Bro, you know, there's an infinite supply of viewers that need help with homework. Infinite supply. So I would welcome more streamers for sure. All right. This will go into our Discord. So Barry, if you're watching, the same link you used to upload the photo, there's a link to our Discord, and I'll also post the download of what this was. Yeah. Gold, do you only do science that has math in it? Doesn't all science have math in it? What science doesn't have math in it? I generally help out with math-based sciences. Do you only eat tacos that have cats in them? Okay. All right, let's see. Notification. This is fun. Dun, dun. Not my LinkedIn. Why does it keep pulling my LinkedIn? Not this, not this. There we go. Okay. These are apparently Science Olympiad questions. Okay, so I'm going to try them. Teacher, I have a crush on you. Ooh. Ooh. My voice is going to be gone by the end of this stream. I won't be able to do it. Yeah, no. I mean, yeah, I can help you out with mitosis and stuff. It's fine. Okay. Let me do part A. Let's do the first one. I think I can do this one. I have degrees in physics. I have a PhD in physics. Half the length of a 1 meter rope is stretched out in a straight line on a frictionless table. The other half hangs vertically. The rope is released from rest. Calculate the speed of the rope as it leaves the table. It's kind of cool. This is kind of a thinker question for sure. Because like only half of it is subject to the force, but then that's changing. It's really cool actually. Are you running on caffeine? I'm about to go get some caffeine. We're okay. We're only... Dude, this is light work. We're only at 2 hours. This is fine. Only got 8 to go. Are they in chat? Yeah, if you're in chat, if this was your question, Math Olympiad person or Physics Olympiad, please let me know. Everyone in caffeine is running on everyone in academia is running on caffeine and hate.
Bing bong. That's dope.
Yeah, probably. You're not wrong. Especially these days, dude, with like how bad funding is. Yeah. Taco Cat says, good question. What is the plan once I start getting 15 or 30 people asking more? Well, the queue caps out at 20. People have to wait once it hits 20. Get more streamers. And also, Taco Cat, I did introduce... So, I've been vibe coding. I love vibe coding. For the last couple days. I created a new bot in our Discord. So, what happens is... This is the big forum where... and here, I can probably... Can I show this to you guys on Discord? Yeah, here, let me show this on TikTok as well so you guys can see. Okay. So, if you join our Discord, there is a channel here called Homework Help. And this is where all the questions that get done get posted, all right? And also, I will post a solution. So, for instance, here's like the whiteboard solution of like what we did for this one. And sometimes the queue gets so long that I don't have time to go through everyone's questions. When that happens, and I have to leave, I hit a button on the queue, and that pipes all the questions back in here to the Discord, but we'll give them the tag of like unsolved is what it'll do. And what that is that's an opportunity for other people to come in and like solve problems if they want to. But I also understand. So yeah, I have a wonderful group of friends. I call them my actual educators, and they also do streams, or they just help out in general. So they may answer your question here if I'm not doing it during the stream because I'm sleeping. But in the case that they don't, I built a bot such that if 2 days elapse and nobody has answered your question yet, then our bot will go through and use GPT-5 to go solve it. So for instance, this question didn't get answered. It was back from like October 26th. And so I vibe coded a bot here that goes through and solves it and then prints up a beautiful like latex screenshot of like what the solution is. So that's kind of my plan for like what happens when we start getting too many people, is that like it'll get funneled into my Discord. We recruit more people to help out after hours or run their own streams. And then in the worst case scenario, you wait 2 days. It's like a waiting period. And then you'll get the solution. Yeah. And I did that all on vibes. This is all vibe coded. Okay, but let's do this one. I can't do Harvard math. Harvard Snavid. No. Yeah. Okay, calculate the speed of the rope as it leaves the table. So I'm tempted to do conservation of energy here, right? I think I want to do conservation of energy. Oh boy, I have a lot to do. Yeah, the remedial math course. Get bent. Okay. We know this is equal to L over 2, right? I think I want to define H equal to 0 here. And then I have to probably do like some center of mass argument. I'm gonna say this is H is equal to 0. I think I want to do I think I do want to do conservation of energy. Right? So, E before. And let's say this has some linear mass density. Lambda, right? I do have to say it has lambda, right? So let's say mass density. Yeah, exactly. Yeah, no, it's super cool, Femvox. Like, vibe coding is fucking dope. It allows people to take ideas in their head and make, like, albeit shitty, but whatever, like, a working product, like, really quickly. And then if it's dope, then you can go get a dev to actually, like, code it correctly. Is this, like, complex geometry so you don't get creases in your sweater vest? Okay, so, we have potential energy and kinetic energy. We assume it starts at rest, right? Okay, so kinetic energy is equal to 0. Potential energy. So that's going to be equal to gamma L over 2 times G times H. Right? So this is the mass that's above the table before it falls, which I'm... Well, actually, and that's 0, sorry. Sorry, we're calling that H equal to 0. And then we're going to say minus the center of mass here, which is going to be this, but still has a mass of lambda over 2L. And then G, but then H in this case is negative L over 4, right? Right? I feel like that's correct. Okay, and then afterwards, so let's look at what's happened afterwards. After this thing is, like, fallen. Why is it minus? Because I'm calling this 0 height. So being below is negative potential. It'll work out because you just need the change in potential to equal the change in kinetic. Okay, so then once it's slipped all the way off the table, right? This is now the full length L. Oh, it's supposed to be plus. Wait. Yes, you're right. Thank you. Yeah, you're right. So now you have mu e is equal to L. So lambda L G, and now the height for the average, because you always do like the center of mass, is negative L over 2. I feel like this is a stream I'll be stopping by once in a while to redeem my faith in humanity. Oh, thank you, Dream. Appreciate you, dude. Yeah, we're just trying to make the world a better place, dude. The news like sucks, bro. No. All right. Lambda L G negative L over 2. Good. And then we also have like some kinetic energy, which is equal to 1/2 lambda L. And then it's V squared. STEM warriors, all STEM warriors, like assemble STEM warriors. Okay. So the total energy here is equal to negative L squared over 8 G lambda, right? Or lambda G. Yes. Yeah, at least yeah, math doesn't give a fuck about, like, I don't know, your feelings or opinions. People have their feelings are too strong sometimes. And they start saying dumb things. Alright, let's get this. So this is lambda G negative L squared over 2. And then this is plus lambda, oh man, L over 2 V squared. What is lambda? Lambda is the mass density. It's a linear mass density. And actually, I'm going to be able to get rid of it. So what I'm saying is that lambda times the length tells me how much mass is there. So we're assuming the rope is, you know, uniform and doesn't have weird widths and shit. Yeah, it's a mass density, yeah. So here, this is E after. Okay, so now they just have to equal each other. Cool. So now, this equals this. And we're going to solve for V. This is a math Olympiad question. It is kinematics, technically. Fuck. I don't have an L squared here, which is annoying. But that's okay. I can at least combine this with this. It's physics Olympiad. Anything else and you're crazy. Yeah. Even Lagrange multipliers, dude. You're crazy, dude. L squared over 2 minus L squared over 8 is going to be 3L squared. G over 8, right? Is equal to L over 2 V squared. So, what is it? 3/4 GL is equal to V squared. Okay. So, V is equal to the square root of 3 over 2. Square root of GL. Wavelength is my guy, dude. Okay, cool. I think that's right. Does anyone know the answer to this, if this is a physics Olympiad question? Curious. I can throw it at ChatGPT too. Just burning so many AI credits today. This was the ethylene one we did. You think it's right? All right, let's just see. I want to see. I want to feel good about myself. Banana. Banana. Mitochondria mommy.
Good job.
Okay. Oh, and baby voice is in. Yeah, thank you, JC, dude. Oh, nice. Yeah, square root of 3 over 2 GL. Yeah, fuck yeah, dude. We got it. Olaf. Hey, Olaf. Good clap. Good clap, Chris. Nice. W. Yeah, Lambda's a chill guy. Who's that? Notification. Okay, notification.
Ooh, the queue's getting big. Queue is getting big. This is actually, it's a good question of mine. Should I cap it at 20? Just because if somebody submits like past 20, like you're gonna have to stay here for like 2 hours for me to get to you. So I wonder if I should, I'm kind of thinking I should keep a cap to more encourage like people who are here for me to go over it with. But also I want people to be able to always ask for help. So, debatable. I don't know yet. We're experimenting. Okay, cool. This is a good question. It just means we gotta work faster. Let's work faster. We can do it. Who do I got? Nice. Love this, Charles. I don't personally do discrete, but I have friends that do. So, if I can't do it, I'll give it to one of my other friends who streams, and they might be able to do it. Yeah, if they're in chat, if they're not, just send it to Discord. Yeah, I could do that. Yeah, it's a good problem to have. It's an interesting problem to have, right? Okay, graph this. Cool. This is basically a parabola, right? Where you have h comma k is equal to 1 comma negative 3. So if we go 1 down 3, 1, 2, 3, that's here. And then because it's positive here, that means it points up. And I guess it happens at 10, right? Usually you want to like find, if you find these 2 points, your teacher's happy usually. So I could just set this equal to 0. So 0 is equal to 1/3. Is worth 1 mark is so sad. It is wild to see how like how teachers sometimes like weight things. Okay, so then I move that over +3, I times 3, I get 9 is equal to x minus 1 squared. Ah, okay, so plus or minus 3 is equal to x minus 1. Cool. So 1 plus or minus 3. So that's going to be either equal to 4, so you got something here, or it's going to be equal to -2. Great. And then because it's dashed, we're going to do this. And then because it says greater than, I know it's just going to be up because it's above it. If you really want to like be rigorous about it, your teacher will say like check a point. Isolation method. I don't know if it's called the isolation method. I call it like just putting it in vertex. It's already in vertex form. And then I'm just finding some x-intercepts. And if I check 0, 0, right? I get, is 0 greater than -3? Or, sorry, no, sorry. That's 0 minus 1. Is 0 greater than 1/3 minus 3? And like, yeah, it is. So that means this is all shaded. Okay, shady, shady, shade. Good. Is the point a solution for this? Show your work. You just plug it in, right, dog? Is 20 less than or equal to 1/2 -1 minus 5 squared plus 2? Is 20 less than or equal to -1 minus 5 is -6, squared is 36. 36 times 1/2 is 18 plus 2. Is 20 less than or equal to 20? It is. So true. True. Okay, cool. And that one's done. Now you can see how it's 1 mark. Yeah, it's not that bad. That was Chari. Where do you get these test papers from? People submit them. People just submit questions and I do them. Yeah, that's how the stream works. People just submit questions, and I figure them out for them. All right, next one is this, the photoelectric effect. Oh, cool. This is a GCSE question, it looks like, right? Noise would know this one, actually. Okay, the maximum... Yeah. Oh, JC's done some streams. But yeah, I could wake up in time for him. He's already on our stream right now. Is this A-levels physics? My degree is in plasma physics. Yeah. I have a PhD in plasma physics. Okay, the maximum wavelength of electromagnetic radiation which can release photoelectrons is that. State the part of the the E&M spectrum that this belongs to. Okay. Well, 6.5 times 10 to the minus 7. That's quite small, right? That's 0.6 nanometers, 10 to the minus 9. Oh, okay. That's 650 nanometers, right? Because I want to know how much the times 10 to the minus 9 is, which is the visible spectrum, no? Yes, Taco Cat, that is the plan. Okay, 6.5 times 10 to the minus 7. And then we need to like just move this to the right 2. And if we move it to the right 2, this has to go down by 2. But negative 7 going down by 2 means it goes to negative 9. So this is the same thing as 650 times 10 to the minus 9, which is 650 nanometers. And that's visible. I think it's like red. Yeah. My plan, Taco Cat, is to take this funnel of people and just spread it to all the other educators who want to like help, so that everybody can get all the help and I can get some sleep. Show that cesium has a work function of about that. Ooh, interesting. Work function. Is that like H lambda? Is that the work function? What is the work function? Thank you, dude. Yeah, that would be great, Taco. Oh, it's HF. E equals HF. Okay. Work function is E equals HF, not H lambda. I was wrong there. Why color match? Why not, dude?
My man.
Okay, E equals HF, but lambda F is equal to C. So F is equal to C over lambda. So you get HC over lambda. So that's equal to, I forget what H is. It's very small. What is H? What's up, Kenzer? H is 6.62 times 10 to the minus 34. Cool. So 6.6 times 10 to the minus 34 times 3 times 10 to the 8th. And then this is all over 650 times 10 to the minus 9. Rosy kisses. Thank you, Ashley. Yeah, I should remember that one, honestly. I don't. Okay. 6.6 e to the negative 34 times 3 e to the 8th divided by 650 e to the negative 9. Ooh, we get something very small. Yeah, 3 times 10 to the negative 19th. That's correct. Cool. We're on the right track. I always love when that happens. All right. Yeah, nice. They're nice that they like say like, hey, this is the answer you should get. Unlike JEE questions are like, oh, you didn't get the question? Go back to poverty. You're not allowed to leave. You have a Twitch account? Yeah, send me your if you join my Discord, we have a promo channel, a self-promo channel. Just put your Twitch. I'll follow you. How do I study for my calc exam? You seem pretty smart. Doing practice questions helps. And like making sure that you understand all the steps. If any steps don't make sense, I would say like that's a good idea to try to review a little bit. Taco, are you leaving? Oh, you're headed to sleep, Gold? Okay. Don't sleep on us, Gold. I'm never gonna sleep on you guys. Thanks for coming by, Taco. Yeah, dude, you can't do part A. You can't do the whole question. What's my IQ? I have no clue. Okay. What is it meant by stopping potential? Ooh, okay. The circuit shown is used to measure the stopping potential for a range of frequencies. I think that's the potential at which current stops flowing. Is that what happens? Is this the potential at which current stops flowing because I don't know, it's equal to the current flowing from. So what happens is with the photoelectric effect is if you shine light which is like the simplest form of electromagnetic radiation onto like an anode cathode system, you end up like knocking these electrons off and then they travel this way and that creates a current. So if you put a high enough potential on here, then they don't go to the other side, right? Exactly. So JC has it right. Yeah. It's the potential such that electrons slow down enough to not reach the cathode. Very nice. Love that. Yeah. Because, yeah, here's what happened. You have, like, a bunch of, like, electrons just chilling here. And then you got some light coming in. And this is cool. This is what showed to the world that light behaves as a particle. Because you have to have some sort of mass here to, like, knock fucking electrons off. And so it knocks the electrons off. And anodes are always negatively charged. Cathodes are always positively charged. So if you knock them off, and then they bind to here, then you'll measure a current. So this is the current you measure. But if you have a strong enough voltage fighting it, then the electrons can't make it there. Because, I don't know, this is like too negative or like not positive enough to attract them. Raid says, I need help with something science related. Not sure if you can help, but it's about gravitational waves. Maybe. I'm in electrical right now and you're teaching more than my teachers. Holy shit. Oh, it does happen. Anyways, cool. Good question. Whose was this? Oh, Natsa After Hours. Good question, Natsa. I appreciate that. It was a fun one. Given energy minus... Yeah, energy minus work function is equal to the stopping potential. Yes. Yeah, the work function, yeah, is the amount of energy needed to, like, I think, knock the electrons off. That's how we think about it. All right. Bro is so goated. Appreciate it, dude. We are 2.5 hours in. 25% of the way. To 10. I'm starting to get a little hungry. Alright, where was this? Yes. Where did I pursue my PhD? I did my PhD at UCLA. And I did it in plasma physics. If you ever want to see my thesis, I'll drop it in the chats. But this is it. Here, where's my YouTube chat? I can't post links in Discord, unfortunately. Sorry, I can't post links in TikTok, unfortunately. Otherwise, I would send them. But yeah, there you go. There's my PhD if you want to know about it. And then I graduated in 2021. Yeah. So what? It's been 5 years now? Four and some change. All right. Next question comes from LOL. Stokes theorem. Oh man, you're gonna hurt me. You're gonna hurt me, LOL. The diagram? What diagram? You saying this diagram's even right? I'm pretty sure this diagram's right. I don't know exactly what's going on here. But this seems like a... Oh, this is a resistor, I think, is what this is. This is a variable resistor. You are right that the battery is in a weird position. Wait, the ground goes through here as well. Oh, and this measures the voltage across it? Yeah, I can help with Laplace transforms. We do a lot of Laplace transforms. You're gonna watch me struggle. It's a potential divider. Okay. Yeah, and this is a variable resistor. Are you saying the battery should be the opposite way around? No, this is always positive. This is okay. Right? Okay, use Stokes' theorem to evaluate the curl of V dot ds, where S is the surface of an inverted paraboloid parameterized by that above z equals 1. Hence, it may be advisable to sketch the surface of S. Yeah, well, maybe. Okay. So this is basically like 10 minus x squared plus y squared. So, when this is 0, z is the biggest. Okay, so it looks kind of like this. What do I do for a living? I teach. I taught physics at UCLA for a couple quarters. I help out with like ed tech startups, and then I do this. This is my nonprofit. So we like motivate gamer kids to like do well in math and science, and then we help them out in the streams. It gets, yeah. Why are the UK people here? It's 2:43 a.m. It's like, go to bed. Stop getting knackered. Yeah, JC is my one of my UK streamer friends. Okay, nice. So yeah, it looks like this. It's like a little fire hat. Okay. No, anything. You can ask. We did chemistry earlier, Capybara. I can do stats. This was circuits. This was chem. This was definitely chem. This was calculus. This is chem. This was chemistry. I say I primarily get questions that are either math, physics, or calc. JC's a vampire confirmed. Chem above all, yeah.
My man.
He does love chem. Alright, I gotta remember what Stokes' theorem is. It's like something with like the partial derivatives, isn't it? Uh-huh. Dude, look at this fucking graphic, dog. What? Where did I major? I got my PhD at UCLA. I got my undergrad at University of Texas. Yeah, what is it? How does this work again? I'm gonna maybe like try to use this to learn. I will bite you. Yo, what's up, Zach? Yeah, Stokes' theorem. I still don't understand Stokes' theorem, but okay. Curl F ds. Like, one of them is easier to do than the other, right? Isn't that what this is? Like, you just pick which one is easier. Yeah, dude, look at this person, dude. As long as I just go around, that's the same thing as s.ds. Oh, okay. So I think, wouldn't it be easier to just integrate in a circle around this way? I feel like it would just be easy to do that, right? That's kind of the trick. That instead of doing this nasty thing here, I can just do the contour integral of f.dr. Alright, fuck yeah, let's do it. Alright, cool. Alright. But then I need this in, I want to say polar coordinates, right? Rotate yourself. Okay. X equals r cosine theta. Y equals r sine theta. And then what? Z just equals to 0. Yes. 7. Yeah. And runs equals 0. We love it. Okay, cool. So then I'm just going to integrate from 0 to 2 pi of what's this, 1/2 r d theta. Is that what this is? And then, I think I have to put an F in there at some point. F.dr. Okay, sorry. It's F.dr.
Okay. Thank you, Pen Center, for the baby voice. Bro went two-dimensional. Yeah, I flattened myself, dude. Okay. And wait. F dot ds. No, it's F dot ds now, right? Oh no, it's F dot dr. Wait, what? Fuck.
What is F? F is this. Isn't this F? F is this. Is V. Baby soundboard, yeah. Okay. F is equal to that's Z, which is 0. And then it's 2xy. And then it's comma x squared y. Oh yeah, here comes Master Chief. And then I can substitute this to get like r and theta. Wait, I could have sworn this is f.ds though, not dr. There we go. That's what I wanted. That's what I wanted. Yes. R cosine theta, R sine theta, comma 1. Why is it comma 1? Oh, because z equals 1? Oh, dude, I'm dumb. Yeah. There we go. Yes. Above z equals 1. Thank you. Okay, so this isn't 0, right? This is 1. Yes. Okay, this is f. And then dr is parameterized by r cosine theta, r sine theta, comma 1. Yes. Okay. So this is f, which we're going to rewrite in our new fancy form, which is r squared sine theta cosine theta, and then 2, which I think I'm going to turn that into 2 sine theta or something, right? And then I have r to the third cosine squared theta sine theta. Okay, cool. This is f, and then dr is equal to r cosine theta, r sine theta, comma 1. Chat is hard. Hi, dumb. I'm Joseph. Yeah, well, that's because the algorithm knows exactly what you're doing. Yeah, and we're doing Stokes theorem right now.
My man.
Okay. And then is it d theta? Am I still doing the integral? So here's my question. Where's my d whatever though? You're integrating over circle of radius 1, so replace r equals 1. And then it's 0 to 2 pi d theta. I think. Cool, okay, thank you. Alright, let's do it. What is this class for? This is probably, I think, Calc 3. Okay, so this right here is f dotted with dr. And let's see what that turns out to be. So that's going to be r cosine theta. Oh, one more thing. Uh-oh. What's the one more thing? Well, when z equals 1, r doesn't equal 1, though, right? You actually need to differentiate r?
You done messed up, AA Ron.
Oh no. This is getting more harder. Negative sine theta, comma cosine theta t, comma 0. That's dr. Oh, okay. Wait. Sorry, yeah, this is r. Right? This is r. But then dr is equal to all these derivatives, right? And technically r is a constant. Yeah. So you have d cos theta, comma sine theta, comma 0, which is going to equal to negative sine theta, comma cosine theta. Sorry, this was 1, comma 0. Yes. And it's yeah. Cool. Okay. So that's my, like... I feel like R is kind of a misnomer here. I feel like I want to call it, like, DS. D theta. Thank you. Yes. D theta. Okay. Why is all my handwriting, like, sloping up? I'm stopping that right now. Okay. Negative sine theta. Cosine theta, comma 0. D theta. Alright. That's because my board was just going up. I'm right-handed, actually. Is anybody in my chat left-handed? I'm curious. Left-handed people, make yourself known. This is my right hand, right? I know it looks like my left. It's my right. That's the mirror effect. Lefty here. What's up, Cody? He's gonna be president, dude. Isn't there an abnormal number of presidents that are left-handed? Lefty, super goose. Lefty in the house, dude. Okay, so this is negative sine theta, and then that's plus this dotted with this. I goon with my left hand. God damn it! It's no goon November though, bro. What are you doing? You lost the plot, dude. Ambidextrous. Okay, cool. 2 sine theta cosine squared theta, right? Okay. And then, oh, and this is 0. Yeah. So it's this shit. 0 to 2 pi d theta. Okay. I fear for your dog, dude. Okay. This is a beautiful integral, though, right? Because this is u du. And this is just integral of that, right? So I have negative 0 to 2 pi sine theta d theta. So this is just going to be 2, right? Sine from 0 to 2 pi. Well, it's actually equal to 0. Yeah, this is 0. What am I saying? Sorry, this is just 0. I have no idea what's going on in front of my screen. It's okay. If you watch long enough, you might get it. And then this is 2 sine theta cosine squared theta d theta. This is a u sub situation. I'm going to say that u is equal to cosine theta. So du is equal to negative sine theta d theta. So then I have the integral. So my bounds change a little bit, right? So u now goes from 1 to wait, it goes from 1 to 1. Oh, that's not good. Oh, isn't this also just 0 again? Is the whole thing just 0? No way. I feel like it is. Right? Because the bounds are now the same. If I use U as cosine theta? I think so. Wow. Okay, so I don't give a fuck what's in here. The answer's 0. Wait, so the whole answer's 0? It's a big fat 0? No way, dude. That's too funny. Is this whole answer just 0? Dude, I hate when math does that. You made me work this much for 13 marks for it to be just 0. Alright, U-sub was my first kryptonite. I feel like that was the quotient rule for me, dude. The quotient rule hurt me. It happens a lot multivariable. Yeah, it's because of symmetry, Zach, right? It's just because we have symmetry. Do you have videos on static friction? Yes, I do, Eric. No, you came to the right place. Thank you for asking. So if you go to our TikTok, which you're watching me on TikTok right now, I have... Thanks for all the follows, by the way. I have a video here on friction. Where is it? It's kinematics. This is Newton's laws. Is this friction? No, that's not a friction one. One sec. I know I have it. It's like one of the first videos I ever did. Here we go. How to solve for friction in physics. So this video right here will explain to you how like kinetic and static friction works and what the common questions they always ask. They always ask like, what's the acceleration? Now the force is this. What's the acceleration? It's like a trick question. If static friction is stronger than kinetic. Sorry, if static friction is stronger than the force that's pushing it. So yeah, this video has it for sure. Go check it out. Yeah. All right, nice. Let's see. ChatGPT also says the answer is 0. Good job. Wow. We love when that happens. We love a good 0. Woohoo! What's up, Rooksa? I got trolled. No, I got trolled when someone submitted me a question that the answer ended up being 6-7. Like it was a complex analysis question, but they had ChatGPT write the question such that when I solved it, the answer was 67. And then I ended up doing it on page 67 of my whiteboard. It was a double troll. Okay, this one was LOL. I mean, their name was LOL. Like, I guess they were trolling me. All right, let's see. Zach, it's late for you, dude, right? What is this, like 8 o'clock, 9 o'clock for you? Appreciate you being here.
Good
Pen Center too. Appreciate all you guys. All right, let's see. We'll pull up the next one. It's 8. Okay, so not too bad. Where do I get the questions? So there's a website, actualofficehours.com. So if you go to that website, here, I'll show you how it works. Here, let's get this out of the way, sorry. So go here to actualofficehours.com. You can just type in your username, whatever, and then drop a screenshot in of what your question is. It'll get added to the queue. You can always look at the queue. If you click here, you can see what people are submitting. So some people got some really interesting questions coming up. It's just after 6 to 7 p.m. No, I got done again, dude. So yeah, so this is the current. Also, yeah, make sure when you go to this website to go submit your question, go check out the streaming schedule, because I'm not the only person that does this. I have a lot of really awesome friends who also stream math and science content, and you can see when they stream on this calendar. So, for instance, tomorrow, Zach, who's E2iPie in my stream, in the chat, and Penn Center are doing a really fun podcast where they're going to talk about like math, education. I heard there's some funny dad jokes coming up. And then also Zach will be doing his own kind of like math help stream Saturday morning. And then next week we got a bunch of people as well. So make sure, come on by. Oh, Joseph streaming. Yes, new streamer Joseph. Make sure, here, let me give a shout out to Joseph. Make sure, yeah, Joseph has just kind of joined the foray into streaming educational content. So if you can go give him a follow, it'd be great to let's get those rookie numbers up. Yeah. All right. What do we got? We got a biology question coming up. To investigate whether red blood cells of animals lose the ability to take in glucose, they collected red blood cells from guinea pigs that ranged in age from 1 day old to 7 months old. Scientists incubated an equal number of red blood cells in separate so good, they have a control. Control groups are great in experimental design. The amount of radioactivity labeled glucose present, the amount of radioactively labeled glucose present inside the red blood cells was measured over time. Describe the difference between passive transport and active transport. Okay, cool. So passive transport is when you're moving things along or like down the gradient, is what I say. I think that's the way I would say it. So for instance, if you have things going from like high concentration to like low concentration, that's an example of passive transport, right? This would be like passive. 3 hours, get them bond coins, dude. Yeah, you get a lot of credit for watching the stream. And they get you gift cards. So yeah, that's passive. So when stuff naturally goes the way it wants to go, things want to go from high concentration to low concentration. Like salty water wants to like spread out into not salty water. That's my first one. Nice pen. Active transport is when you fight a concentration gradient. So like when you're trying to like swim uphill, for instance, or yeah, whatever. Swim upstream. So this would be active transport. How do I know so much about all the other sciences? I've taught all of them at some point, or I've tutored them. I can definitely help with centrifugal forces. Yeah, drop a screenshot. I'll do it. So cool. That's the difference between active and passive. Okay, justify why students use an equal number of red blood cells in each cultural dish as a control. So it's the same starting concentration, I guess. I mean, if you didn't have the same number, then they would do different shit. What? I mean, the definition of a control is you need things to have the same starting conditions. Otherwise, that can create what's called what do they call it? What are the unknown factors that like mess with an experiment? Confounding variables. You don't want confounding variables in science. Yeah, confounding variables is we hit our 3 hours. Okay, I need to restart this for 1 sec. The board gets mad at me over 3 hours. Well, that's cool. We got to our first 3 hours. We only got 2 more of these to do. 2 1/3 of them. Flowful Z variables. Yes, centrifugal is fake. Yeah. What does the equation of friction mean when the force of friction is less than mu(s)? So if the force of friction is less than mu(s), then it just means it's kind of a smart force. It only exerts the force it needs to like push the thing, to keep the thing stuck. That's what it is. Mass stream train, let go. Yeah. This train's not stopping until 2 a.m.
Bing bang.
Okay. Justify. I just think that's the definition of a control, right? Yeah, like rate is dependent on initial. Initial conditions. And you could say like it reduces confounding variables. Okay. Glucose transporters are required for the facilitated... Okay, so facilitated diffusion sounds like passive transport, but if it's facilitated, that's kind of active. Okay. The scientists claim that the expression of the gene encoding these transporters decreases as okay. If the scientists' claim is supported by experimental data, predict the effect of increased age on the amount of radioactively labeled glucose inside the cells of each group. Oh, okay. So there will be less diffusion, right? So less diffusion means there should be less concentration inside the red blood cells. Yes, I think so. I would say, like, yeah, less concentration of glucose. And then the prediction for that, is that there are less transporters. So if you have less transporters, that equals slower facilitated diffusion. Which implies less intake of glucose. Yeah, cool. Okay. Nice. Cool. Fun questions. Biology. I mean, biology, especially at this level, seems kind of like obvious to me. I'm like, well, they get older. The things that move things don't really work anymore, so there's less of it. But it's all, you just have to know the lingo. You just gotta... The thing I liked was the active versus passive transport. That was like, oh, okay, cool. I can explain a concept here. Okay, whose question was that? That was a biology question. From... Oh, just from biology. That was just someone's name was biology. Okay, cool. All right, another one done. I'm starting to get hungry. Please get my next. If it's in the queue, we'll get to it. We're streaming for 7 more hours, so I guarantee you I'll answer at some point. Oh, Ruxo, your biology. Oh, nice. It was kind of a fun question, right? How are you going to do that? I'm going to do that by answering questions for the next 7 hours. That's how I'm going to do it. Could you explain synchronous inertia? Ooh, I've never heard that term before. What is synchronous? Let me just Google this real quick. What's synchronous? Synchronous inertia. Is this an engineering thing? A power system to resist changes in frequency, which is provided by the stored kinetic energy in rotating masses. Oh, okay. So this is an engineering thing for sure. Okay. Why are we doing math for 10 hours straight? Why not, dude? It's better than, like, scrolling through feet pics. No. Yeah, come for the knowledge. Alright. No, it's cool. Yeah, so, I mean, this is what they say. So... Yeah, a lot of times, like, turbines or, like, energy generators, right, need something to rotate. It's a very basic way that we make electricity, is we basically move coils through magnetic fields, and those generate current, and then that current gets converted into electricity. But in order for these things to spin, you want to have a bunch of different input sources causing it to spin. And so here, yeah, they talk about, like, oh, well, you could have a generator. So the generators here, these things are, like, extracting energy from this spinning rod, because as the rod spins, it creates electricity in the generators. But in order to keep that rod spinning, you need other things to be contributing, like inertia or like rotational inertia to it, and those can be things like a power plant from like wind, or yes, PV is photovoltaic, so this is like a solar plant. And yeah, they call it the frequency. Yeah, and most stuff does, right, on the grid works at 50 to 60 hertz. Yeah, so I guess synchronous inertia is what sources and what sinks do you have that are balancing, like, the rotational energy in and the rotational energy out to a system. Yeah, it's all just boiling water, dude. It's the most simple way of, like, creating electricity, so, dude, yeah. Math for 24 hours every day, 0 hour break, burnout, and come back from the ashes grind says. Yeah, I will do a 24-hour stream at some point. I'm trying 10. Trying 10 today. Because we got 10K subs on YouTube, which is dope.
That's dope.
How are we doing on YouTube, by the way? Let me see. What are we at? What are we at, Where are my channel analytics? Oh, nice. Okay, cool. There's like a live counter somewhere, usually. Where's my live counter? Analytics. Subscribers. Where is it? Dr. Gold 24K edition. Yeah, that's right. That's a good one. I thought I can usually click on this and there's like a big button of it. Where is it? I think it's like analytics, audience, subscribers. How long till 24K subs? Yeah, that's what we really need. I swore it was. Oh, here it is. There it is. See live count. Okay, there we go. Okay, there you go. That's the live count of subscribers. Yeah, yeah. We had a big couple days. I think it went up like 1,000 in like 3 days, which is really what prompted this. Rue. Okay, more stuff. Okay, let's do this. This is, again, a little bit of thermo, but there's some more stuff happening. Dude, you show up on my normal TikTok page. It's called your FYP.
My man.
Correct. Yeah. Okay, let's see. What's the final temperature? Okay, so that's like Q in equals Q out. Oh, your personal account. Oh, that's cool. All right. Okay. So this means like MC delta T of the water has to equal the negative MC delta T of the nails. And then I think we're going to hope that the heat in the nails doesn't cause this to go past 100. Because if it does cause it to go past 100, then we got to talk about heat of fusion and heat of vaporization. The reason for that, and here, I'll show you. It's like, there we go. This is what I want. Yeah, this is kind of like this is the chart. So what happens is, as you have, let's say, water, for instance, and it exists as ice right here, right? This is like the temperature, and this is like how much energy you're putting in. So as you put more energy into ice, the temperature goes up until it hits 0. And at this point, any more energy you put in does not raise the temperature. It actually breaks down the bonds in between the atoms, keeping it a solid. And so this is called the energy E of fusion you have to get over. And once you got, and this is where things are like in between being ice and being liquid. Then you have liquid water. You start putting more energy in. Temperature keeps going up, right? Until you eventually hit vaporization. So this is where stuff is boiling, okay? Now, during boiling, you'll notice when you boil water that the temperature of the water doesn't change. It's always 100 degrees centigrade, at least at sea level. Because what's happening is you are putting energy into the water and breaking down the bonds that keep it a liquid, that keep it together as a liquid to now make it a gas. And so as that happens, this is called vaporization. Temperature doesn't change. But eventually you push past that and you get to what's called like superheated steam. And so now you have vaporized liquid water, vaporized water, which is a gaseous water. And that just keeps going up. And this is this region over here is how like turbines and stuff work. It's all like superheated steam. Okay, so, but what we need to make sure is, so the water is starting at 4 degrees centigrade, which means it's starting, like, here. I need to make sure that, like, as I add heat from the nails, it doesn't push it above 100. Because if it pushes it above 100, I got to figure out if it's enough to vaporize the water and turn it into a gas, or if it just stays as, like, a mixed vapor liquid. Oh, someone asked that question, HK. That's a good Diffie Q question. All right. So let's do this. We're gonna figure out how much heat is in the nails and how much of that transfers into the water. So 325 grams of water. So we can put a mass here. So the mass of the water is 325. The specific heat is... What is that specific heat? Where is it? I know it's 4.186, but whatever. 184. Yeah, we do E&M for sure. The pulsar timing arrays. Okay. And then this is going to be T final minus T initial. Okay, but what's the initial temperature of the water? It's 4, which is technically 277. You got to put things in Kelvin, right? You might not need to actually here, but it's you get in the habit of it. It's just good. Delta T equals C because E equals MC squared? What? We're teaching chem right now. Or this is like thermo, I guess. Okay. Alright, mass of the nails. So, let's remember that was a quarter of 454 grams. Let me just get that real quick. $113.5. Okay, so that's 113.5 times the specific heat of the nails, which is 0.452. So it's interesting, like, the iron nails are actually a pretty shitty conductor. Dude, like, look, water is 4. That means it takes 4 joules of energy to raise the temperature of 1 gram of water, 1 degree centigrade. It only takes 0.4 to do the same thing for a gram of iron. And then this is, again, also, sorry, there's a minus sign here, right? Because it's minus. Because you need them to be equal and opposite. And this is T final minus. The initial temperature was 55. So it's 328, right? Nice. Okay. And now we just have to solve for TF, which is kind of a pain. But okay. I mean, this is going to be a number. This is going to be a number. You, like, divide this. You multiply, and then you, like, move it around. So let me just show calculator ways. Well, that's how that one works. So I got 325 times 4.184. I'm going to divide that by 113.5. I'm also going to divide it by 0.452. Okay, so you get 26.5. TF minus 277 is equal to TF minus 328. And now your goal is you distribute this in. And you move that over. So this is going to be, once this multiplies, and then we subtract one of the TFs, that'll be 25.5 TF is equal to negative 328. Oh, wait. Sorry, this is a minus sign. There was a minus sign here. Almost forgot the minus sign. One sec. Right, I'm gonna go to bed. See you when I wake up. See you, JC. Night. Thanks for coming by, dude. Okay. That's a negative here. Which, negative A minus B is the same thing as B minus A. So this is the same thing as 328 minus TF. And then this is still 26.5 TF minus 277 times 26.5. So I can move the TF over here. That makes 27.5, and then I'm going to move that over here. So 27.5 TF is equal to 328 plus 277 times 26.5. Oh, this is going to be huge. Uh-oh. 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 SpaghettiOs. Oh, no. Yeah, I already see this is going to be greater than 373. Okay, so we're already pushing this. That's because you did Kelvin? Yeah, but this is already going to be above 373, right? I already got 328. Oh, I'm dividing by 27.5, though. Forgot about that. Okay, one sec. 328 plus 277 divided by... I forgot about the division. Right. And then we divide this by 27.5. Ooh, so I get 278. It's actually kind of nice. So TF is equal to 278? That seems very low. It's like 3 degrees. Yeah. Yeah, that's like a 3 degree. Yeah, that, well, it's 5 degrees. So, okay. 5 degrees Celsius. Is that the correct answer? Seems like it didn't really do much. Check with the big chat. Okay. Yeah, 5 degrees centigrade. I guess it makes sense because you only have like, you have half the number, you have half the mass of the nails, and the nails are also like a factor of 10 worse with heat capacity. And then you don't really have that much change in temperature. It just seems so low. Alright, I trust it. If we wanted to, I could put this into ChatGPT real quick. Yeah, let's just see. Just to verify. We have been streaming for 3 hours and 15 minutes, so I want to make sure I'm not going crazy. This was Stokes' theorem we were doing. You were the calculator, sir. Yes. Well, you take Q equals MCAT for both of them. Feed ChatGPT the VDI heat atlas. What's that? I'm just curious what it gets to here. Yeah, answer is, yeah, 5.85. Yeah, close enough. Yeah, 5 degrees. Damn. Yeah, not very much at all. Yeah, it was 278.8, so it's 5.8. Cool. All right, ChatGPT agrees with us. I'll take it. You're welcome, dude.
Well done! Well done!
Rooksra. Nice. Let's throw this in. It's a German collection of standard heating. Oh, dude. Oh, that's really cool. Yeah, engineering is wacky, dude, with all the tables they have for things. Yeah, if you've ever seen them before, where's this? Like this. Yeah, like all these ones. these tables, and then these are like other tables. I can't even read this. Yeah, steam tables. I remember having to do these a lot when I taught like some. Yeah, look, it's like saturated liquid, saturated vapor. Yeah, all these fucking tables, dude. What are the EE ones? Really? I mean, I guess this is like, oh, like conductors. Oh, okay. Maybe stuff like here. Insulation levels and stuff. Yeah. Okay, cool. Chat agreed with that. I take that as a good sign. Let's see what we got next. Avish. Oh, cool. These aren't too bad, Avish. We're gonna do a little bit more conceptual physics. Let me see what your other ones are. Here, I'll just bang all these out for you, Avish, because it's not too hard. They're kind of all the same. Okay, what happens when two waves have the same amplitude, the same frequency, and are perfectly out of phase? Very cool. So if they're perfectly out of phase, you get what's called like negative interference or destructive interference, right?
Nice.
This is oh, thanks for the follow. 10-foot screws. This is destructive interference. If you wanted to see this as kind of like a graph. Oh, really? Oh, man. It was the last question on the paper, and the answer was 0. That's cool, Jade. It was a fun one. Yeah. I was like, what? Why? How's the answer 0? But then Zach pointed out to me that a lot of multivariable calculus things end up being 0. Right. So, for instance, if these were in phase, it would look like this. But then if you move them out of phase, I don't know why this thing like suddenly got like nipples on it. Oh, fuck. Or here, I'm just gonna draw 2 of them. Draw 2 of them exactly. So like, look what happens as you move this. This is completely out of phase. This is what we call 180 degrees out of phase. And you end up getting the peak of this fighting with the valley of this, and that creates 0. Because if you add them up together, they end up being 0. If you want to show this mathematically, it's actually pretty cool. Let's say the blue one was y was equal to sine of x. And then the red one was y is equal to sine of, let's say x minus pi. So this is 180 degrees out of phase. So what you learn from this, yeah, they do cancel out. It's not saying if they're harmonic, true, but it does say the same amplitude. So this is like same amplitude, same frequency, perfectly out of phase. Perfectly out of phase means phi is equal to pi, right? This is an identity. Sine of x minus pi, I'm pretty sure it's an identity. Where is it? This one. This is always a great sheet. I love this one. Oh, they don't have it here. No, where's the pi identities? Ugh. I'm pretty sure sine of x minus pi is negative sine. Whatever, just trust me on it. Pretty sure it is. This is negative sine of x. And so if you add these two together, you end up getting 0 as well. equals 0. So that's why, yeah, that's why things that are 180 degrees out of phase, destructive interference, yeah, complete with each other. Okay, wave moves along a piece of yarn and then encounters a heavy rope. Describe the orientation of the transmitted and reflective waves. This is really cool, actually. So when something goes from, which is kind of like an index of refraction. This is like N1 is less than N2. You end up getting the reflected waves invert is what happens. So this like hits and then inverts in the other direction. But I think this one stays in the same orientation, but it just has like less amplitude. So Folly says, cool way to remember all the trig identities. Oh, e to the iy is cosine y plus I sine y, and that e to the iy, e to the iy prime is equal to I e. Oh, okay, cool. Yeah, the sum and angle ones. What is Ling? Thanks, Jade, for having us on your 3:30 a.m. gym stream. What are you doing this morning? What are you doing? I skipped chest day today, unfortunately. It's my favorite day. But I couldn't do chest day because I was up till 5 a.m. like coding last night. You're a madman. Keep it up. Yeah. 10 hours. We're 3.5 hours in. 3.5. We're almost getting to halfway. Okay. Anyways, when something has is able to move faster in a medium and it hits something that's like slowing it down, the reflected waves are inverted, but the transmitted ones are right side up, I'm pretty sure. Doing arms? Nice, dude. I'm a big fan of arms. Arms are great. Powerlifting. Nice. What's your stats, dude? I want to get to 3 plates by this end of this year. I hit 290 on my 1 rep max for chest. I want to get to 3. I want to get to 315. I want to be the only PhD plasma physicist who can bench 3 plates. It's my goal. You are science-based. Thanks, bro. Okay, so reflected is, I believe, flipped 180 degrees. Or inverted, basically. And then the transmitted, I think, is the same. Same thing happened for light waves, by the way. Same, but you can say like less amplitude. I bench 178, competing. Oh, you weigh 178. Nice. Squat is 450. That's a massive squat, bro. What? Congrats, dude. Dude, I can't really get up. I can't get over 300 on my squat. Deadlift is 505. Wow, that's good. Yeah, I'm too old to deadlift, honestly. I'm 35. Like, if I start deadlifting, I'll fuck my back up. No. Bruh. But nice, 255 on bench. At least I got you on bench. But I also weigh 195 at this point. I've been like dirty bulking for the last 6 months. Yes, light waves. Yeah, right? Yeah. They're all related to. A stiff leg deadlift. Okay. Poverty bench. Yeah, those are rookie numbers, Yucky. Let's get that chest up, dude. I agree, Jade. Yeah. That's the general consensus amongst my peers who are also in their 30s. Is that like deadlift, the risk reward is not worth it for deadlift, yeah. If you're young, yeah, go for it, man. It's pretty fun. But as you get older, the risk of injury like really sucks. You don't recover as much. Okay, in figure 2B, how does the amplitude of the beat relate to the amplitude of the waves? Oh, okay. I think it's the summation of them, maybe, right? Yeah, I think it's equal to the sum. Equal to the sum. Describe the pattern of the sound represented in figure 2B. Oh, this is the cool thing. So this is called a beat frequency. So when you have two things that are slightly off in frequency, they line up at certain points and they cancel out at others, and this creates a beat. The cool thing is, like, the beat frequency is equal to the difference between the two original signals. Your stream came again as I was scrolling? Yes, dude, the algorithm's working. Oh, no, yeah, rotator cuff. You gotta do these workouts. You gotta do these ones. These ones are good for the rotator cuff. You know what I'm talking about? They're pretty good ones. Yes. It is kind of like Delta X. Here, I'll show it here on the stream. You guys want me to show it? It's actually pretty fun. Let me go to, like, online sound generator. We're going to demonstrate how beat frequency works. Yeah, here we go. All right. One sec. Let me turn the music off so you guys can hear it. Okay. I'm going to create a wave here that is at 440 hertz. I'm going to hit play. You guys are going to hear it. All right, cool. So that's at 440. That's our first frequency. So apologize for the noise if you have headphones in. So let's say like F1 is equal to 440 hertz. Let's create another frequency, F2, which is slightly different than it. Let's say, for instance, like 443 hertz. Yeah, the if I still have ears, as if I crank the frequency up. The beat frequency should be equal to 443 minus 440, which is equal to 3 hertz. Okay, and a hertz is like how many times per second you hear something. All right, so watch this. We're going to duplicate this. So I'm going to create another tone here, but I'm going to put it at 443. Do you hear that, like, how that oscillates? Whoop, 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 whoop. And it sounds like it's hitting it, like, 3 times per second. That's a beat frequency. So I can decrease the beat frequency if I bring them closer to each other. Let's say, like, 441. Ooh. You see how that's, like, once per second? That's because we're doing 441 versus 440. Yeah. And look, if I stop it, dude, people are like, oh, dude, you're just playing like a different sound. I'm like, no, dude, it's the same thing. Yeah. Okay. All right, enough. I mean, you can also, you can crank the frequency up. So for instance, if this one's at 440, and let's put this one at like, I don't know, like 445. 447. Anyways, okay, enough. Hey, okay, there you go. Anyways, those are beat frequencies. Yeah. So it's real. I don't know, you might have noticed that, like, difference in frequencies and, like, you can hear it. Go try it out if you want. Just, like, type in, like, online tone generator or, like, whatever. Just go to some website and that you can put in frequencies and just fuck around with it. In this case, I opened 2 tabs and then I just had them at different numbers. Yeah, it's sick. Science!
That's dope.
Science is dope. Anyways, okay, so that's why the beat frequency is that. Is flickering in a camera the same effect if the shutter speed doesn't match the frequency? Kind of. I think it's a little bit different, but it is also kind of like a wave. You are right. Yeah, that's because like the refresh rate of the camera isn't fast enough. So you're right. You're catching like the black spots that happen. You can definitely get notes from hertz. So yeah, if you want to know what they all associate with, like 440, what I just played is a concert A. So if we do like frequency to notes. Oh, he made the Desmos piano, right? Is that right? There's a Desmos piano. I think I've seen that. Yeah, but here you go. These are all the different frequencies. So for instance, like a concert A, if you play like in the orchestra or whatnot, what you always tune to is right here. This is 440. And then if you want to go up in frequency, right? So to A sharp to B, you got to like bring it up. The cool thing is as you go up an octave, right? You always just double the frequency. So an A on like one end of the piano going to the next A is doubling from 440 to 880. Yeah. Yeah, someone showed me. It was a Desmos piano. piano with 2 octaves. Here we go. I can't really hear it. I don't hear shit. Anyways. Yeah. Guess I'm playing notes. Is this playing anything? I think it's supposed to make noise. Oh, there we go. Okay, I had to turn the sound on. So this is cool. So this is showing as frequency changes, you get like different notes. Yeah. Oh, that's cool. Very cool. Oh, this is a whole piano. Why they put 69 and 42?
Nice.
The answer to life. And where's your y'all's key? 67 or something. This would be 68. 67 is a D sharp. Because of equal temperament. Oh, do they not always just double? No, I think octaves always double. Am I wrong about that? Yeah, it's a free new way to play the piano, yeah. Now look, oh. You know, look, for G, right? G is doubling. 49, 98, 196, 392. You are right, it's not exactly double here. It's a little bit off. It's pretty much double, though. G sharp. Yeah. Yeah, rounded. You know, there's interesting things, dude. Music is math. I DJ. I produce music myself. Like, I love music. Music is great. And there's a lot of connections that music makes with math. And it all kind of like... It's all connected. Some are done. Yeah. What's up, Mucker? Anyways, this is a cool question for Avish. Good job. Let's head on to the next one.
Man, you're still doing the stream.
Oh yeah, dude. Yeah, we're going for 10 hours. We're at 3 hours and 30 minutes now. About to hit 4.
I can't believe you can stay focused for so long, man. That's amazing.
I mean, dude, they have like girls in hot tubs that go for like 10 hours. They don't do fucking shit, dude. What? No. I'm pretty sure I can like do some math at least.
But what time is it where you're at, or what time?
It's early, dude. It's only 7:40. Yeah, it's pretty early.
Oh, PM. Oh, it's
yeah. I'm in Los Angeles time.
Oh. LA nice.
LA is great. I love Los Angeles. Hey, we just won the World Series. Sorry, Canada.
No, I was watching that game, the Rogers Center.
Oh, nice. Yeah. Is that where Toronto was playing? The Rogers Center?
No, I was there watching while they were playing in LA.
Oh, while they were playing in A. Oh, I see. They probably did like a watch party or something.
Wasn't a nice time, bro.
Yeah, I'm sorry. We got suicide alert.
Okay. I'll tune in for a bit before I sleep.
Okay. Nice. All right, let's see. What was that? And I did this one as well. Okay, so we can mark this one as done as well. His brain's gonna die at hour 7? No, dude.
Surprise, motherfucker.
I'm not going nowhere. I am probably gonna make some food in like 20 minutes. I might take like a 5-10 minute break because I just need to go like eat something. Damn, we're getting a lot of questions coming in. Ooh, what the fuck is this, dude? What? Someone's asking me about like gears? Yeah, you get points for sending anything that's math or science related. Hopefully related to like something you're learning. Maybe all the octaves are doubles, but the ratios... Oh, yes, exactly. You're right, Flofi. You are right about that. Yeah, there's something cool with like the golden ratio and stuff and music. There's a lot of cool shit going on. Yeah, rip to the Blue Jays, though. Yeah. Honestly, they played a very good game. That was a really brutal World Series. So much like random luck just happened out of nowhere. What's up, X-Man? Okay. We choose a pair of gears, G3 and G4. Pressure angle, 20 degrees, spur gears. Show that both gears have the same diametral pitch. I have no clue what diametral pitch is. Check if there is interference. Compute the contact ratio. Pressure angle is 20 degrees. Okay. Well, y'all gonna learn something with me because I'm gonna have ChatGPT solve this, and I'm just curious. We're gonna learn. We love learning. I learn stuff. I learn new stuff every day, dude. We're gonna learn about gears. I don't think I've ever done this. Yeah, also it's Imperial units, dude. Get out of here, Imperial. Bum, bum. Dude, damn, it's like it has to write code for this? Dude, what is it doing? Excuse me? The addendum radius of the gear shouldn't exceed the radius of the pinion's base circle? Dude, what is this? Maybe the torque translation. Yeah, maybe there is some physics in here. Maybe. That would be nice if there's a little bit of physics in here. So much engineering just seems like, I don't know, bastardized simplifications of physics. Interesting. But this is, I mean, this is cool. I've always thought about like how do gears mesh to each other and stuff. Question, is the phase current on delta connection the same as the line current? What? Like what, for an AC circuit? Phase current on the delta connection. Okay, this is taking a while to solve. Okay. Oh wow, we've hit the 20. I've hit the 20 on the cap. I'm not sure, Alexander, yet. That sounds like kind of a specific EE thing. Oh, here we go. Wait, we got some answers. Here we pick gears G3 and G4 from the table. N1 is 16 teeth. Pitch diameter is that. N2 is that. Large guy says no. Great. Some people in my chat apparently know. I love that. We're bringing in the smart people.
Good job.
Here, let me increase the. I'm gonna increase the counter on it for you guys a little bit. 1 sec. What was it on? I think it's on submit. Ooh, Max Q. Sorry, where's Max Q? Okay, there we go. Okay, should be able to upload more. Okay, I do not know about teeth and gears, so this is an example of a question. I'm gonna put it into my Discord, but I will paste a solution for you here. Where was it? There we go. We'll share this, and we'll see what the next thing is. Cool. Copy. Nice. Okay. Let's see what the next one is. Next one is... Ooh. This is great. I like this. Send to the engineering gods. Yes. Y'all who are actually answering in my chat, if you'd like to join our Discord, all the questions I post get put there. And if you'd like to explain or answer some of them, I would love to have your help. I'd really appreciate it, honestly. I teach everything like math and science from middle school up to college, but occasionally I'll get asked like engineering questions, and I am looking for some people who want to help out in engineering, because it is one of the harder things to find tutors for, because most people who are good at engineering don't teach. They go make a lot more money being engineers. Yeah. Parthenons, yeah. Okay, let's see this. A project is launched from the top of a cliff above level ground. Yeah, 37 is a nice 345. That is true, Femvox. Because engineers forget everything after their bachelor's. No. Oh, no. Okay, at launch, 37 is nice. Yeah, this is a 345, right, Fem? Okay, all good, Large. Thanks for coming by. We'll probably still do it. It'll just get added into the Discord. So if you want to see it, join our Discord, and we'll post the solution for you. Thanks for being here. Thanks for being a part of it. Okay, at launch, the projectile is 35. So this is 35. 35 above. And has a velocity of, yeah, dude, Femvox, they literally just made this. Dude, this is so fun. They made this 50, but they made this 37 degrees, right? This is literally a 345. Okay. And they also made G equal to 10. This is the nicest numbers on a physics question. Yeah. Jesus loves you all. Thank you, Chris. I need some more Christ in my life. I always say that. Like, I need more people praying for me at some point. Okay. So, first thing you do, whenever you have a velocity being shot at an angle, you want to break this into components. So, we're going to say, like, V naught X is equal to 50 cosine of 37 degrees. And then V naught Y is equal to 50 sine of 37 degrees. It turns out that this ends up equaling 40 and this equals 30. The reason why, and then this is why me and Femvox are talking about, this is such a nice question, is that when you have a 3, 4, 5 triangle, this is a Pythagorean triple, 3 squared plus 4 squared equals 5 squared. That's also the same as 30, 40, 50, where this thing right here is, well, actually, let me change it around. Sorry, let me make it this way. 40, 30, 50. This is 37 degrees. This is 53 degrees. And this is 90. So we know this triangle. So when I see this 50 and 37 degrees, I'm over the moon, dude, because I don't have to do much math. Who let the math prof write the physics question, right, Fluffy?
Good job.
It's pretty dope. Okay, anyway, so this is 40. This is 30 meters per second. Total time from launch until it hits the ground. Okay, so that means we really only care about when y is equal to 0. We want to figure out when that y equation is equal to 0. So from kinematics, right? Y is equal to y naught plus v naught yt plus 1/2 at squared. Exactly. Yeah, exactly, DMs. So the final height is 0. The initial height is 35. The initial velocity in the y direction is 30. So plus 30t. And then this is plus 1/2 a, but they say a is equal to, so a is equal to negative g. The acceleration due to gravity points down. And so that's going to be negative 10. So this is going to be minus 5t squared. Beautiful. I know a is 9.81, but dude, look what they said. Look what they said. Motombo, dude, they said this. I agree. It's horrific to use g equals 10. It's like saying pi is equal to 3. But we're just going based off what they did. Because I think this is nice. Watch what happens here. So, this is what you're solving for. You can divide through by 5. And you end up getting, t squared minus 6t minus 7 is equal to 0. E equals pi. Don't choose violence, dude. Oh, this is beautiful, dude, because look at this. This is negative 7 and 1. So you get t minus 7, t plus 1. So t equals 7. Wow. So the total time is equal to 7 seconds. The horizontal distance, that's cool. So horizontal distance is equal to your velocity horizontally times how long you're in the air going horizontally. That website, actualofficehours.com. It should let you submit. Let's see. I changed the buffer so it accepts over 20 now. Used to be only 20. So this is equal to v naught x times the time it's in the air, which we know is 7 seconds. So that's going to be equal to 40 times 7. So that's equal to 280 meters. Great. Calculate the speed of the projectile at A, B, and C. This is so fun. Well, at B, it's at the same height. So by conservation of energy, your kinetic energy plus your potential energy has to always add up to the same number. If you have the same potential, that means you must also have the same kinetic. So, VB equals V naught, and so that's going to equal to 50. At position A, you do not have any velocity in the in the y direction, right? Because you go from being up to not so up to not so up to like, oh, we stopped going up and now we start going down. So, at position A, this is just equal to V naught y, and so that's equal to 30. And then the question is, what happens at C? Okay. At C, V final x is equal to the same 40. V final y is equal to, so that's going to be V naught plus AT. So that's going to be 30 minus 10 times 7. Oh, wow. 30 minus 70. It's equal to negative 40. Okay, so VC is equal to the square root of 40 squared plus 40 plus minus 40 squared. Oh, this is too funny. Square root of 3200. Or, square root of 80, right? Is it just square root of 80? Do I have that right? Space engineering. I might not be able to do it, but if I can't, it'll get added to our Discord, and maybe an engineering person will take a stab at it. Boom, 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 boom. Right? 40. This is an isosceles. This is 40. This is 40. So this should be square root of 80, right? That seems kind of weird, though. Right, isn't it? 1 square root of 2? Yeah. Oh, it's 40 square root of 2. I'm retarded. Sorry. Uh-oh. 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 I'm starting to get sleepy. We've been streaming for 4 hours. Yeah, sorry. It's 40 square root of 2. I was getting too clever with my triangles. Matombu. Right, this is 1 square root of 2. So if I multiply this by 40, this is 40. This is 40 square root of 2. Okay. So VC is equal to 40 square root of 2. Nice. Good question. Nice. Who was this? Ite? Ite. Nice. Okay. Let me see the next one, and if I want to I might take 5 minutes just to go to the bathroom and grab a Red Bull. What's the next one gonna be? Simpsons Rule. Ooh, this will be fun. Okay, I'm gonna be back in like 5 minutes. Okay, so hang tight, and we'll resume the stream when I get back. You guys miss me? Ugh. All right. We missed you. I missed eating too. One second, I gotta fix my green screen. All right. There we go. The most important thing. Red Bull. I think for the 24-hour stream, I'm definitely gonna have to go like do Adderall or something. Like caffeine, I can do 10. It's fine. 24 is like superhuman. Okay. And we got some soup. I love soup. Sometimes I'd like come back from music festivals at like 3 o'clock in the morning, and we're heading back to the RV, and I'm just like screaming like I'm gonna go fuck up some soup. I have a very special soup. This is a dill pickle cup of noodles. I love pickles too. I'm a very big pickle fan. I'm a pickle fiend. So yeah, we're gonna have some pickle noodles too. All right, let's lock in. We got 6 more hours. Red Bull gives you energy. It's true. They were really nice to us at TwitchCon, by the way. Red Bull hooked it the fuck up. They had this whole area. It was called like the Creator Club or something, or Creator Stop, and they just had like free sushi, free drinks, free. I didn't pay for any food at TwitchCon. I got fed by Red Bull the whole time. How long have we been on? I think we've been on for 4 hours and 5 minutes. We're going to 10. All right. Use Simpson's rule with 4 intervals to estimate this nasty integral. Interesting. I need to remember Simpson's rule because I don't remember it. Da-da-da-da. Oh, okay. Wait, so it's just a Riemann sum? Is that Simpson's rule? Wait, what is weird about Simpson's rule? what the hell is Simpson's rule? Oh, using quadratic polynomials. This dropped me an entire grade? I mean, that sucks, dude. I'm trying to understand. Oh. Yo, what? That's nuts. It is an interpolation. This is cool. I don't think I've ever seen this before. So it's W over 3 times W times Y first plus 4 times Y of the odds. Oh, it's using a lot of naval architecture. I don't think I've ever seen this. It's pretty cool though. And then I guess you add them, right? If you still, I don't know why it works. That's pretty cool. Typic says this is A-level further maths. I don't think I've ever seen this. Maybe some of my other math people have seen this. Okay. I'm gonna steal this. And W is the width. Yeah. W is the width. And then Y is... Okay, cool. Got it. Okay. Very cool. Yeah, we can do this numerically too. We'll do this numerically. We'll see how close we get. I'm actually kind of curious about this. Okay, so 4 intervals, right? E to the x squared probably looks something like an exponential, no? It's like an exponential to an exponential. And we're going from 0.4 to 2. So it probably looks something like this. Looks like something I would solve. Yeah, correct, dude. Yes, I agree. Okay. And it's going from... We're going to say from like 0.4 to 2. This was on your further maths A levels? Is that what you're saying? It's kind of mean. All right, 4 intervals. Does that mean 4 sections? Or like, so for instance, this would be 2 intervals, right? So this would be 3. So then, okay, gotcha. I don't personally do real analysis, but I have a lot of other awesome math and science friends who, my PhD's in physics, but their PhDs are in math. So if you want to submit your question anyways, if I can't do it, I'll add it to our Discord queue, and they might take an attempt at it during their streams. Also, if you want to figure out when they stream, the same website there that you use to submit the screenshots, there's a calendar that shows all the other awesome math people that stream. Yeah, I was looking at it for a while, so let me know. Well, okay, well, let's get to it. So this is 4 sections. We agree? Yeah, you're welcome, Meep. Okay, so I gotta divide this into 1, 2, 3, 4. So I think I do 0.4 plus 2 all over 5? No, over 4 to get the widths. So that's gonna be 2.4 over 4, which is equal to 0.6. Okay, let's see if that makes sense. So this is like 1, and then 1.6. Does that make sense? 1.6, and this is 2.2. Oh, this is already. Oh, this is bad. Sorry. 0.4 plus 2 is 2.4. 2. Am I fucking up here? Divided by 6, right? Oh, you subtract them. Sorry, this is the average. I'm dumb. Sorry. It's 1.6 over 4. Uh-oh. Uh-oh. The timing of the stream is starting to get to me. Okay, 0.8, 1.2, 1.6, and 2. Great. Okay, awesome. So the first one... Okay, so the width is 0.4. Okay, so we know it's 0.4... And I guess it's always divided by 3. I don't know why it's divided by 3, but that's fun. And then it's y at the first. So that's e to the 0.4 squared. And then also the last one. So plus e to the 2 squared. Okay. And then the odd ones. Okay. So the odd ones... What do they call the odd ones and the even ones? Okay, so it's literally 1, 2, 3, 4. Okay, fine. Okay, so these are the odd ones. The purple ones are this. This is odd. This is odd. And then the even one is just the one in the middle. Okay. So it's plus 4 times e to the 0.8 squared plus e to the 1.6 squared. And then plus 2 times e to the 1.2 squared. This is just a mess, dude. Are you allowed to use a calculator on this? Do I get like some sort of calculator? Like, what? Calculators are allowed. Thank God. What? Okay. Let me see if I can simplify this at all. So 0.4 over 3. And then this is going to be like e to the 0.16 plus e to the 4 plus 4e to the 0.64 plus 4e to the 2.56 plus 2e to the 1.44. Okay. Let's just take our calculator out and see what happens. I don't see what this really teaches you other than like mechanical integrals like absolutely suck. Okay. E to the 0.16 plus e to the 4 plus e to the 0.64 plus e to the 2.56. Oh, wait. But these had 4s on them. Uh-oh. Don't mess up, boys. It is a TI-84 emulator. It's the gold edition, though. This is plus 2e to the... Wait, no. This e. Sorry, wrong e. E to the 1.44. Okay. Oh, dear. I did something wrong on the syntax. What did I do wrong on the syntax? This is all okay. Don't get mad at me. Oh, I didn't put another... Sorry, parentheses. Yeah, whatever. Okay. And then what was it? 0.4... Ooh. What is SDE? Standard differential equation? I can do differential equations. Alright, let's see what we got. 16.47. Cool. Seems a little high, but maybe. Oh, stochastic. Oh, probably not. No. I don't know about... So you sum up the number of odd ones. That's what I'm implying from this. So... Let's look at this one, Matumbo, for instance, right? Here, there are 2 odd ones, right? Index 1 and index 3. And there's only 1 even, number 2. Here, I have 2 odd ones, right? Index 1, index 3, and only 1 even, index 2. Oop. We gotta tell TikTok that we're actually still live. It is a really strange formula. Yeah, I actually don't know where it comes from. We can research it a little bit if we want to. I mean, the queue's already at 21 questions, so I invite you to look into this as inspiration for like, where the hell did this come from? Okay, 16.47. Now let's evaluate that like numerically, because I can also do that on the calculator. If you go to, what is it? I think it's math. There should be an integrate. Yeah, fint. I think it's numerical into, yeah, fint. Here you go. And so we're going from 0.4 to 2 of... This was like an exercise, yeah. So this is e to the x squared dx, right? Okay. Oh, it's pretty close. 16.03. I don't know, like, how much better is that than just doing a much simpler, you know, Riemann sum? I don't know why that algorithm works. It's pretty cool, though. Anyways, cool question, Tippik. Now solve it by hand? No, dude. I like life. Okay, cool. Let's add that one to the roster. It's just an approximation method. Someone said it was used in naval shit. What was that? You said Navy stuff? That's pretty cool. Typic. Mark is done. Naval architecture and shipbuilding. I always find it fascinating, dude, that we made these massive fucking things like back in the day. Without any like computer technology. Right? It's pretty cool. Okay, let's see what we got next on the queue. Spicy chicken nuggies with partial integration. Yeah, so wait, how would you like algebraically integrate that? That's a good question. I think this is a Gaussian integral. I believe this is a Gaussian. And it's just kind of a... It's this, right? I think, yeah, it's the square root of... Well, that's from negative infinity to infinity. The sunflower of death and despair. Oh, I guess these are from infinity to infinity. These don't have, like, bounds on them. Equally tangent to the central circle, and then sequentially tangent to each other. Wow. Then R can be written as the square root of A plus square root of B plus C, where A, B, and C are integers. Whoa. Okay. Well, I know angles at least, right? Like, I know this to this is 30 degrees, yeah? If it's divided by 12, right? I don't know. I'm thinking something like this. So if this is 1 and this is 1. Oh, this is 1. This is 1. Right? I think I can split this, yeah? And then if they're tangent to each other, they gotta be tangent there, right? Oh, I think I got this. I don't think this is as much death and despair. Because then that tells me this is 60 degrees. No. 75. A Tarsha? What's a Tarsha puzzle? That sounds scary. Don't hurt me. Can you prove the derivatives? Yeah, I probably could. I think I'd do like a limit definition of it. Okay, I think I'm close on this one, though. 30 degrees. And then this we know is equal to r, right? Can I find out this distance? I think I can. I can do law of cosines, right? Yeah. Wait, so... Alright, because this is r plus 1. This is r plus 1. This is 1. And then I have 2 unknowns, I guess. Let's just call this x. Let me just do that. So... It is law of cosines, right? Yeah, I thought so. But I need like 2 equations, I think. Because I have 2 unknowns, right? Or, oh, I think you're right. I think you're right. Yeah, let's just do law of cosines. Okay. So x squared is equal to 1 plus r. Well, I know this whole thing is 30 degrees, right? To go from 1 to 1. And then, since these are tangent also here, that tells me this is a straight line. Then, I'm going to do, like, law of cosines here. Plus, what is this? 1 squared minus 2, 1 plus r times 1. And then this is cosine of 75 degrees. But then, I need a second equation to knock out x, right? Which I was tempted to do with sine. I wanted to say that sine of 75 degrees over x is equal to, right? Sine of 75 over x is the same thing as like sine of 15 over 1. Right? So now I get that x is equal to sine 75 degrees over the sine of 15 degrees. Yeah? Getting closer. Okay. So then plug it back in. So we get sine 75 over sine 15 squared is equal to... I can try to do engineering questions. You can always submit them, and if I can't do them, they just get put into our Discord for other people who maybe... Or even my chat. My chat has a lot of really cool engineering people watching that may want to help you out. Yes, and then I'm going to get that sine 15. I'm going to get it. 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 Don't worry. Well, also because sine of x... sorry, sine of pi minus x, I'm pretty sure is equal to negative sine of x. Right? Let's think. Which one was yours, Armand? Right, think about it this way, right? If this was, for instance, x, let's say this is like 135 degrees. The sine of this is the same thing as the sine of 180 minus that. Oh, so it's just equal to sine of x, sorry. Sine of pi minus x is equal to sine of x. Right? I think that's true. Let me see. Sine identity. Sine pi minus x. Yeah, sine of pi minus x is equal to sine of x. Okay. And so... Oh, but this is 75 and 15. Oh, I need sine of pi over 2 minus x. Okay. That's different. But that is another identity we have. One second, let me go find it. I've done it before. Where are you, Trig? There you are. Gotcha. Gotcha! Gotcha! Yeah, this is probably handy. I think specifically what I'm going to want is one of these. Sine of pi over 2 minus x. So 90 minus 15 is sine of 75, right? So I'm gonna get the cosine of 75. This is gonna be like a tangent. This is actually really cool. All right, but here, let's just keep working. 1 squared plus 2r plus r squared plus 1. Okay, and then it's minus 2 cosine 75 degrees minus 2r cosine 75 degrees. Oh, you're 15th in the queue? Okay. Yeah. We've had a lot. I'm doing a 10-hour stream, so don't worry. I will get to it. I think once we get into the last, like, 2 hours, then I'll say that I'm not getting past 20. Okay. Alright, let's lock in. Let's try to find it. Because I want to get R. R is equal to the square root of A plus the square root of B plus C. I'm very good at physics. I have a PhD in physics. This is like this is like a tricky like math Olympiad type question. Do we want everything in terms of sines or cosines? It will pop up eventually, 100%. One over 5 minus 2 square root of 6. I think it's easier to simplify. Which one was that for, Joel, though? That's what sine is? Sine of which one? 15? Ooh. Yeah, that can be difficult, honestly, to do physics if you don't really know math. Or, like, if you have hard times with math. Because physics is very much based on math. I say, like, math was invented for physics. Oh, thank you, Jack. Yeah. Because I think how I want to write this is... Yeah, setting up the equation is always the hard part. The math kind of comes afterwards. Okay. I feel like I want the half angle identity. Where did you get that from, Joel, by the way, for this? So... Oh, it's provided? I don't think it's provided here, though, no. Covariant and contravariant. I don't know about that. But yes, I agree with this. We can write this as a quadratic, right? I can say this is r squared plus 2r, right? So there's the r squared, 2r, 1 minus the cosine of 75 degrees. And then this is 2, right? And then that's plus 2. And that's 1 minus the cosine of 75 degrees. And that's equal to this. And then I feel like I want everything in terms of cosine, just real quick. Thanks for the Rose. So sine of 90 minus x is equal to the cosine of x. So sine of 75, which is equal to the sine of 90 minus 15, is equal to the cosine of 15. Or maybe I want to keep things... I think I want to keep things in terms of 75 degrees, maybe. Well... Okay, so that's cosine of 15. So then... Sine of 15... I teach physics at UCLA. Is equal to the sine of 90 minus 15. which is equal to the cosine of 75. Wait. Okay, so then this is equal to cosine. Yeah, where are you getting the square root of 3 over 2, though? Spicy chicken nugget. Undergrad. Okay, so we had a 2r and a 2r cosine 75. That's why this is a 2. I had 1 squared, so that's 2 minus 2 cosine of 75. So that's why that's 1 minus cosine of 75. And then here, I'm thinking about... Oh, you live next to UCLA. Nice. I live on Bundy in Santa Monica. Come visit me right now. Ooh, why did you do cosine of 30, though? How are you doing cosine of 30? Oh, I see. You're doing this. Oh, you don't even need the x. Oh, that's so much smarter. Yeah, I feel like this sucks. Oh, that's cool. Yeah, nice. Tell them physics is dope. Yeah, I taught 1B over the summer, and I taught 5A spring quarter last year. Step questions. Wait, is that like nursing stuff? Step questions? Iago? Maybe not. I think the 30 is smart, but then we still have the 15 in there. Step bro. I'm so close. Plasma physics. That's my favorite type of physics. My favorite type of physics to teach, though, E&M. Okay. Let's do it, yay. Okay. So then what? X equals negative b. So negative 2, 1 minus cosine of 75 degrees. Plus or minus the square root of b squared. Minus 4 times 1 times this really hot mess. What song? The song that's playing right now? It's all AI generated. Dude, there's gotta be a better way. There's gotta be a better way than doing this. I've done some Olympiad questions today. I feel like this is an Olympiad type question. This is all AI generated, yeah. No, I would never get this in my class. This is someone just asking me a funny, hard question on YouTube. Where can you find my thesis? I have it here if you want it. This is my thesis. Someone asked me about me earlier. Just look up my full name, Giovanni DeGangi Rossi. Here. I don't know if I can paste this in. Yeah. Troy Carter was my advisor. But yeah, you go read it. A is 45 and B is 30. Wait, that can't make sense. We need A plus B plus C to equal, like, a nice number. I'm gonna go read. Have fun reading it. It's very interesting. Also, I feel like we have to take the positive solution anyways, right? Yeah. All of this music is AI generated, because otherwise if I played actual music, they would like bop me for like monetization. No. So I just use like Suno to just generate pretty chill lo-fi stuff. Okay. This is not anything nice. My life is a lie. Let's see what ChatGPT would do. There's no harm in using ChatGPT for a little bit of inspiration, you know? That's what I say. Yeah, maybe there is. So let's just see. I always like to see what chat comes up with, and then it's like inspo. Like, if it's cool, then it's cool. Dude, it got in like 4 lines. What? Excuse me? What? God damn it. The answer's 7, apparently. I'm sorry, I'm gonna go over it. I'm gonna go over the answer. This was a valiant attempt, ladies and gentlemen. It really was. Like, we really tried. Yeah, dude, it was 4 lines, apparently, for this solution, dude. Okay, R equals R plus 1. I agree with that. From the big center to any small center. Cool. Adjacent small circles are tangent, so the distance between the adjacent small centers is 2. With 12 around a circle, the central angle between them is pi over 6, 30 degrees. That's what we said. Cool. We were correct in our initial thing. Hence the chord length satisfies. Oh, C. Yeah, I don't know where this comes from. 2 is equal to 2r sine pi over 12. The chord, yeah, of course. It's the chord length. Dude, what the fuck's the chord length formula? What?
You gotta get in the hospital now.
What?
And I just said, just shut up.
Wait, I have a question kind of unrelated to this. What is your question? Ooh, FLR effects could be added to gyroflute or kinetic correction. So I didn't do much. You're talking about finite Larmor radius stuff. I didn't do much, like, in the term of, like, well, FLR is what I eventually ended up saying was the reason why I observed what I did, because the theorist who originally kind of, like, supported my work ended up not doing a great job. Like, they published something and it ended up being wrong, so I just, like, kind of slapped, like, oh, it's probably finite Larmor radius. I definitely teach F equals MA. Yeah. He put your thesis into ChatGPT and made it make smart questions. I was like, bro, I haven't heard finite Larmor radius shit in, like, 5 years, dude. What? How do you know about this as an undergrad? Okay, I want to know what this chord equation is, though. Sorry, what chord length? What is chord length? What's this chord length? Oh, arc length times theta. Oh, this. Oh. This is cool. I didn't know about this. Where the fuck does this come from? Length from 2 random points on the circumference. Oh, I see. And the radius is big R. Oh, fuck a duck, dude. Wow, that's cool. I see. I see. I think I see how this works. Yeah. Yeah, resistive drift alphane waves, yeah. Yeah. Welcome to grad school. It's all very scary. Okay, so this was little r plus 1. This was equal to 2, right? And then, let me see how this comes about, though. Okay, because if this is r, this is r. I agree this is s theta, right? But where does this come from, by the way? Sorry? D is equal to 2RS. I've never seen this before. This is a cool formula, though, but I get it. Once you get that, yeah, you say that 2 is equal to 2R plus 1 sine of 15 degrees, right? What is D? So D is the distance between 2 points. So here's what we're doing. We're creating like an even bigger circle here. No. D is the distance. Here, watch, I'll show you. So imagine I have a circle that goes through all the center of the smaller circles. Then this and this, okay? This is going to be R plus 1. But then this distance right here, that's equal to D, which is equal to 2. Oh, use the cosine identity. Okay, so you're saying that 2R squared cosine, because where is that coming from then? Sorry. Is it kind of like a half angle thing that's happening? This is a double angle though. Yeah. I agree with that. Yeah, no, I agree that's okay. So are you saying on this triangle I have D squared is equal to R squared plus R squared minus 2 2R squared cosine of T, right? No, I'm not in grad school. Dude, I finished grad school a long time ago. Equilateral triangle. Well, it's not equilateral. It's isosceles. Okay. And then I'm curious. Oh, sorry. So D squared is equal to 2R squared minus 2R squared cosine T. So D squared is equal to 2R squared 1 minus cosine of T. Oh, sorry. Is this cosine squared T? Sorry, did I? Oh, sorry, what is? Sorry. Oh, okay, that's where I messed up. Okay, and I did that here actually. Yeah, this should have been cosine squared. Oh, it's not. Wow, what's up, Walking Stick? Thanks for the raid. Shout out to Walking Stick Library. Thanks, I appreciate it. We're doing a 10-hour stream to celebrate 10,000 follows on 10,000 subs on Instagram. Not Instagram, sorry. On what is it? YouTube. Yeah, look. Now we're up to 10,158. Pretty cool. Woo! Yeah. If you bisect the angle, you get 2 right triangles. I agree. Oh, wait. I think I'm starting to see what you're saying. Yes, this becomes T over 2. Okay, and this is 90 degrees. So this is D over 2, this distance right here. Oh, okay. So sine of T over 2 is equal to opposite D over 2 divided by the hypotenuse 1 over R. Oh, that's brilliant. Okay, so D is equal to 2R sine of T over 2. Oh, so you actually didn't need to do this. Okay, very cool. Okay, I understand where it comes from now. Alright, so all that was left to do is to actually figure out what the sine of 15 degrees is. Which I think one of you guys said it. Something with square root of 2 square root of 6. Right? Very cool. How would you get the sine of 15 degrees? You need a half angle formula, no? Sine of... I think you need to, like, use one of these, right? I know it's 1/6 of sine pi. Are you going to do a multiplying thing? Well, I don't know what... no. So I'm just trying to see, like, how that works. I think you do something maybe with this. I lied, Moto. It's okay. So, cosine of 30 is equal to 1 minus 2 sine squared of 15, right? If we use this. So, cosine of 30, I know, is equal to 1/2. So, 1/2 minus 1 is equal to negative 2 sine of 15 degrees. Is that right? Sorry, cosine of 30 is square root of 3 over 2. Sorry, not 1/2. That's sine of 30. Square root of 3 over 2 minus 1 is equal to negative 2 sine squared of 15 degrees, right? If I'm using this rule. So, square root of 3... So, 1/2 minus square root of 3 over 4 is equal to sine squared of 15 degrees. Okay. Oh, so then it's another square root. So 2 minus the square root of 3 over 4 is equal to sine squared 15. But then I got a square root again? The trig identities. Okay, because I need... Do I need sine squared? No, I just need sine. Okay. How does this become just square root of 6? That's my answer. That's my question. I don't want to use a calculator. I feel like you should be able to do this without a calculator. And also, it's kind of like an exercise for my brain. Conjugate top and bottom. We're kind of already set. I have to square root both sides, though. Like, that's gonna be square root of a square root. I like jack-o'-lantern's idea, though. Well, it doesn't have to equal an integer. It has to be of this form. Square root of a plus square root of b plus c. Yeah, you're not allowed to use calculators. I liked jack-o'-lantern was going to do the difference of signs. Yeah. So in this case, right? Oh, sorry. Sine of 45 minus 50, minus 15. Or sorry, minus 30, right? Demois theorem? I've done it at some point. This is sine 45 cosine 30 minus cosine 45 sine of 30. So this is square root of 2 over 2, square root of 3 over 2, minus, oh, I see it, square root of 2 over 2, 1/2. So you get square root of 6 over 4 minus square root of 2 over 4. Okay. Square root of 6 minus square root of 2 all over 4. Yeah. Sorry, there's a lot going on in my chat. Square root of 6 minus square root of 2 all over 4. So 2 is equal to 2r plus 1. And then over 4. And then we have square root of 6 plus square root of 6 minus square root of 2. Okay. Very cool. Oh, man. Brother. Well, I can cancel this. Four over the square root of 6 minus the square root of 2 is equal to r plus 1. Oh, man. And then, yeah, you got to rationalize this, I guess. So, 4 square root of 6 plus 4 square root of 2 over 6 minus 2, which is 4, is equal to r plus 1. Okay, we're getting close. Square root of 6 plus square root of 2 is equal to r plus 1. R is equal to 1 plus the square root of 2 plus the square root of 6, which is 1 plus 2 plus 6 equals 7. Okay, done it. We did it. Oh my god. Oh my god. Don't get me the minus 1. Okay, my bad. Oh, it's 6-7. No.
That's dope.
Oh my fucking god, dude. What? The answer 7. 1 plus 2 plus 6 equal to 7. Yeah, I'm just done. I'm just done with it. I'm done. I'm just done. I'm just so done with that question. I'm just so done. It's like, no more. We've almost reached the halfway point of our 10-hour stream, by the way. I feel like, yeah, this question was a fun little, like, lunch break question, dinner break. I needed to eat something. I haven't eaten, like, all day. Starts strong, finishes very weak. Yeah. Don't worry, once I crush this soup, I'm gonna be rejuvenated for the next 5 hours. Alright. GG. Yeah, good job. Whose question was that, by the way? I'm gonna stream for 5 more hours. I'm doing a 10-hour stream to celebrate getting 10,000 subscriptions on YouTube. And so we're halfway there. UC is a great school. I enjoyed it. I did it for my PhD, and I've taught there. Like, it's a great place. All right, next up is Mitochondria Mommy. It's an interesting name. But first, let's add this one. Where was this? Wasn't this. It's my thesis. Yeah, it was this. Okay. The Nuggies got us, dude. That was a beautiful question. I learned a lot from it, honestly. There were so many different ways to attack it, and it's so funny how, like, some of them just ended up being, like, horrendous fucking algebra. No. But then, like, this little sliver of, like, hey, if you just go down the golden path and you get this exact little way of doing it, everything works out really nice. I would love... my PhD's in plasma physics. I would love to get accepted into UCLA. It's just insane in California. Dude, you're preaching to the choir, man, dude. My rent is not cheap. And like, groceries are ridiculous these days, dude. I went to Costco. I spent fucking $600. Just like food. I didn't even get any liquor or anything. I was just like buying food. I was like, what? Am I throwing a party for myself? Why is this $600? Yeah, I don't know, dude. Yeah. Price of shit is nuts. Yo, we got some guns and some... No, dude, no. It is horrendous trying to eat out in LA. I went and got like a burger, a fries, and it ended up being like $25. I can't eat out for under like $20 anymore. It just doesn't happen unless I go to In-N-Out and like actively try. But any of these other places, minimum $20 just to eat. I buy steak. Well, dude, I'm living off of soup right now, so. And water bottles. Yeah. And we got Red Bull. Shout out Red Bull. Thank you. This is a Lockheed Martin question. Why? Because there's a gun involved. It's like the B-32 Raider drops a 500,000 pound bomb on a tent in Iraq. No. Okay, the launching mechanism of a toy gun consists of a spring. Yes. It's compressed 16.5 and the gun is fired vertically. Calculate the maximum height to which the gun can launch a 25-gram projectile relative to the starting point that it's compressed at. This is cool, actually. So wait a minute. Interesting. They're calling this x equals 0. Okay, fine. Okay, energy before. So this is right before it's launched. So you're going to have spring potential energy, which is going to be 1/2 kx squared. You're also going to have negative potential gravitational energy because you're technically below x equals 0. So you say minus mgx. Dude, if you can even get a job these days in computer engineering, I would fucking take it, dude. And then plus 0. Okay. Okay, and then energy after at the maximum height. Okay. This is going to go away. Kinetic will also be 0, right? So you're just going to have mg, let's call it like x prime, I guess. Right? It's actually not too bad. There is no 1/2 mb squared, because at the bottom, right before it shoots off, it's at rest, and when it reaches its maximum height, it's also at rest. All about that mindset, yeah. You can do it. Believe in your dreams. Okay. Okay, so x prime is just equal to 1/2. You thought, dude, the sarcasm from Mathematic Fanatic. What's up, dude, by the way? I thought they were an ethical company, Lockheed Martin. Why is v equals 0 at the edge? It's not. It's 0 here. It's 0 when it's cocked, like before it's shot. Yeah, it's interesting that we said y is equal to 0 here. You're not stupid at math. Don't worry. I think this is the tricky part, is to realize that there's actually negative gravitational potential energy at the beginning. That's what's hard. Yeah, don't worry. You're not dumb. I get plenty dumb sometimes. And then this is minus... minus x, no? I submitted the second grade questions for my cousins, Lorenzo, because I told him you're a great explainer. Thank you, Fanatic. Oh, it's okay. Yeah, we are going late tonight. Yeah, we're going for 10 hours. 10-hour stream tonight. Yes, practice makes perfect. Math is all pattern recognition. You know how you get good at recognizing patterns? You see more patterns. Gotta keep seeing stuff. Good, watch. Welcome, Panda. We're looking at a conservation of energy question. So, I think we're just done here, right? This is it. So, x prime is equal to 1/2. K was equal to 550 over, you need things in kilograms, so this is unfortunately 0.025, 9.8, and then x is the amount it's compressed, which is 16.5, so that's 0.165 squared minus 0.165. I have a physics degree. My PhD is in physics. Okay. So 0.5 times 550 divided by 0.025 divided by 9.8 times 0.165. Someone looked up my thesis the other, just right now. Minus 0.165. Okay, so 30.39. That sounds about reasonable. Just look up Giovanni Rossi, UCLA physics. On like, I think it's called like pub whatever the fuck. Not here. Where is it? I will put my thesis on that link because people are always asking me like what I did. But yeah, this is what I did. Nah. Yeah, my mother's Sicilian. I'm not on physics publication. Yeah, you can find me. I did a couple publications. Alright. You like the Sicilian defense? Oh, if you like chess, we run chess tournaments in our Discord every once in a while. You should come by. They're really fun. I have some really brilliant kids who play chess really well. They like beat the shit out of me. My ranking, I think, was, I want to say 1200, maybe 1300. So like not super great, but I'm, you know, also not the worst at chess. Okay. Calculate the speed of the projectile as it moves through the equilibrium position of the spring. Oh, that's cool. So that's just all this. And then through the equilibrium position of spring, that's equal to just 1/2 mv squared, right? Because at x equals 0, you have no spring kinetic energy, spring potential energy. You have no gravitational potential energy, and so all you have is kinetic. Oh, Terrence? I haven't seen him, no, but yeah, he is at UCLA. You know, the organic chemistry tutor is also a chem professor at UCLA. Cool little known fact. People don't remember that or don't know it. Kx squared over m, right? The 1/2s cancel. Minus 2gx. I think it's just 2gx. Yeah, is equal to v squared. Yeah. It's like Manuel something. He's Hispanic. It's something like Manuel Rodriguez or something. I forget his name. He's a cool guy though. It's so funny because I don't think anyone at like the chemistry department like really knows how internet famous he is. What was X? X was compressed 0.165. 1 in Vermilion. No, he's not Asian. He's 100% Mexican, I think. I mean, maybe I'm wrong, but he had a Hispanic name from what I remember. Okay, nice. Okay, so I think that's all we need for that. So let's see. Oh, sorry, I was covering up the screen the whole time. You guys can go see. So 550 divided by 0.025. $595 meters per second. That's a fast gun. Oh, that's v squared though. Oh, square root. I was like, yo, what? what fucking toy gun here is going at 500 meters per second? Much better. Okay, 24 meters per second is around 60 miles an hour. Okay. Nice. Good question. That was actually pretty fun. Not too bad.
That's dope.
Sicilian defense is for high-rated players. It's difficult for normal people. I gotta remember what the Sicilian defense is. All right, whose was that? That was Mitochondria Mommy. Fun. Cool username, dude. Okay. I would prefer an E&M problem than a quantum mechanics problem. Just quantum tends to mess with me sometimes. E&M I'm pretty good at. I've taught E&M. Grade 10 science help. Love this. So here for the grade 10 stuff. Electromagnetics, yeah. Meters per second to miles per hour is diabolical. I mean, you just learned that. I'm pretty sure 60 miles an hour is 23 meters per second. Oh, these pickle noodles slap. Why do you know all this science? I teach a lot of it. It's kind of like, it's been my job for like the last 20 years. I teach all types of sciences. Yes, so Izab, dude, I literally just did a projectile motion question here. So we did this one. And then, where was the other projectile motion one we did? Was it? No, this was the nightmare question. This one. This was also a very good projectile motion question. There's a little bit of a queue, but if you want to submit a question, I will get to it eventually. We're doing a 10-hour stream today to celebrate 10K on YouTube. You can upload at actualofficehours.com, that link right there. And then when you click on that link, there's also a lot of other cool information, such as the schedule. So this is when me and I also have some other great friends who stream science, math stuff. So here's like a little calendar of when they do that. And then also I invite you to join the Discord because every problem I do here from students, I post the solutions into Discord. And if I don't get to them by the end of the stream, someone else in my Discord will answer it. I have a Wacom tablet. That's what I do. Calculate the absolute refractive index of a clear passing material if the velocity of the velocity of light in the plastic is that. Oh, okay. So correct me if I'm wrong. I think N is equal to C over V. So that's equal to 3 times 10 to the 8th over 2.5 times 10 to the 8th. Which we can simplify that, right? That's the same thing as like 30 over 25. Which divided by 5 is 6 over 5. So about 1.2. It's a pretty cool N. Yes, cool. All right, a ray of light is incident at an angle 40.8 degrees on the surface of the same plastic material. Determine the angle of refraction. Okay. So I believe this is Snell's law. So this is question 1. Question 2 is Snell's, which says that N1 sine theta 1 is equal to N2 sine theta 2. This is pretty intense for a 10th grader. So kind of like this. This is theta 2, N2, and this is theta 1, N1. He who snelt it dealt it. Y'all are fucking hilarious. He who snelt it dealt it. Oh man. Okay, here's the cool thing. So N for air is always equal to 1. The other important one is that, like, N for water is 1.3 repeating. So, we have 1 sine of 40.8 degrees. And then it's equal to N2, so that's 1.2 sine theta 2. Okay. So sine theta 2 is equal to this. Yeah, GG. I need the easy wins sometimes, dude. Also, yeah, especially after, like, this fucking mess, dude.
Disqualified.
Dude, this hurt me, dude. I'm gonna be talking about this to like my grandkids or something. It's like generational trauma. Okay. So we can do this. This isn't too bad. The Discord link, it's on the same website, actualofficehours.com. You should see something that says join our Discord, which is right here. Just click on that. It should work. Tell me if it doesn't. I know some international people have been having issues with it. That was like a math Olympiad question. It was like a there's competition math questions that are just hard for the sake of being hard. That's what that was. Okay. So you get sine theta 2 is equal to... I can do statics if it's not too nuts. When you start talking about like torsion and like Young's modulus, like I don't know that stuff. But if it's just torque, like moments and sum of forces, I can totally do that. Okay, so how we get for theta 2 here, this is a really cool thing. We take the inverse sine of both sides. Little known secret, right? Some of you might be wondering, like why does this work? Because this is cool. This just kills this off, right? So you get, theta 2 is equal to that. Nice. Take out your physics book. I'm glad, dude. I'm inspiring you. Also, are you from Jamaica? Are you okay? Like, what? Didn't Jamaica just get, like, absolutely wrecked by, was it Hurricane Melissa or something? I guess you must be, like, not too bad if you still have internet connection, at least. Okay, so 33 degrees. Nice. Boom, 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 boom. Nice. Good job, guys. Oh, there's a typhoon in the Philippines? A lot of people don't have light and water, but my part is fine. Bless you, dude. Nice. Yeah. I think I've been to Jamaica. I've been on like some cruises, I think, that like stopped in Jamaica at some point. That's where they also, I think they tried, was that where they tried to do Firefest that one time?
Disqualified.
God is mad. Yeah, God's been mad like pretty, I understand why God is mad, dude. If I was God, I'd be fucking pissed. No. What are you guys doing? Oh, Firefest was Aruba. Oh, thank you, Walking Stick. All right, so this was grade 10. Grade 10 science help. Nice. I remember it was some Caribbean place that it's actually pretty mean that they really like screwed over all the locals, like all the local contractors. They just like didn't pay them. Well, that's fucked up. Like I get it if, you know, Blink 182 doesn't get paid, but you know, they have tons of money, but the poor people making sandwiches in Aruba, they can't just absorb that cost. Studying for tests right now, man. Any good tips? Get the fuck off of this. No, but yeah, I would say good night's rest and don't psych yourself out. Remember that you got this, confidence. And if you absolutely have to do something like before the test, maybe take out a sheet of paper and just like write out some equations, you know, because you'll get used to doing that on the test, and it's muscle memory really does help. So yeah, it's actualofficehours.com, that website. OneZab, whatever, that website down there. That's just what it is. TikTok won't let me post links. They hide them. Nobody can post links in TikTok land. Sleep 8 hours and eat breakfast. Trust. I agree with that. I agree. All right, downloads. Nice. All right, what we got next? Marco Scott. Find the Thenoven. Ooh. Oh, I've done this. I have done this before. Alex. Yeah, so the negative sign on spring forces is always just to denote what direction it's pointing. So, I know basically what it means is like wherever delta X is pointing, the force points opposite to that. That's why the negative is there. I tend to like not really use that negative until the end, or until I kind of know like which way it needs to be pointing. So because conventions of positive and negative depend on like what you're calling up and down, and it depends on the situation. So here, just real quick before I do this Thevenin circuit question. If you have a spring like this, right? And let's say this is X. And let's say this is X equals 0. This is X is positive, and this is X is negative, right? If you pull something this way, right? Or don't stretch it, but like pull it this way, right? Your delta X, which is equal to X final minus X initial, right? That's a positive number minus 0. That's going to be a positive number because you're calling things to the right, the positive direction. Okay? So in that case, F equaling negative K delta X just means the force points opposite to where delta X points. So if you're stretching this way, your force is to the left. Where this can kind of like get weird is, let's say you're on like the other side here and you have a box, okay? But then you stretch it even, let's say this is like X is equal to 0, right? And then this is X is equal to negative, and this is X is equal to positive. Then when like you pull it this way, right? Your delta X is equal to X final, so that's a negative number. So it's a negative number, like minus 0, which is again a negative number. And then F equaling negative K delta X. Since delta X in this case is negative, you get negative K times negative, another negative, and that's why you get like positive K X. And that should make sense because the force is now pointing to the right. So when they say like when to use negative, just kind of ignore that and just say to yourself, when you're setting up force diagrams, make sure that the force of the spring is pointing opposite to where it's stretched. So if it's being stretched to the left, you need the force to point to the right. Conversely, if something is being compressed to the left, right, it also wants to go out to the right. That's also going to be a positive. Okay. I need to move this out of the way. This needs to go out of the way. I need access to things. Okay. Yeah. The negative sign is I totally get that. Students are like, when do I use the negative? You don't really. You just, when you're setting up your force diagram, just make sure it's pointing the direction you want it to. This is not AP Physics C. This is an electrical engineering course for sure. Yeah. Okay. First, I need to remember how Thevenin circuits work. I know you come up with like it's connected to a load resistor or something, right? Oh no, don't send it to the email, OneZab. Just send it to the website. There's a website here. OneZab, this website. You just drag and drop your screenshot in there and just hit submit. That's all you got to do. If you send things to my email, I won't get them. Not during this stream, at least. Yeah. Just use the website. You got it, OneZab. Alright, yeah, I can do statics. Just add it to the list. Oh, what's up, Marco? This is mine. Wow. Thank you for being here since 3 hours ago.
That's dope.
You submitted this at 6:25. It's now 9:25. I appreciate you for waiting 3 hours. Okay, let me look real quick on like how Thevenin circuit works. Okay, here we go. Hyperphysics is usually pretty good. My level of comfort is I've been streaming for 5.5 hours, so I'm already uncomfortable. Don't hurt me. Okay. Any combination of batteries and resistance with two terminals can be replaced by a single voltage source and a single series resistor. The value of E is the open circuit voltage at the terminals. Oh, very cool. And the value of R is E divided by the current when the terminals are short-circuited. Okay, so like, how do you do this? Okay, R2 does not affect this voltage. Good. Wait. In the example below, the resistance R2 does not affect this voltage. And R1, R3 provide a voltage divider. Yeah. Yes, I definitely do trig identities, please. Is the +1 on the drawing the power source? It's a voltage source for sure. Norton resistance. Man, there's so much fun stuff here. But I think what makes this tricky is you have a couple sources, right? So, well, oh, did I cut this off? I'm sorry. No, did I cut your question off? Sorry, my bad. Did I? Oh no, you cut it off. What's the highest aerospace? You can test me. Okay. Oh, wait a minute. Okay, and then this is 10 VX. Wait, does this tell me there's also a VX across? Wait, I'm confused. Wait, what? What's up, FemVox? Thank you for still being here. Voltage controlled voltage source. If I didn't do plasma, probably nonlinear dynamics. I like nonlinear dynamics. Computer science is great. I like computer science. I was vibe coding a lot recently. Let the node between the 10 and the 20 ohm resistors. Okay. I think I know how to do this one, but I'm also sleepy. Yeah. It's okay, it's okay. I'm also sleepy. Ashley says the Thevenin resistance is 24 ohms. Where do you get that from? VX is from the node after the 10 ohm and the ground. Is this the ground here? So we're saying, if this is... So VX measures between here and here? Is that what we're saying? Okay. Let's do some stuff. VX, right? And then if this is 10 VX, that means this must be also 10 VX. Dream of Dawn says, start with nodal analysis. VB is minus 10. I agree with that. Because this connects straight to this, right? So this is VB, which is equal to minus 10 volts. And VA is then equal to 0. Okay. Is that because this to this has to be 10? KVL. Where am I looping though? Is this my loop, Dream of Dawn? They don't really connect, do they? Okay. Nice. So that's 0 plus What's up, God's Dice? Okay, okay. Yeah, yeah. You measure like some device between these, I guess. Okay. So there's 10 volts across here, and what? There's like another 10 across here? What does that tell me, though? VA minus VX over 20. No, we definitely do a lot of chemistry. I've done a lot of chemistry. Difference of potential is equal to EX. Oh, across here. Because wait. Because that's what I'm writing it as, right? The numbers, Mason. What do they mean? Oh man. I know about Vesper ones up, yeah. I do. This stuff I know less about. I've done it like a long time ago. Yeah, let's collapse the two. I agree with that. You want to collapse these two into just like a 30 ohm? Yeah, let's do that. Maybe that'll help us out. Here. I'm just going to call this 10 volts. Although the issue is that like VX measures from in between those two, right? Yeah, there's a source on the left, Dreamadon. There's a 10 volt source on the left. Oh, fuck what? Oh, wait, that changes the B voltage. Right? Because this is minus 10. Isn't this also going to be like minus 10? Okay. When in doubt, I'm going to throw this at chat and maybe like we can go through it and like learn. Let's see. Let's see what chat says. I just created a 6mm gel in my garage that doesn't burn, char, or anything. Send it to me, dude. What? Gel of what? Are you like just creating like napalm? Not only 10. Yeah. Yeah, there's the 10VX plus this. I'd start. All right. Well, here. Let's see. Let's see what we say. Let the node between the 10 and the 20 ohm resistor be VX. So they're saying this is VX. Yeah. Draw 2 loops in the clockwise direction, one in the left and one on the right. Oh, so you're saying like this loop? Is that what you want me to do? You want me to do like this? And then this one. Nice, God's Dice. That's dope, dude. Both clockwise, they say. Okay, so let's do our current loops. So what? So I have 10 minus the leftmost branch is the current of the orange. Okay. So am I doing a KVL loop here though? So 10 volts minus, this is where like I want current in here, right? Okay. So I want to say this. I want to say like I times 10, right? Minus I times 20. Minus I times 120, right? And then plus 10VX is all equal to 0. Alright, you're going to want 1 for orange and 2 for blue. Thank you, Dream. And then I feel for this one, I have, and this is all I1. That works. Then find the current in terms of Vx. Okay. Okay. Let's do it. So, that's 10 plus 10 Vx minus 140 I1. 150 I1, sorry. Equal to 0. Okay. So then I1 is equal to 1 over 150. And that's 10 over 150. 1 plus Vx. So I1 is equal to 1 over 15. 1 plus Vx. And then I guess we're going to say that's the same current in here, though, right? It's wrong to assume VB is minus 10. Yes. Yeah, we agreed with that. Sorry, let's get rid of that. That's wrong. Okay, so doing the blue current, though, right? So if I went, like, across here, so that's VAB. Minus 120, which that's I1, right? Plus 10 Vx. Oh, actually, sorry, but you wanted to go clockwise. Sorry, my bad. Sorry. If I want to go clockwise, then I have 10 Vx minus 120 I1 minus VAB is equal to 0, right? Let me fix this, sorry. So VAB is equal to 10 Vx minus 120 I1. Yes, because there's current drop in the resistor. Wait, no, this should be added. Sorry, this should be added. Because current is running in this direction if we're going counterclock. Current from orange, right? That's running this direction. So when I cross it, I actually add that potential drop. Right? Yeah, current is, yeah, we use like whatever, it's like the whatever convention. Okay, but then how do I get this Thenabin? Wow, thanks for the sub, by the way, Prime. Cloudy, appreciate that. You got VThenavin is 64 volts. That is what the solution comes up with, Femvox. Solve for the current and voltage between VB and VA. So, I mean, this is the voltage between AB, right? Why I'm back. Hello. Welcome, dude. Okay, one sec. VAB equals 10 Vx plus 120 over 15 is 8. The queue is 23 questions long. It's a little long today. I'm getting like railed on this one. So what? VAB is equal to 18 Vx plus 8. Now I have to work out how to do Arthenovin with a dependent source. Oh no. I equals 10 minus Vx over 10. Vx over 10. Are you saying that from here? V over R? But this is my... But what about the 10 volt source here as well? I think measured from here to here is Vx, Blake. Oh. Here's actually an interesting thing. Okay, wait. No, we've been doing 6. This is 6.5 hours. Okay. I think I'm starting to see something here. Wait, one sec. Okay. All right, let's call this Vx. I agree with... Let's try to walk through this. This is Vx, all right? The current here, right? If we measured this referenced to here, right? So Vx down another 10 volts all over 10, because that's the resistance here, right? That's the current at this location. Yeah? Because Vx is referenced to here. This has to equal the opposite current going through here, which would be negative Vx minus Va over 20. Okay? Or I guess the other way to write this is equal to, right? Whatever the current is here has to be the same current here because they're in series. So this is equal to Va minus Vx all over 20. Right? Let's call this whatever. Like, this is I, right? I is equal to this voltage minus this. Because I can't reference it to here. Because Vx is referenced to here, and there's another 10 volts in between it. Yes. I think I got this. Okay. And then at A, yeah, this is positive for sure. Va minus Vx over 20. So this current in here I think I'm starting to get it. Do we assume there's no current here? Right, if this is open, right? Current is equal to 0. So here, this is like I2, which equals to 0. Has to be equal to like I1 plus I3, I guess. Yes, okay. So, and this is at VA, right? So VA minus Vx divided by 20. That gives me the current I1. That plus the current that's coming through I3, which is VA minus 10 Vx, right? I guess we assume this is at like ground maybe. Okay, VA minus 10 Vx. Bro, I do not miss this. I don't either. I'm teaching myself it, honestly, along the way. And this is equal to 0. This is I1. Okay, I2. Okay. You got V Thenemin as negative 200 over 7. Femvox got 64, and I'm tempted to believe that. Because it is the same answer ChatGPT eventually gets. Okay. Hey, Feminomenon! What's up? We're doing some really difficult electrical engineering questions. If anybody wants to see what the question is, again, go to the website, actualofficehours.com. Marco Scott, who has been waiting patiently for the last 3 hours, because we've had such a line of questions today. This is his question we're doing. Yeah. You think this KVL? Or I thought I already got this. I1 is equal to 1 over 15 plus Vx. Which is VA minus Vx over 20. But then I still need VA. You're on 3-phase transformers? Okay. Okay, so, I mean, this is 2 equations, 2 unknowns. We should be able to solve it. Right? Okay, so 2Vx. No. Man, I need to like get rid of that VA, dude. That VA's annoying. I think I can solve for VA here. 20Vx minus, or 20 over 10 is 2. Oh, so 2Vx minus 20 is equal to VA minus Vx. So VA is equal to 3Vx minus 20. Okay. Now let's plug that into here. So I get 3Vx minus 20 minus Vx over 20 plus 3Vx minus 20 minus 10Vx over 120 is equal to 0. 2Vx minus 20 all over 20 plus negative 7Vx minus 20 over 120 is equal to 0. And then I'm going to multiply through by 120, so that's going to give me 6. So that's 12Vx minus 120 minus 7Vx minus 20 equals 0. 5Vx is equal to 140. Vx equals 140 all over 5. Which is 28. Okay, and then let's plug that back into here. 3 times 28 minus 20. That's 84 minus 20, so VA is equal to 64 volts. Oh, cool, you got 28 for Vx, good. Fuck. Alright. And then V Thenemin is just VA, right? Okay. So V Thenemin equals VA. Which equals 64 volts. Because that's the open circuit, right? Yeah, that's the VA. Okay, cool. Okay, now to figure out Thenemin resistance, I think we take any sources and we replace them with shorts. Boltzmann's constant. Okay, here we go. Okay, so for R-Thenovin, I'm going to get rid of this. And then, same thing here. So now this is just Vx over 10 plus... Yeah, you can't short this one. I'm not going to short that one. So then this is Vx, but instead of Vx minus Va, it's Vx minus Vt over 20 is equal to 0, right? But V-Thenovin was 64. So, 2Vx plus Vx minus Vt is equal to 0. 3Vx equals Vt. Because it's a dependent source. So, 64 over 3. That's not anything nice, is it? Fuck. Okay, so then the current at A is going to equal, right, this current plus this current. So that's equal to Vt minus 10Vx over 120. Oh, well, the algorithm found you, dude. And then that's plus Vt minus Vx over the 20. Oh, okay. No, this stream is ending in 4 hours. we're going for a very long time today. Okay. And okay, so that's 64 minus, was it 64 over 3? So 10 thirds times 64 all over 120 plus 64 minus 64 over 3 all over 20. I have 4 more hours, yeah. We've been going for 10. We're going for 10. No, I have 4 more hours. No, you're not dumb. It's okay, Ethan. You're not dumb, dude. Okay. Okay, so what is that? 64 1 minus 10 thirds over 120 plus 1 minus 1 third all over 20. This is such a mess. 20 over 3 over 120. What's the 64 from? That was the Thenovin voltage. Thenovin voltage was 64. Yep, you're right, Lefkus. Okay. Plus 2 thirds over 20. So let's make that 12 thirds over 120. So I get 32 thirds over 120 times 64. Not a very nice number. 64 times 32 all over 360. From here. 20 over 3 is wrong? Oh, really? Oh, yo, you're so right. Jesus Christ. Sorry. Yeah, I have been streaming for 6 hours. I'm going to start making mistakes. This is -7 over 3. Thank you. Thank you. 5 over 3. There we go. Close one. Yeah, well, that was close. Divide by 5. Oh, was that 62? 72. Oh, 64 over 72. Nice. Okay. So that's the I at A. And then R theta of N is equal to V theta of N over IA, which is equal to, what was that? Oh, 64 over 64 over 72. 72 ohms, I think. Does that sound right?
Bing bong.
It's certainly a nice number. Jesus Christ, this question. Try gradients next. Try a barrel roll. This is, I don't know actually. Looks like a good number. Fine, fuck it. We're calling it, dude.
That's dope.
Oh, man.
What's you call that?
Please ask me a chain rule question. I would love a chain rule question. Marco, sorry. Marco was waiting 3 hours for me to do this question. So almost 4 now because it took me another half hour to do it. Marco, if you're still watching, I think we got the right answer. Some little tips on how we did it. We figured out that like the current here coming from this has to also equal the current coming from this. All right. And then also that the sum of the currents here, right, had to kind of like add up to 0 because this is an open circuit, nothing's going through. And then when we went to calculate, so that got us theta in voltage, and then when we went to calculate the resistance, we got rid of this as a short. So now this voltage, the current from this was just Vx without the 10 volts being also added. And then we did the same technique to then figure out what the current at the terminal would be going in. And then we divided V theta of N by that current at the terminal. Gold, I'm a second-year undergrad. I remember you helped me back in 10th grade. I love you, bro. Oh, thank you, dude. Thank you, Bag. 10th grade. Wow. Jesus Christ. That's like 4 years ago. Nice. Good job.
Bing bong.
Love that. I hope you're doing well in college. What are you studying? Thank you. You're the GOAT. I couldn't find the second KVL equation to find. Thank you so much. Please teach more at UCLA. Aw, appreciate that. Yeah, if they want to keep hiring me, I don't know. I have like great fucking student reviews, but UCLA is just fucked.
Oh no.
With funding. Absolutely fucked. So I might teach again next year in the winter quarter. Yes, I taught the spring quarter and the summer session. I did an online summer session for Physics 1B. Is that what I did? Marco, I'm going to post this solution, by the way, in my Discord if you want to go see it later. Kinesiology. Cool, man. That's dope.
That's dope.
Are you going to go be like a sports medicine trainer or something? That'd be pretty cool. Thank you for waiting, by the way, Marco. Appreciate it. You submitted your question at 6:25, dude. It's almost 10 o'clock now. Thanks for the patience. I appreciate it. Okay, where is this question? Okay, mark this as done. You cannot convince me that circuits aren't witchcraft. Hey, yo, what's up, Huber? Congrats on the 10K. Thanks, dude. Yeah, we had a lot of people find us on YouTube in the last month. I think we gained 1,800 subs just randomly, which I'm super happy about. Big fan of that. Man, I remember being so excited collecting coins for the gift cards. Yeah, it's totally still a thing. Yeah, we still give out gift cards to gamer kids, or regular kids. You don't have to play games, but most of the gift cards are games, are for gamers. Yeah, we gave out a Nintendo Switch bag. This last summer, I ran like a summer camp like a virtual summer camp where all the kids, you know the drill, like competed in games. We did a chess tournament. We did a talent show. We did like some cool math challenges to make sure people don't fucking forget all the math over the summer. And then Ethan, I don't know if you remember, Ethan joined our server like 2-3 years ago, but he won the Nintendo Switch too. He's always all the way from Belize. Did you solve the question about the lens? I don't know if I've gotten to it yet. I just went through a beautiful mess, which is Thunderman Circuits. You should host another chess tournament. I will host another tournament. Yeah, we need another chess tournament for sure. Thanks, Bag. We try. Hope all's well. Dude, if you ever like run into problems like with math or science or whatever the fuck in college, even if you just want like little life advice, feel free. The Discord's always still there. Oh, Wraith. Yes, Wraith. Wraith, you're coming up. See, look at the queue of questions I have. Wraith. Wraith, you're third. You're coming up. You're number 3 coming up. I'm gonna help out Eric real quick. He's back, dude. Okay, cool. This is probably actually not too bad. This is physics. How do you feel about biomechanics? If it's torque, I got you. If it's like what muscle connects to my biceps, like, I don't know. I might not know that. But I can do torque. I can do torque and forces. Do I know the Canadian curriculum? I've worked a lot with Canadian people, so maybe I do. Alright, mass block B is on the table attached to a string which goes over an ideal pulley and is attached to a cube of mass MC. Dude, where the fuck did MA go? Just fucking ignored MA? These alphabetist people. 3i is already simplified. I'm gonna love yours. Wraith, be careful how you say that. If the coefficient of static friction between the block and the table is mu s, the magnitude of the force preventing from accelerating is best described by... Oh. It's just MCG. Right? So, this cube has mg pointing down, and it has, like, tension pointing up. And then in the block just feels tension pointing this way. And it feels friction pointing this way. So, I mean, this is a common mistake people make, because they see static friction, and they think automatically it must be mu s Fn, which in this case would be mu s mbg, right? This is the maximum amount of force friction can provide to keep this thing stuck, all right? If any force on it is less than that, then static friction only provides that amount. Am I going to be live tomorrow? Not tomorrow, Sunday. If you want to check out the calendar, Davesy, it's on the same website that everyone's using to, like, to submit their questions. Wait, fuck, where is it? Here's the calendar. Go check out the calendar. Calendar tells you all the times we're all streaming. Go do it. Anyways, back to what I was saying. So, this is the max. This is the maximum static friction. But static friction is a smart force, which means it only provides what it needs to. So if I pull on this, let's say, just for shits and giggles, let's just say that, like, mu s was equal to 0.5, mb was equal to, I don't know, like, 10 kilograms, g is also equal to 9.8, right? Then fs would be equal to 0.5 times 10 times 9.8. That would equal to 49 newtons. All right, so this is the maximum amount of frictional force that can be provided by the block. If you pull on it with only 10 newtons, friction is not going to apply the whole 49. It's going to only apply 10. It applies as much as it needs to in order to keep this thing having a net force of 0.
No.
So that it doesn't move. If eventually you pull with more than the max, so let's say I pull with 100 newtons, okay? Now this thing is going to start falling. Because the static friction isn't enough. Like, we've reached its limits. And even more so, now when you calculate friction, you're not going to use static friction. You have to end up using kinetic friction, which is usually a lower coefficient. That's why it's easier to push things once they've started moving. So, yes. So in this case, because we know it's stuck, the only frictional force it's going to provide is whatever opposes the tension trying to pull it. And the tension trying to pull it, if this thing is, again, stuck. If this is stuck, this is stuck. So nothing's moving. Then T minus mg has to also equal 0. So T is equal to mcg. And that's this answer. Choice D. Nice.
Nice.
You learned this in first year physics? So I've probably worked with it, Ethan, but if you want to just, this is why I tell people if you submit a screenshot of a question to me, I can instantly tell how much you need to know, because I've seen everything. Well, maybe not everything, but I've seen a lot. So, oh, we're still going. Yeah, Avish, yeah. Dude, we still got 4 hours left. This clock is still going down, dude, but we haven't quit. We've started dipping into the Red Bull at least. I will make it. Sorry, who the fuck was this? Eric. This is Eric's question. GG, yo. Thank you, Jack-o'-lantern. It's getting a 10. We're past the halfway point, dude. It's like a marathon, right? Just get past the halfway point. You're great. It won't let you join the Discord. What does it say? Can you tell me what the error message says? I don't want to fucking pay the extra 7 Discord boosts to get our vanity URL again. It's so dumb. I love Discord to death, but I feel like they just keep like trying to take money from me. I've been studying since the morning. I'm slurring my words. Same, brother.
That's dope.
All right, linear algebra. Ooh, vector space. Oh, fuck. What'd you do? What'd you do, vector space? All right. We went from nice mechanics to linear algebra. Beautiful. All right. The vector space P2 is equal to a plus bx plus cx squared for a, b, and c are real, a polynomial functions of a degree of most 2. Define w. Is that the Wronskian? Oh, it says action can't be completed? It's whack. Try doing it on your desktop, Levi. Can you do it on your desktop? I've heard it fucks up on mobile. Especially if you're overseas. Which I hope you're overseas, because it's late if you're in the US right now. Yeah, try it on your desktop. Let me know if it doesn't work. Otherwise, send me a DM maybe on TikTok, and I'll manually send you another link. This is not physics. It definitely is not. Show W equals the span x minus 1 x squared minus x. Recall the factor theorem. If P is any polynomial and P of A is not equal to 0, then P of x is equal to x minus a cubed for some polynomial q of degree less than that of P. Okay, well, I think I see what they're saying. For instance, if I had, like, let's say, like, P of x was equal, like, to x to the 3 plus x to the blah, 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 right? I can always write that as x, x minus, this is a root, and then it's going to be 1 power lower than this. So this would be x squared, blah, 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 blah. We use this a lot with, like, polynomial long division and graphing nasty polynomials that aren't in factored form. Okay, Okay, so wait, if P of 1 is equal to 0... Ooh, okay. Oh, this is cool. Okay, so if P of 1 is equal to 0, then P of x can be written as x minus 1 times something that's 1 power less than this. So I'd say x to the first, right? Oh, you're very welcome, Scary Stories. Finally something useful? Like something useful on YouTube finally, or something useful on my stream? Oh, also, wait, what the hell? Why is my banner not working? Let me fix it. Sorry, TikTok. One sec. Oh, you can't change it? Oh, whatever. I'm gonna fix that later. Oh, it's funny. The countdown is starting to bug out on TikTok. It'll reset itself. Okay. Oh, without using the subspace test. I think I want to write it this way, though. Okay, so this is some, like, x to the 1. So let's just say this is some, like, alpha x. Or let's just say I hate alpha. Let's say ax plus b. Yeah? Then... Thanks, Femvox. Appreciate it. You always a G, Femvox. Everyone say goodbye to the solutions manual. Good night, solutions manual. Femvox is my solutions manual. This is linear algebra. Okay. Okay, then p of x is also equal to... So let's like reverse foil this, right? This is the same thing as x. Or here, it's ax x minus 1 plus b x minus 1. I just like reverse factored this. Yes, don't worry, I will explain it to you. Okay. So, oh, I can, ooh. This is equal to a x squared minus x plus b x minus 1, right? Uh-huh. Nice. So now we already showed that x minus 1 spans it, and also x squared minus x spans it. Yeah. Nice. Okay, that's cool. Right? Because these are kind of like a basis. This is the new basis for it, right? Right, Anch? Like this. These are the base. The basis is now x squared x minus 1. That's very cool. Yeah, basis is just a fancy word for kind of like a coordinate system, right? So, like, for instance, let's say you want to describe any point in the xy plane. Or let's say, like, something with a z value, right, is dependent on x and y. You can say, okay, z is equal to, like, blah, 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 x plus blah, 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 y. This is like the basis that describes the values z. You were able to join a desktop? Cool, yeah. Yeah, I gotta tell people, yeah, mobile's just fucked. Thanks, Levi. Yeah, you're welcome. Thanks for troubleshooting that with me. Yeah, right? Yeah, basis is such a scary word. But basis is just like, how do you describe your system, right? If I want to describe, let's say a party, let's say like party level. Party level is then proportional to like something as a function of like pizzas, like how many pizzas are at the party, plus something as a function of, oh, well, I don't know, y'all are kids. I'm trying to think, what was, video games. Yeah, how many video games are at the party? Yeah, there we go. Awesome. Yeah. Your basis for partying would be pizza and video games. Pizza and cola. Yeah, cola. I was trying. Pizza and Coke. Yeah, there you go. Soda, Coke. Yeah, pizzas and Coke. That's how you make a party. All right, that's what basis is. It's linear algebra. Yeah, I still look young. I'm 35. I'm not young. Explain why W is a subspace of P without using the... Okay. Yeah, exactly, Ansh. Explain a subspace without using the... So, okay, what is a subspace again? Maybe I need a better explanation for what a subspace is. Thanks, dude. Yeah. Oh, yeah. Well, I still go to the gym, yay. Good professor, though, yeah. Yeah, something. You always sacrifice something. You either sacrifice your physical health or your mental health or your social health. Okay, Anch says a subset of a vector space is a vector space itself. Well, I agree. Oh, yeah, wait. Didn't we say W was the span of these? Oh, and P is a subspace of P2. Oh, okay. Okay. Yeah, a span is always a subspace. That's cool, man. Nima Arcani. I don't know who that is. What type of physics does he study? Alright, span is always a subspace. Yeah. Hamed? I'm gonna go look him up real quick, sorry. Oh, this dude! Oh, yeah, this dude is... Yeah, this dude's baller. Oh, okay. My friend actually has met this guy before. Yes. Yeah. This guy is brilliant. Oh, he was born... I grew up in Houston. Oh, that's fucking sick. Okay, cool. Yeah, Nima. Okay, yeah, I know this guy. I don't personally know this guy, but I think one of my friends actually knows this guy. Personally. Yeah. He was a he does quantum gravity physics, my friend. He's a brilliant dude. If you guys want to check him out, he's awesome, dude. His name's David Chester. I was his best man for his wedding. David Chester physics. This guy. Yeah. Go check him out sometime. This is one of my best friends, David Chester, but he's a quantum gravity physicist guy. They're always the most unique creatures, the quantum gravity people. The theoretical physics guy, the black guy, of course, yeah. Yeah, he gets paid like a lot of money to study quantum gravity and like UFO propulsion and stuff. It's wild, dude. He's a wild guy too, by the way. Okay. Find the basis for Omega. We already found the basis. Right? Wasn't the basis this? This is the basis. Okay, so wait. X squared minus X. And X minus 1 is the basis. Yeah, because they're also linearly independent, right? Because they're off by a factor of X, which is nonlinear, yeah. Yeah, best dude. It's the journey's fun, man. I always say don't worry about the end. Find the dimensions of W. So dimension of a basis is how many vectors you have in the basis, and so that's my pizza and my Coke. So that's dimension of W is equal to 2. Right? Because you got 2 things. Nice, cool. Good question. Linear algebra.
That's dope.
All right, Wraith. I think you're next. Am I gonna regret this? I'm gonna regret this, Wraith, dude. Linear algebra, they said. Oh, just explain it? Okay. You better not be asking me like where babies come from or something, dude. Don't do that. Okay, you're not. Okay, I'm just checking. I've had some trolls ask me funny things on YouTube. I definitely do mechanics, yeah. How important do you think it is to learn math conceptually versus memorizing steps? Thanks, man. So I actually have a LinkedIn post about this. Don't worry, Wraith, we're coming to you real quick here. If you want to go follow my LinkedIn, where is it? Where's my profile? This is me. Where's my post on it? I wrote a post on it. Where are my posts? Yes. This is my post. So, I'll give you the TLDR. Here, I'm going to link it to you. If you use LinkedIn, it's cool. For, like, saying professional things. But, in general, I think learning mechanical procedural fluency is great for building confidence. Especially in, like, students who don't think they're any good at math, if you show them like, hey, you can do this, then they're most likely to stay interested in it. And so I don't believe you should really lead with conceptual, because that tends to scare people. If you lead right away with like conceptually how math works, they're probably not going to get it, and when they don't get it, they think they're dumb. So if you show them like procedurally that they know how to do it and they can get the right answer, that like builds up the dopamine response that they're used to on like TikTok and whatever, and then you can like kind of start like breadcrumbing them into actually learning like why things are the way they are. Do I do OChem? I don't personally do OChem, but I would love for you to submit a question, because I have another streamer friend who just started streaming, and he's an OChem master. And he's looking for more people to help in OChem. All of this is free, by the way. None of this costs any money. So, if you have OChem questions, please put them down at that website. Just put them in there. Join our Discord, and then the OChem guy will do them. I know it sounds kind of sketchy, the OChem guy, but he just went to bed because it was like 3 a.m. UK time for him. But he will be up in a couple hours. And I can definitely help with limits. Okay, Wraith said he's in 8th grade and he wants me to explain fronted gravitational waves to him. Okay. Okay. Focus attention on the electromagnetic field associated with the pulsed emission of a pulsar and denote the field phase. Oh, Jesus Christ, dude. What's happening here, dude? What? Who is making you do this in 8th grade? I don't even know how to do this. Okay. Pulsar timing arrays. I mean, that's really cool, man. If you're interested in 8th grade and like really fun astrophysics type stuff. It's a project on gravitational waves. I got you. Okay. Here, I'm gonna explain some words to you, because I don't know exactly what this stuff is, but I can explain it to you. So, time-dependent phase. Do you know what phasing is, first off? Phasing is important. So, for instance, if you have a wave that looks like this. Okay, Wraith, that's cool. I'm gonna explain some things to you. So let's say you have a wave, which is like a signal. So almost everything in the universe is waves. Light is a wave. I don't know, like everything else is waves. Matter's wave, whatever. A lot of things we measure in the world oscillate, such as like sound. Sound is a wave. It's particles in the air moving back and forth at a certain like frequency. So one way to describe waves is not only like their amplitude, how tall they are, but also describe positionally, like here in this axis, where they're located, and that's called phasing. So for instance, when two waves line up with each other, this is a phase angle of 0. Okay? This means there's no phase difference. Reasons why things can have phase differences is maybe two things are going through different materials, or they're passing through different mediums. This is how like an interferometer works eventually. Yeah, if you want to look up like interferometer, I think that's probably the next thing you actually have to learn about. So interferometer. Try to understand what an interferometer is. But phasing refers to like how like ahead or how delayed two signals are, okay? And so a lot of factors can affect that phasing, that delay. For instance, if this thing is like smooth sailing through, you know, the nicest road ever, but this thing's like having to go through the mud, this thing is going to be phase delayed. In astrophysics, it refers to what materials the waves are having to go through. So like what type of dark matter, what type of, I don't know, like gases or other things. And also if things are spinning, so pulsars spin and they pulse. The reason why they pulse, I believe, is because they're circular, but they have like some end of them that's like beaming out. So as this thing spins around, it's like a lighthouse. You see the blip every once in a while, and that tells you how fast it's spinning. Oh, cool. You did a project on interferometers. Okay. Right. So, yeah, I think that's how pulsars work. Various. Thanks, man. So, a radio telescope is a telescope that doesn't see light per se, but it sees radio waves, which again they're waves just like light waves, but they're at a different part of the spectrum. And what they're saying here is that the phase difference between I'm trying to think what are the two signals? Are they referencing like two separate, do they have like two locations for the radios, the radio telescopes, and they're seeing what the difference in the phasing angle is? We actually use a network of pulsars as a system of interferometers, basically acting like one giant LIGO. It's pretty cool. Oh, nice. Yeah, LIGO. Is that the very long thing? Am I thinking of that right? Or that's SLAC? No. Wait, what's LIGO again? Yes, yeah, the very long thing. Yeah, this thing. Yeah, this thing's fucking dope. Yeah. This is very cool. Yeah, yes. Because when things are very long, you can then detect things that happen really quickly. So things that like have very, very small differences in time will appear more drastically if you look at them over huge distances. So yeah, that's why this is LIGO. Oh, that's very cool. I know it's a very long thing. Yeah. Pause. Okay. So yeah, the difference in the position of the mirrors is on the scale of like 1/10 of an atom. The fact that we detect it is wild. Yeah, we have very, very fine instruments, I guess. So this is saying that the phase difference is dependent on a bunch of different factors, such as T0 here is corrections due to the spatial motion of the Earth. Cool. The solar system with respect to the pulsar, and the wave propagation through the interstellar medium. Okay. So this stuff is like just due to that we're all spinning in... We're all just like tiny meat machines on these puddles, these little rocks that are getting shot through the universe at crazy speeds in all different directions, right? What do I do for a living? I do this. I teach. This is one of my ways that I teach, though. And then here, they say tau GW are corrections owning exclusively to HTX. Okay. I don't know what HTX is, but I assume it's a function of time and space. I teach at UCLA, I teach privately, and I teach for free on social media. So I teach a lot of places. And then, yeah, L, the distance. Yeah, of course. The distance between the distance between us and the pulsar would affect the phasing. Yeah. Okay. So residuals usually means like differences is what it does. Okay. And so I think when I see timing residuals, I think they're talking about what are all the correction factors you need to make in order to figure out what the real phase difference is between two signals, because there's a lot of other shit going on that messes up the timing. Oh, gravitational wave strain, delta L over L. Okay. So, yeah, that's the other thing, right? Is that gravitational waves can affect the speed and timing at which light waves or electromagnetic radiation travels through the cosmos. So in LIGO, delta L is about 1/10 of an atom. And L is 2 kilometers. It's huge. Okay. Cool. Does that make a little bit more sense, Wraith? Did we at least, I mean, give you some stuff to look at, right? Interferometers and phasing. Yeah? Nice. Cool, dude. Thanks for waiting around for this question. It was cool. I like the more conceptual questions. They're fun. It helped a lot. Fuck yeah, dude.
That's dope.
I teach like undergrad courses. Physics 1B, Physics 5A are the 2 courses I've taught. So like mechanics for undergrads that are life science majors, and then E&M for engineering physics majors. Peace, dude. Yeah. Oh, you're doing your master's in physics. Dope. Nice. Where at? What are you doing? What are you doing? What are you studying? This is Wraith. I don't discuss location. That's okay, dude. You're all good. You can tell me what you're studying at least, though. Yeah, what are you studying? Yeah. Ooh, generalized uncertainty principle in quantum mechanics. That's sick. Very cool. Yeah, quantum mechanics is always kind of a mystery to me, honestly. What program are you enrolled in? No, but that's telling location, Melee. Can't ask that. Basically putting the Heisenberg uncertainty principle into curved space-time. Ooh. Now, why is space-time curved, by the way? Is that because of gravity? I think gravity usually does it, right? Okay, Kenny submitted a blank picture to me. Okay, that's great. Kenny, real, my bad. Okay. Use the Wronskian. Oh, this is actually pretty cool. I debate flat earthers and they're crazy. Can't let my location get out. Yeah, don't dox yourself. It's okay, man. You don't have to. Is that the Jacobian? In my backyard? It's more common than you think. Okay. Do I take the determinant of this thing? I forget. Okay. So we're going to call this thing F1. We're going to call this like F2. I remember LeBronskian. I think LeBron's still playing though, isn't he? Okay. All right. So, you just do derivatives, right? It's just the columns are just derivatives of the thing. So in this case, this is 1 minus 2x squared. The next derivative would be negative 4x, and then the next derivative would be negative 4. And then we take the determinant. Cool. Sick.
That's dope.
Nice. Okay, so then this is 3 plus 4x. This is 4. This is 0. You can put it in there. I may not be able to answer it, but why not, dude? This is a monumental stream. This is the first time I've done a 10-hour stream. So every question you submit is immortalized into the great history of actual education office hours. Yeah, I don't think it's a 2x2, unfortunately, right? This thing fucks it up. Fortunately. 7, 2, 0. Well, the nice thing is, if we're crossing this with this, I think we're only gonna get these two, right? Yeah. Okay. Okay, this is W. So then let's find the determinant of W. So I like to do this method. I do like this. So the determinant of that, so that's equal to 4 times 0 minus 0 times 2, all 0. Okay, cool. Minus, sorry, what was this? 3 plus 4x. And then it's negative 4x times 0, starting with a negative 4. Negative 8. And then here. Oh, wait. Did I do that right? Sorry, it's minus negative 8, so it's plus. Yeah, plus. Okay. And then that's going to be... Favorite math class in college? Ooh. I took a really fun ethnomusicology class, just like for credits, for GE credits. I had a really fun time in that. I learned about gamelan and like instruments and shit. Also, my Italian class was really fun. But if you want to ask me like what my favorite math, physics class was that I took. Man, what would that be? Probably my E&M lab, honestly. I had a really cool E&M lab. Yeah. Why minus in the middle? Yeah, E&M, right? Yeah. E&M was great. I liked E&M. So, yeah, whenever you do determinants of 3x3s, it's plus minus plus. So you do plus this times that minus that. And then it's minus this times whatever. And then it's this, and this. Dude, Jackson, bro. Oh, my God.
Disqualified.
Dude, we used to have a giant picture of Jackson in our grad school lounge, and we would write like, it was just a picture of dude. He's a scary looking dude, man. You ever seen like who John D. Jackson looks like? This man, dude. He inspires fear. Who hurt Jackson, dude? Dude, some of his questions haven't been solved yet. Dude, this is my favorite picture of Jackson. This one. We used to have this picture up on the wall, and it would say like, these are different times, but it would say like, I'm gonna rape you till I love you, or something, or until you love me. Yeah, because that's what it felt like, dude. It felt like we were being violated constantly by this man, trying to like do his questions. He's a very scary person. We also we would have a meme here, and it would be like, find the vector potential everywhere. Yeah. Okay. So let's keep doing this Wronskian. That's going to be negative 24 minus 32x plus I'm like hearing things now. 112 plus 14x. What's up, Arlo? Oh, Arlo, dude. I haven't seen you in a while. What's up? Right? Okay. And wait, does this have to equal 0? Does it have to equal something? So that's 98 minus 18x. Not 14x, they say. Yes, you're right. 32x. Oh, it's oh. Thank you, Ziad Banet. You're so right, dog. Yeah, I was like, wait, isn't this supposed to like be independent of x? It is. Yeah, this cancels with this. Okay. Beautiful. Yeah, 16 times 2 is not... Yeah, it's 32. 98 then. Wait, yes. Yes. No. 88. Yes, 88. Cool. Dude, I forgot you streamed. Of course I stream, bro. We stream all the time. I stream 5 times a week. Welcome. When's the next stream? Yes, Cal, that'll show it to you. Good. Wow, you're the first person who realized like how like commands work. Okay. So what does this tell us? If the Wronskian is independent of x, then they're linearly independent. Is that true? A Wronskian that is a function of x that is independent of x only in the trivial case. A Wronskian is a function of x. Wait, dude, what is this? Dude, Jesus. My PhD is in plasma physics. There we go. Uh-huh. Okay, so as long as it doesn't equal 0, it's independent. If the Wronskian equals 0, thank you, Ziad. I appreciate that. So yeah, I think this is independent. Nice. Good question. It's fun. Thanks for the follow, Rosen. All right, whose was this? Kenny. Kenny M. All right, let's see. Someone else is, I think, asking like a mechanical engineering question. Let's go. Yeah, what's up? Yeah, nice, Kenny. Yeah, so here, I'm gonna put this in the Discord for you. So, well, it should load at some point. There we go, Kenny. So here is the solutions to your thing. Oh, I see there are other parts to it. Is 231 spanned by 1 minus 1 and 1 2 2? I think you put this in a matrix and you try to like row reduce or something, right? Yeah. You put them in the columns. Yeah, and don't solve it. Okay. Yeah, these are not too bad. Boom, 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 boom. Oh, Jesus. Oh, no. Oh, no. What's happening here? What's happening in this question? Okay, when the rope is at an angle of 30 degrees, the 1 kilogram sphere has a speed of 0.6 meters per second. The coefficient of restitution, that's something to do with a collision. Determine the spring constant has that, and theta is equal to 20 degrees. This is some 16th century torture machine. True, dude. What? Determine the velocities of A and B immediately after impact. The maximum deflection of the spring. Okay. Let me look up what coefficient of restitution is again. Oh. It's the square root of EK final over EK initial. Love that. That's actually pretty cool. No, don't worry. You don't have to do this. This is hard engineering stuff. But I'm going to use this information here. Right. I guess that's why it's a square root then, right? Basil? Yeah, I just haven't really seen that in my physics class that I teach, or like even when I was in physics. I have seen it's kind of it's an engineering thing, or it comes up in like the UK. They talk about it a lot. Okay. So let's do conservation of energy. I think I want to do conservation of energy, yeah? Conservation of energy. I don't know why the angle really matters, honestly. Oh, you know why it matters? Because as this thing moves forward, this thing moves up. Oh. Well, that's tricky. Oh, that's do you guys see what I'm saying? I was like, why the fuck do I care about the angle? It's like, oh, as this thing moves to the right. Oh, this thing should move down then, no? Well, no. Wait, what the fuck? Do we assume it's always in contact with it? I'm gonna at least solve one part of it. Well, the coefficient of restitution is 0.8, so that tells me right away it's not perfectly elastic, right? Perfectly elastic coefficient of restitution would have been 1, right? But we can always do conservation. No. Wait. No, we can't do conservation energy. Well, we can't do conservation of kinetic energy. Oh, actually, no. Conservation of energy doesn't work. Oh, fuck. Momentum, maybe? Yeah. You can't do conservation of energy with collisions. That's unfortunate. Although... And also, wait, sorry, is this EK of the... Is this of the system? Final velocity B minus final velocity A over... So, yeah, this is of the whole system then, right? Because it's like... It's like... Yeah, exactly. I think it decreases by 0.8 squared. I agree. Is it the total energy, though, right? I think I still want conservation of energy, especially if I'm doing anything with the spring later, right? I don't have momentum for springs. Okay, so before... It's not purely elastic. The coefficient of restitution is 0.8. If the coefficient of restitution was 1, it would be. Okay, the only kinetic energy you have is from this, which is going to be 1/2. Is everything 1 kilogram? No, the wedge is... Okay, so we're gonna call this MA. 1/2 MA times V naught squared, right? And then it does have a little bit of gravitational potential energy, right? Because it's up a height difference. Let's call this all H equals 0. This is all H is equal to 0. So then if this is L, then this is L cosine alpha. Right? Okay, and this whole thing is L. So it's L minus L cosine alpha. Okay, plus MA G, and then it's L 1 minus cosine alpha. So this whole length here, because the length of the pendulum doesn't change, is L. This is L cosine alpha, so then the height difference is L minus... Since it's mostly elastic, I think the ball will bounce. Yeah, okay. Well, here we go. Okay, this is then equal to... I don't know what this is. This is kind of mechanics, but it's also kind of like engineering. If you have a doubt question, yeah, send to the website down there, actualofficehours.com. Okay, I think we've got all the energy, right? And now they collide. So this is going to be equal to 0.8 squared, right? Of 1/2 MB VB squared, or it's like VB prime squared, plus 1/2 MA VA prime squared. Yeah, I have taught. Yeah, I have taught at the university level. I'm not currently employed as a professor, but I have like been professorly, I guess. Transfer function. Yeah, there's no bounce. It's asking for the velocities immediately after the impact, right? I agree, right? Okay, cool. So that's conservation of energy. And then I think we also have to do conservation of momentum. But then this has momentum in the, like, this direction and this direction. So how am I going to still have that momentum afterwards? The spring has not compressed yet. So I think part A is asking for it right after the impact, so the spring is not compressed yet. My question is, where's the momentum in the Y direction going to go? Sure, but then that's not conserving momentum, because I need downward momentum to be happening, no? Oh, so if it's immediately before the collision, you don't need coefficient of restitution? Nah, no, but I'm doing right after. We're saying right after the impact. After the impact means I do need the coefficient of restitution, because there's deformation has happened. Man, fuck. I need there to be momentum. Oh, wait a minute. Yeah, so, sorry, I think you're onto something, Ziad, here. I can do the energy right before it collides to right after it collides. Yeah. The reason why momentum is not conserved is because gravity is pushing down. Oh, this is fucking genius. Oh, wait, one sec. Sorry. Very sorry. Sorry, we have 3 situations here. Okay, conservation of energy. Okay, this is gonna be, when the ball's like here, and whatever, this is this, right? This also has to equal when the ball is here. Yes, exactly. Yep, here we go. So this is like right before, so before collision. And then we have after collision. Yes, thank you. Yeah. Right? So this is like, oh no, they've collided. I'm going to use this to figure out what the velocity... So this is v equals 0. And this is going to be something like this. This is like this. Got it. Okay, I got it. So I'm going to... Yeah. This is situation 0. This is situation 1. This is situation 2. So this is VB2, VA2. Okay, here, I just have 1/2 MA V1 squared, right? Cool. Yes, because now there's no potential. Okay, and then once I get that, then I can set it equal to this. And now I can do conservation of momentum, which says that MA V1 must be equal to MBV2 plus, or sorry, MAV2 plus MBV2. Yeah? We'll do this afterwards. Yep, exactly. Fuck. Okay, great. So what? Do they want me to calculate these numbers? This is where I know this is an engineering question, by the way. Or it's mastering physics because they're making me calculate numbers. I don't want to calculate numbers. Screw that, dude. I just want to do everything symbolically, dude. I don't want to like have to plug these fucking numbers in. Use the Lagrangian melee. Chill. All right. I'm gonna put everything in. Well, here. You know what we're gonna do? While we do this, while we're cooking with numbers, I am gonna just have ChatGPT just run through it just to see what it gets for numbers. Here, solve. And then we'll see if we get the same thing. Do you think it's important to have a good foundation in math to proceed in college? 100%. It's probably the most important thing you can do. Is have a good foundation in college, in math. I think just in life, dude. Yeah, probably pretty great. Okay, MA is 1. So I can already get rid of this. So just 1. Oh, also I could have just canceled it because they're in everything. Okay, so wait. 1/2 V0 was equal to 0.6 squared plus 9.8 times, what is the L here? L is 0.9. Kempy, what's up, dude? 1 minus the cosine. You want to say hi? Here, you can come say hi.
Yo, can you help me on a problem?
There's a queue of 24 other people I have to work through right now.
Alright.
But submit it. Submit it to the...
Yeah, I did. I'm number 24. Thank you.
Okay, you're number 24. Alright, we'll get to it.
Thank you.
You're welcome, dude. Let me see what his question was, actually. I'm just curious. Kempy. Oh, inflection points. Nice. Actually, that's not too bad. Here, Kempy, come. Let me just do this one for you real quick. You did jump in my Discord. It's fine. Let me do this real quick for you, Kempy. Come back. Just because, yeah, I want a little bit of a break before I start doing all that engineering garbage. I gotta put all these numbers in here. I'm gonna do this one for you real quick, Kempy, because I appreciate you're in my Discord. Alright. Okay, the graph of the second derivative is shown below. Which of the following is true? So, okay, what do we know about inflection points? What does that mean about the second derivative?
It's like when the slope is 0.
So the inflection point is where f double prime of x is equal to 0. So f double prime of x is equal to 0, and f double prime is changing signs. Okay? Okay. Is f double prime of x equal to 0 at -1?
Yes.
Yes, good. And you notice how it's changing signs from positive to negative? That means it's an inflection point. Good. Okay, that one's true. Concave down from -1 to 3. So concave down is when what?
It's when it makes a upside down U.
Yeah, the sad face. But the important thing is concave down occurs when f double prime of x is negative. Okay?
Okay.
So that happens here and here. So when they say from -1 to 3, is it concave down? Is the second derivative negative here?
Yes.
Yes. Even though I know this looks like a happy face, but remember, this is a graph of the second derivative.
Okay.
Okay. F double prime is increasing at x equals 2. Ooh. Well, that one's kind of hard. I don't fucking know.
Let's probably see.
Oh yeah, because it's just 1 and 2. Yeah, you actually can't tell this. You can't tell if it's increasing or not because I'd have to know what the initial velocity was at some point, and then integrating the second derivative tells you what the change in the first derivative is. So I can tell you whether it's still positive or negative. So yeah, 1 and 2.
Thank you.
You're welcome, dude. Okay, 1 second. Let me just. That was easy. What's up, Willie Manilli? All right, let's go back. Let's go back to this. Back to the grind.
Nice.
Thanks for the follow, Paradox. 24 posts. 24 delete. Oh, you're so welcome. Yeah, no. We're doing this because we just hit 10,000 followers on YouTube. And I said I'd do a 10-hour stream for 10,000 followers. Someone wanted me to, like, shave my beard. I was like, I'm not doing that. You know how long it takes to grow a beard? Plus, I look terrible without a beard. Okay, let's keep going. What is a Haverson? A Haverson? I am a professor sometimes. I'm not currently teaching UCLA because money. UCLA doesn't have any money. MG 10. Which is wild because they definitely have a lot of people that like pay tuition. So they definitely had money somewhere. Where'd it go? All right. Okay, so this. Oh, dude, why does it keep messing up my thing? Stop. Okay. But alpha was 30 degrees. Cosine of 30 degrees is square root of 3 over 2, right? That's cool. So that's 2 minus square root of 3 over 2? Or we can just leave that how it is. Okay, and then this is equal to 1/2. And then this is v1 squared. Okay, so let's get v1. We're going to get it. Let's do it right now. Trust. 0.5. Sorry. What's up with my calculator? Stop that. 0.5 times 0.6 squared plus 9.8 times 0.9 times 1 minus square root of 3 over 2. And then we're going to multiply that all times 2, right? Because we got a 1/2 on the other side. So times 2 square root 1.65. Okay, so this is equal to 1.65. Okay, now we can use this little bit of information, right? Actually, I think I just want to use the coefficient of restitution. Right? I think so. Watch this. So 1.65 is equal to... So MA is 1, so that's... No. For this one we do. Watch. Wait, I don't think you need the coefficient of restitution for momentum. Alright, nice. Thanks, Blue, for coming around. Ooh, we're at the final 3 hours. We have been live for 7. I've locked myself in my closet. I'm teaching to the void. Wait, this is V2A, V2B. And then this is plus... Okay, shouldn't the first V2 in your momentum be V1 prime? So here's what I'm saying. I'm calling everything here subscript 0, everything here subscript 1, everything here subscript 2. Like, this is situation 0, situation 1, situation 2. And then I'm doing A and B to signify the ball or the whatever. That makes sense? Yes. Insane. Yeah, I still have a chance. I'm still drinking Red Bull, dude. So, we're trying to get the velocities of A. So we're trying to get V2A and V2B. So then I'm going to use the coefficient of restitution, right? Whatever. Where's that bitch coefficient? No. Jackson, go away. Oh, where is it? Coefficient. Thanks, dude. I'm gonna use this. Oh, not that. So I'm gonna say that 0.8. So VFB. So that's V2B minus V2A. All over V1A, which I already know is 1.65. Yo, what's up, Sid? Oh no, you have bronchitis.
Surprise, motherfucker.
No. I'm sorry. No. Don't worry about staying up so late, Sib. Yeah, no, this has been a crazy, crazy stream. We're at 25 questions in the queue. That's pretty nuts. Where are you? Sorry, where are you, Sibley? Where are you? Oh, you're pretty far down. Oh, you submitted at 8 o'clock, which was 3 hours ago. Oh, this is Biosavar, but you just do it for one of the things, but then multiply it by 1, 2, 3, multiply by 6. Okay, let me finish this one, Sib. Maybe I'll do that one real quick because that one will not take too long for me to do. All right. I think we got this. Right? Because look at this. V2B, V2A. Yeah, and this is simultaneous equations. Look at this. This is some cool ass shit, right? Because watch. Because V1B is also 0. So now I have just 1.65. Oh, you're welcome, Sib. Don't worry about it. Sib was one of my students during my summer UCLA class I taught. And then this is 8 times 1.65 is equal to... What's this? V2B negative V2A. Bingo fucking bango, right? So if we just add these are going to cancel, right? And so I just get 3 V2B is equal to 9 times 1.65. So V2B is equal to 3 times 1.65. What's that? 4.95? Right, 1.6, 4.8, another 0.15. Okay. And then... $1.65 is equal to V2A plus 2 times 4.95. You're so right. No. Thank you, Ziad. Dude, Jesus. It's not 8.
Surprise, motherfucker.
God damn it. Damn it. Okay, you're right. So this is... Oh my god. Sorry. 1.8. Okay, so sorry. Let's get some... I was looking at this. I'm like, this is kind of weird. 1.8 times 1.65 divided by 3. Okay. V2B equals 1. It's 0.99. Let's just say V2B is equal to 1. So then, 1.65 equals V2A plus 2. So, V2A is equal to negative 0.35. You got 0.33? Oh, I think I rounded somewhere. Okay. Cool. Is that what ChatGPT said? Well, ChatGPT like fucked up.
Disqualified.
Dude, what is ChatGPT doing, dude? Bro, what? VA does not have components. Does it? Maybe it does. You're right, chat is wrong. Great, thank you. Fuck the clankers, dude. One victory for humankind. Don't clip that though. Like, if ChatGPT takes over, I want them to know that I never said anything bad about clankers. Okay, cool. Nice. I don't know where the angle makes a difference here. But I think we can assume, right, that now you have situation 4, situation 3, which is just this and like compressy spring, right? So then just set this equal to. Oh, and here's the interesting thing. Yeah, no. This is just equal to. Okay. All right. So, yeah, 3 is now just considering this without it being compressed, and then 4 is it being compressed. Okay, so here you have 1/2 MB V2B squared is equal to 1/2 K X squared, right? Cancel. X is equal to the square root of 2 MB V2B squared all over K. So that's equal to the square root of 4. V2B was basically 1. All over K. What was K? 1500. Square root of 4 over 1500? Does that sound right? Cool. 5.16 centimeters. And I think you're done. I'll take it. What a fun question, Bilal. So much going on in that question. Jesus. I'm right, chat's wrong. Always. Okay, cool. Here, let me do Sibs real quick. Sib's a homie. Big supporter of the stream. How are you feeling right now after 8 hours? Oh, it's only been 7. We're heading into 8. Okay. A wire is bent into the shape of a regular polygon with n sides whose vertices are a distance r from the center, n equals 6. If the wire carries a current I0, determine the magnitude at the center, and if n is allowed to become very large, show that the formula reduces that to a circular loop. Very cool. Yeah, you're good, Sib. So There's a simplification for this. What is it? Biot-Savart for magnetic field line of current. And then I want the one with the angles. Where is the one with the angles? You know what I'm talking about? Those angles mess me up. Okay, fine. Maybe I'll do the angles. It's like this question. I know it's this one. And then like the component in the y-hat like direction cancels itself out. Where's a fucking line of current? Yeah, here we go. Long wire. Yeah. Where's this equation though? I don't want to have to go find it. I'm hunting for it. Yes. Dude, I know someone's done this. This is it. Yes, here we go. This is it. Here we go. This is what I want. This is what I want. Oh, I like John Coley. It's pretty dope. Wait, I thought I got this image. Okay. And then let me get what the full Biot-Savart is. Where's the full law for it? This is it. Okay, because this is the full thing that you're supposed to integrate, right? So, what you end up saying is, let me show you where it comes from. It's actually pretty cool. All right, so if you have a little bit of DL here, right? And so we end up saying that like if this is DL and then you're crossing it with R hat points back this way, right? And then if it's symmetric, so you'll have a component of the magnetic. So if this points this way and current points this way, right? Magnetic field will only be up or down. Okay. However, I want the amount of I want the amount of I, or the amount of L, that is perpendicular to R. So if this right here is R hat in the DL cross R hat, and DL is pointing this way, DL cross R is going to be LR cosine theta. Where, LR sine theta. Where sine theta is the angle in between these two. But sine of theta here is the same thing as cosine of theta here, because you want this amount. So that's why we end up saying, okay, well, this is just LR cosine theta. Okay. Oh, cool. And then it's over 4 pi r squared. Where does this last r come out, though? 4 pi... Why do I say A? Where's A from? Why am I allowed to say A? DL is that way. Cross with R vector, which is R hat. And then it's, yes, it's the cosine of that angle. There's still one more r I have to get rid of. Where do we get rid of that last r? Oh, wait, no, I'm allowed to have, okay, that's right. That just gets pulled out. But wait, why is r always equal to a then? 4 pi. Ugh. Okay, I forget where this comes out, but I know this is correct though. So eventually, if you want to integrate to get the magnetic field at the center from going from like a theta 2 to a theta 1, it's equal to this. And in your case, when I'm going from here to here, this angle is equal to this angle, right? And so instead of being sine theta 1 plus sine theta 2, it ends up just being 2 sine wait, sine theta 1 plus sine theta 2. Yes, there's a lot in the queue. One sec, I'm getting this. Sine theta 1, sine theta 2. Wait. If this is theta, and theta's the same. Oh, so it's 2 sine theta. Oh, okay, cool. Oh, I got it. Okay. B is equal to mu naught I over 2 pi A sine of theta, where theta is equal to this angle right here. Okay, cool. This is cool. Now, that's a magnetic field just due to one of these sides. Okay, so now we need an expression for, like, what this thing is based on the number of sides there are, right? So, if this is theta, and how many sides this has? 1, 2, 3, 4, 5, 6. So here, n equals 6. And, there's gonna be 12 of these in 360. So that means each one of these is 30 degrees. Okay, so let's see if there's a formula for this, right? I think it's 360 over n times 1/2 is equal to theta, where n is the number of sides. Let's see if this makes sense. So for a square, I'm curious about this angle theta, which should be 45 degrees. So let's see if that makes sense. So 360 over n equals 4 is 90 times 1/2. Yes, good. 45 degrees. Okay. Does this make sense, Sib? Like, this describes what this little angle here is? What's up, Faizan? My man. Yeah. So theta is equal to pi over n, basically, is what we say. Because 360 over 2 is 180, but you want to do everything in radians. So 180 degrees over n. Okay, cool. So then B is equal to mu naught I over 2 pi A. Yes, exactly. Yeah, you do. But this is nice and symmetric. But yeah, otherwise you have to know, like, theta 1 and theta 2. In this case, theta 1 is equal to theta 2. And then theta is dependent on the number of sides by this. So this is pi over n. And then, okay, now we need an equation for this, A. Which is like, A is equal to this. Oh, which I think is constant. It says the vertices are always a distance r. Okay. Very cool. So this is mu naught I over 2 pi r sine of pi over n. Any more electrical questions? You can check. There's 25 questions in the queue. But wait, as n goes to infinity, I need this to reduce to like 1 or like 2 pi. Does it? I don't think it does. Fuck. Man. I need like sine of n over n to go to 1. That's what I need. I need the n in there somewhere. Oh, no. A, what is A in this question? I think I know what happens. Yeah, it's close. It's this. Oh, man. Okay, one sec. I just want ChatGPT to, like, help me. I'm so close on this one. No, not this. Dumb. I want to know it. I want to know. It's me, like, trying to, like, piecemeal put together after 7.5 hours of working. Like, what is this fucking magnetic field equation? We got it. We're gonna get it. Yes, I get it. Give me the question. Give me it. Center to side to midpoints. No, you don't need to do that. Yes, here we go. Yep, theta 1, theta 2. It's doing it. And then theta is going to be equal to pi over n, right? Here we go. Ooh, wait. Mu? Oh, A is the perpendicular bisector. Oh! For a straight wire carrying I naught, the magnetic field... where theta is L, the angle away from the perpendicular to the other end. It is BS of R. Yeah, no, it totally is. I'm just trying to, like, remember. I'm so close on this. Because the angle is pi over n, right? Yeah, I got that. Pi over n. Right? Because half the length side is r. Where are they getting the 2 pi from? Oh, Sib. Sorry. I need to multiply this by the number of sides there are. Yes. This is the B field for just one of the sides. This is for one side. Oh, okay. Okay. U equals pi over n. Then n is equal to pi over u. So now the limit as n approaches infinity is the same thing as the limit as u approaches 0. Okay? Watch this. This is a really cool algebra trick. So, if I replace... So instead of doing the limit as n approaches infinity of this, I'm going to replace pi over n with u, which means n is equal to pi over u. And then instead of the limit as n approaches infinity, u is going to approach 0. Because as n goes to infinity, u goes to 0. So now I have the limit as u approaches 0 of pi over u, mu naught I over 2 pi, big R. And then it's sine of u. And then this is fucking dope. Watch this. So pi's cancel. You get mu naught I over 2r. Limit as u approaches 0 of sine of u over u. Pi over n, not pi over u. No. I said u is equal to pi over n, Ziad. So then pi over u is equal to n. Because the reason why I do that is this. The limit as u approaches 0 of sine of u over u is equal to 1. So then I get mu naught I over 2r. Which is the correct answer. I think so. Yeah? Okay, full. Yeah, fuck yeah. Oh, man. No, you don't need to do an integral. This already has the integral, by the way, Sib. So this right here, this is already integrated. So this right here comes from this, and this came from doing the integral of dB. So, yeah. There's a derivation for this. Just find it. And then all I did is I said, oh, well, theta 1 equals theta 2. So that's why that's 2 sine theta. Which then made this a 2 pi. And then I figured out, oh, well, theta, which is like the half angle here, is equal to 360 over n times a half. So it's pi over n. So then you put that in here. And then immediately when I see I'm taking limits with like sine of something, you want to try to get to this. You want the limit as x approaches 0 of sine of x over x. It's just, it's a really nice trick in calculus that'll save you a lot. Yeah. You eventually just memorize it, yeah. And then, yeah, once you do this clever u sub, the limit changes from approaching infinity to approaching 0, which is what I need for the sine identity. And then this now becomes sine of x over x. Or sine of u over u. Very cool question, Sib. Thanks.
That's dope.
I hope you feel better. I'm sorry you have bronchitis. That sucks. Sibylle. What number was that in the queue? Answer me, boy. Turn up the brightness. Hey, you guys with all these usernames are hilarious. Sorry, Sid. What question was that? You were number 10. All right, let's mark number 10 done. In the queue. This is my hardest. Yeah, where are you taking this, Sib? Are you sorry? You're not taking this at UCLA, right? Are you taking this at SMC or something? I forget your story. I mean, I remember something was fucked up. All right. Last 2.5 hours. 24 questions. Let's go to work. I'll tell you offline because this is too public. Sure. Okay, let me know. Oh, Jesus. Someone's asking me very difficult things. Okay. What do we got? I just love that question. The one with the shapes. I love anything where it's like take the limit, it turns into blank. I'm like, oh, that's really cool. Right, because a many-sided shape, like a circle, is just a polygon with infinite sides. It's like a cool way to think about it. It's like as if you just like create. There's probably like an image of this, right? Circle is infinite, and it's like it's the forbidden polygon. Yeah, here we go. Yeah, like this stuff. Oh, I love, dude. These are great, dude. The troll math. Have you guys seen these? Draw a circle, draw a square around it. Perimeter equals 4. Remove the corners. The perimeter is still 4. Just keep removing more corners, and eventually you get a circle, right? I forget why this doesn't work, but it doesn't. This is also a really cool one. GeoGebra is really dope. So, in this case, here you could like make the radius a little bigger. So as you, yeah, let's see. Can these ads go away, please? Thank you. All right. So watch, as you increase the number of sides, do you see how eventually this thing like starts to look like a circle? Like already when you're at 30 sides, basically a circle. Really cool. It's a cool way to think about it. All right. FA, FB represent the force system acting on the corbels by a resultant force. What's a corbel? Y'all engineering kids, man. Specify its location on the XY plane. Okay. Ooh, do I have any on him? I don't actually. I need to. What do you need to know about imaginary numbers? Like how to manipulate them or like what they mean? Or maybe like complex analysis type stuff? So what are the rules here? Do I need all these forces? I don't know what FA and FB are. No, right? Oh, yeah. If they're the root, I got you. Willie, if you want to follow another really good friend of mine, here, I'll put it in the stream for you. One sec. Where is it? Zach, E to the 2I pi, does a lot of complex stuff. Complex analysis. And like not even like complex analysis if you don't even want to go that far, just like other there you go. Yeah, E to the 2I pi. He's the first one on that list. Go give him a follow on Twitch. He's also on the calendar. He's gonna do a stream Saturday morning if you want to ask about complex numbers. He's really good at like teaching that type of stuff. Yeah, he's good. He's a good friend of ours. Alright, so there's some unknown engineering. Any of my engineering audience want to help me out with this one? Like, I know that in order to get the resultant force, I'm going to use, like, the different X and Y components of these things, right? But how do I know FA and FB? Is there something I'm missing where, like, they're supposed to balance, maybe? I assume, right, that I don't want this thing to, like, tilt, right? Because that would be bad. So maybe we look at torque in, like, different directions? So let's look along this axis. Right, so along the y-axis. Oh, they're given. Oh, I'm dumb.
You done messed up, Aaron!
Thank you, Harsh. Jesus Christ, I don't know. I get that. I'm so sorry. Okay. All right. Sum of the moments is equal to 0. I agree. So we have That's how you find your location. Good. All right. So wait, if this is the origin, right? If I look in the y-axis, right? I have FB acting at 0.75. I have a 6-1 happening at this is 6 kilonewtons. FB is 5 kilonewtons, right? And then this is at 0.65. And then we have force A, which is 7 kilonewtons. And that's occurring at 0.6. Phazon says, the pi equals 4 thing fails because while the area approaches the circle, the perimeter is constant. At no point do the jagged corners disappear, even though the corners are getting smaller and smaller. Oh, I see. So, yeah, it's like impossible force and immovable object. Yeah, this is statics. What's up, Ahmed? 0.6, and then I got an 8 going down at 0.7. Okay. That's on the y-axis, right? I assume I then need to know something probably for the x-axis, right? Do I? Yeah, because we need both coordinates. I do know the Bernoulli equation. Yeah, I've definitely used it for sure. Okay. So we have FA. So I have 7. And then that's acting off on X by 0.15. And then it's acting to the right by 0.1. And then there's another one, FB, which is 5. Which is 0.15. Oh, Jesus. And then we have 0.1. It's actually kind of cool. 0.1. That's equal to 6. Cool. Alright, well, I already know what the resultant force has to be, right? You need the sum of the forces going down equal to the sum of the forces going up. So that's got to be 11, 18, 26 kilonewtons. Yeah? And then we just need to figure out the moments. Okay. So these moments are counterclockwise. So they're positive. So I'm going to say, I'm going to do everything. I'm going to drop the kilonewtons. So 0.75 times 5 plus 0.65 times 6 minus 7 times 0.6 minus 8 times 0.7 and then plus, right, some mystery. And if R is positive, it'll be positive. Plus some mystery 26 times R times Y, sorry, it needs to be equal to 0. Yeah, so this is sum of torques. It's actually really cool. See, I can do engineering when it's basically physics. When you all start putting weird, like, stress, tensor, strain, whatever things in here, I'm just like,
That's dope.
No. I don't want to do those. I don't know what those things are. Okay, and then for this one, 7 times 0.15 plus 6 times 0.1 minus 8 times 0.1 minus 5 times 0.15 plus 26x is equal to 0. If you're gonna do engineering, call it engineering. Yeah, this is just engineering. I like physics. Engineering is just physics, but like pre-packaged with like tables and like funny things to make it, I don't know, better for the real world, like more realistic. Okay, let's keep going. We're gonna get it. 2 hours and 20 minutes. Home stretch. Home stretch, guys. Home stretch. Okay. 0.75 times 5. Plus 0.65 times 6. Minus 7 times 0.6. Minus 8 times 0.7. And that's going to go over. And then we're going to divide it by 26. Engineering is a pain. Yeah, bro. I 100% agree, dude. It's just a pain. Like, why is it making me do all this, like, painful algebraic shit? All right. X is equal to negative 0.083. I'm only a first year and it hurts. Yeah. Okay, let's do the right side. But I get it, dude. It's mimicking like the real world. Like the real world is tedious. Like dealing with contracts and inspectors and HR. Like all that shit sucks. But that's what you have to like deal with as an engineer eventually. Okay, and so then this is divided by negative 26. So we get y wait, this one should have been positive. Yeah, wait, this one should have been positive, sorry. This one's positive. I forgot the negative sign. Excuse me. Minus 0.0038. Meters. Here, we can say 827 if we really want to. Nice. Okay, there we go. That's your answer. Congrats.
That's dope.
Do I have anything on the Bernoulli equation? Yeah, I could probably do some Bernoulli stuff. Can you go back over it, ABDE? What's ABDE? Over to explain. Yeah, sure. I got you. Okay, so, by sum of forces, all of the forces pointing down have to add up to a single resultant force, which is really the force of the ground pushing it back up. Otherwise, this whole thing would collapse. So, in order to figure out what the magnitude of that force is, which is this only up force here, right? I just set it equal to what all the down forces were, which in that case were these. So 5 plus 6 plus 7 plus 8. So that was equal to 26 kilonewtons. Okay, so that's the first part, is just figuring out, okay, what's the magnitude of the force? Okay, now I need to figure out, wait a minute, but where is that resultant force acting? So, assuming that this column is not, like, tilting anyway, and it's not gonna, like, keep falling, you assume it's balanced, which means that the torque pulling it this way has to be 0, and the torque pulling it this way also has to be 0. So what I do is I say, oh, hey, I'm gonna pretend I'm a person here, and I'm looking this direction, and I'm gonna see, based on this line here, which is y, where do all my forces fall along that axis? Reference to this origin point, 0. And so what I see, for instance, is, oh, well, look, To the left of this one, I have a 6 kilonewton force, which is located 0.65, 650 millimeters away in this direction. And that corresponds to this one. Okay? So then, for instance, this one. I don't care about how diagonally far away it is. I only care about how far it is in the direction of the axis. That's how torque works, or moment. You only care about the perpendicular distance to the force. In each axis. So this one is acting 0.75 away from the origin. So that's why I put this one located at 0.75. And then you do the same thing for this and for this. And so now you have a diagram of all the different forces and where they act referenced to some origin point. Notice that these forces are going to try to tilt this thing so that it falls this way, right? That's called positive torque or positive moment because it's causing it to like fall in the clockwise direction. So moment force, I think, refers to things that are static, which means they're not moving, whereas torque is usually equal to I times alpha and is associated with things that have angular acceleration. In my mind, they're the same thing. I think I've heard the formal thing is that in statics, they call it moment because everything is stationary. It's static. To me, like, things are in equilibrium is what we say in physics. And things are in equilibrium when the sum of the torques is equal to 0 because the angular acceleration is 0. Engineering doesn't talk about angular acceleration. That's why I say engineering is like physics with a condom. They try to like protect things and be like, well, we're going to use this thing because we don't actually want to learn about all the little like minutia. And I get it because a lot of engineering is based on like practical applications of physics. So you don't need to know all the little things. You just need a table that like approximates like what's up. Okay. So then these forces cause it to torque. Oh, interesting. Twisting and bending. Okay, there you go. There you go, Bob. Yeah, Ahmed Bob. Yeah. See, I don't know about that. In physics, we don't talk about twisting versus bending. To us, it's just like it's just moving. Again, and that's like that's the practical application of engineering. Is in engineering you care about how much something twists versus how much something bends. In physics you don't. Physics we talk about like rigid bodies and like things just like having momentums and stuff. We don't care if the steel snaps. Yeah. But the concepts are the same. Because you have again the torques from these, which is pulling it this way, have to equal the torques from these, pulling it this way. And so this is us adding up all the different torques. And then we add in an unknown torque from this one, which has a force of 26 and is located at some position Y. That is the equilibrium position that this resultant force needs to be at. Okay, then so you can just solve this for Y. You get a value. And then you solve this for X and you get a value. Oh, and I think I made these backwards. Sorry, I did do these backwards. Yeah. Sorry, this one is X. Sorry, this is X. This is Y. That's me just being tired. Okay. Does that make a little bit more sense? These are all just, these are torque terms, right? This is equal to, like, force times the radius. Sure does? Nice. Okay, great. I'm glad. Awesome. Good job.
That's dope.
Good job.
Well done! Well done!
I got the best of both worlds. I have a BSc in engineering of physics. What is engineering of physics? What? That's a fun degree. Engineering of physics? Okay, I'm gonna dump the screenshot for this in our Discord. So again, if you want to go join our Discord, all the answers I post are there. Also, anything I don't get to on this queue, because this queue is up to 23 questions. If I don't finish all of them in 2.5 hours or whatever amount of time, they'll still get put into our Discord as like the spillover. And I have a bunch of other awesome people who like to stream and help out, and they may answer them for you. And if you don't get an answer within 2 days, I then have a bunch of API tokens from a Microsoft sponsorship that I'll just burn it on GPT-5 Pro for you. So I will just run the most expensive AI model at it, and it will give you something that you can at least reference to see whether it's right or not. I say AI is great for like studying because it's like a friend that you get to bounce ideas off. I know how like weird that is, right? To say AI is our friend. But I understand it is harder and harder these days to like, I don't know, create friendships, maintain friendships. So, you know, sometimes you're learning remote or everyone in your class fucking sucks and like doesn't want to be social. I get it, especially in some of the STEM classes. So AI can be that person to just bounce ideas off of. And again, AI is not right all the time, just as your friend wouldn't be right all the time. Oh, this one. I miss statics. Life is so much simpler. Yeah. This one has been done. I'm pretty sure. Yeah, you got the homogeneous solution, which is great. Dude, I'm very sure this has been done in my. I think it's literally been done in my server. And it's kind of a pain in the ass, honestly. But yeah, the homogeneous solution is easy, right? Anytime you're just solving y double prime plus 9y is equal to 0, you assume e to the at is your solution. So then y prime is equal to a e to the at, and y double prime is equal to a squared e to the at. So basically, like, the derivative level becomes the exponent on a. You see how second derivative is a squared? And so this gets you a squared plus 9 is equal to 0. So a equals plus or minus 3. 3i, right? Yeah. And when this happens, this means you have oscillating solutions of sine and cosine. Because it is technically e to the 3i... Wait, was it 3ix? Plus e to the negative 3ix. This is technically what we call like the homogeneous solution. But the other way to write this from Euler is you just write this as like c1 cosine 3x plus c2 sine 3x. Okay. The other part, yeah. So then solving the particular solution, this part sucks. I know, because I literally had someone do it in my I'm gonna go find it. Let me see. From e to the 2i pi. That's that. That's cosine. Wait, what the hell was Zach doing here? Dude, I know he did this question. Zach from Rampton. Yeah, here we go. Yeah, this is differential equations. So yeah, the really cool thing, again, about my Discord is that I can go in and see what other people have done for like solving problems, because we store all of them. And so this is cool. Rampton has literally done this question. So rather than me go through and do it, I'm just gonna show you like how he did it. And this is for a slightly different question. So here, this one was y prime plus 9y is equal to cosine 3x over 4. Do you see how that's basically the exact same as this? They're just instead of over 4, it's just 18. It's the same question, right? So right, this is the homo solution, which gives you this. And then the particular solution, yep, variation of parameters, exactly. Yeah, you do variation of parameters on this. So variation of parameters is, you say y particular is equal to u1 y1 plus u2 y2, where this is y1, this is y2, and what is u1 in this case? Oh, this is u1, right? Oh, and then you need the Wronskian thing, the w. Yeah, okay. You do this. Oh, the nice thing, this is cosine squared and sine squared, so this just gets you 3. Oh, fun. Oh, okay, cool. Okay, so then u1 is equal to this integral, which is just negative 1 over 12 dx. Cool, so you just get that. u2 is equal to this, which is another u sub that you do, which gets you ln. So then you have, this is the homogeneous solution. This is from fuck, where is it? This is from u1, negative 1/12 x cosine 3x. And then this one is from here, ln sine 3x. Okay, cool. Yes. All right. So literally follow this process. It's the exact same thing, but instead of a 9, instead of dividing by 4, instead of having a 9, you have an 18. But I'm a reference this for you, just in the essence of time. Let me know if any of this doesn't make sense. It's a pretty standard variation of parameters question, which is a diffie-q trick that just sometimes works. I forget why it works, but it just does. It's almost like, I think it's like a reverse chain rule. No, sorry, it's like a reverse product rule for integrals. Yeah. Okay, cool. I'm gonna say similar.
Well done! Well done!
Is there a case where it fails to work? Good question. I think when the integral is difficult. Yeah, you don't want to do variation of parameters when this thing becomes a nightmare. We got lucky here because this ended up just being 3, because sine squared plus cosine squared was equal to 1. And then these were fairly simple trig integrals. If this integral you get for u1 and u2 is just an absolute horrendous nightmare, then this is not the way to do it. So, a lot of diffie-q is just kind of guessing and checking, and there's a certain like toolbox of solution strategies that you use, and again, it's math, it's pattern recognition. You just say to yourself, oh, this diffie-q looks like another type of diffie-q I know how to solve with variation of parameters, let me try it. Actually, I mean, the first thing you learn in differential equations is to guess solutions. You just say, this looks like it's the solution of this form. Let me go try it out. And then it just works. It's one of the funnier maths to me. Because it seems kind of, it sticks. I would always forget the ending of the YP solution. Yeah. Oh, JHNet, was this yours? Was this your question, by the way? Sorry. I just saw you in my Discord. I mean, the ending part is just the y2, right, and the y1. Right, because I think this is just, yeah, what is that? u1, y1, yeah, this is u1, y1. u1, y1, u2, y2. Nice. Okay, cool. HK. You did differently. Oh, okay. And again, there's a lot of different ways to solve differential equations. You don't have to do it this way. I think this solution that got posted by Ramton was after I think Zach had attempted it, but like done like a horrendously more difficult way to do it. I think he started like trying to guess solutions that were of the form cosecant. Basically, he's trying to like guess the variation of parameters. Okay, let me get rid of some tabs real quick. We don't need this. We don't need this. Okay, cool. Let's see what this is. E&M question coming up. An infinitely long conducting cylinder of radius A has a surface charge density rho s. The cylinder is surrounded by a dielectric medium ER is equal to 4 and contains no free charges. The tangential component of the electric field in the region R greater than A is equal to negative phi cosine phi over R squared. Since a static conductor cannot have any tangential field, this must be cancelled by an externally applied electric field. Find the surface charge density on the conductor. I think large guy said I could skip this one. Because... Unless you're still here, large guy. Tell me if you're still here. Otherwise, I'm getting tired. We're at 8 hours? Need more Red Bull. Okay. I'm gonna skip on this one real quick, just because I need to be getting tired. And we still got to get it. We're gonna make it to 10. We're gonna do it because I want to do 24 at some point. Unsolved. We'll leave that. All right. Abstract. Oh man, is this group theory? Wow. Jesus. I am also going to punt on this one. Here, that one's abstract. So here's the cool thing. Even if we don't answer your question here, I'm gonna mark it specifically as unsolved. I'm gonna give it unsolved, and then I'm also gonna say for the math gods. So this will be like a fun thing. If any of my other awesome math god friends want to go solve, they're gonna get a ping for it now. It's like calling in the heavy artillery. It's like send in the Eagles. Okay. Definitely not Armin. Oh, this is kind of cool. It's another statics question. Tipping. Tipping is always interesting. You should always tip your waiters, by the way.
My man.
All right, what are we doing? A uniform cubical block of mass M inside L. Cool. Is lying on the edge of a rough table with a quarter of the edge overhanging when a small block of mass M is placed on the top surface at the right. The cube is on the verge of toppling. Okay, so it's like about to topple. The block of mass M is given a sharp horizontal impulse so that it acquires velocity towards B. The small block moves on the turf surface and falls on the other side. What is the maximum coefficient of friction between the small block and the cube so that the cube does not rotate as the block moves over it? Assume that the friction between the cube and the table is large enough to prevent sliding the... Okay. So this doesn't move. So tipping occurs when the center of mass is like to the right of the center. So when the when the center of mass is to the right of the rotation point, right? So when This is the rotation point, right? Because this is the thing. This is the point at which things are like kind of tipping around. And I think what you want, in order for something to be barely tipping, I need the center of mass to be like right here. Once the center of mass moves a little bit to the right, then this thing just falls down. I think. So you want the center of mass to be right above it. Yo, what's up, Collarstone? Welcome. I saw you and Penn had a cool stream on the other day. What were you guys talking about? It was something mathy. Nice. We've reached midnight, by the way.
Whoa, nice. Nicely done, man.
Oh, what's up, Penn? I was just talking about you. I said, yeah, there's Collarstone. Didn't y'all do a stream recently?
Yeah, we were. It was like a story time with Sasha. It was wild. Sasha was going on about like some crazy manifold stuff.
Oh, okay. Yeah. See, y'all are deep in like the math land. Riemann surfaces? See, I don't even know what these words are. I mean, I know what a Riemann sum is. Like, I'm smart. It's a Riemann surface.
All I know is I saw that you had like posted linear algebra, so I kind of want to go check and see out what it is.
Yeah, please go check it out. Yeah, that was where did I post it? Well, it's in the Discord. It's this one. Yeah, whatever this is. This is kind of your stuff, right?
Oh, this looks like group theory. Yeah, this is a group theory.
Didn't you do a group theory? You did a group theory class at some point, didn't you? Or something? I want to say you did.
It was, I would say it was more so like Stuckey that was in control of the group theory one.
Okay.
And I was just casually hosting.
A conscientious observer.
Yeah, group theories were like is where algebra like goes like kind of crazy.
Yeah. For me that was like complex analysis. The second we started talking about like going around imaginary holes and poles, I was like, dude, bro, you guys need to stop. What are these holes and poles you guys are talking about?
I kind of want to look at this though. This is crazy.
Yeah, I have some funny like YouTube math warriors that always submit like really interesting questions to me.
Did you have any other like good math god questions tonight?
Let me see if I did. I probably did for sure. I mean, someone asked about the DiffyQ one wasn't bad. What was it? I did something with linear. I figured that one out. Nothing super. What's that?
I love that you vibe coded. Basically asking like, do you use a GPT-5?
Yeah.
I love that you just like vibe coded to give it answers to the question after a certain amount of time. I think that's pretty fire.
Right? Yeah. I was just telling everyone because there are like a bunch of people in the queue and I'm like, I'm not gonna get through everyone, and I never do. Like I'm always like, I have too many questions. I dump them into Discord. Maybe some other people like a day or two later answer it, but then I don't want to leave people on a lurch. So yeah, I spent all of yesterday coming up with this way to, because Microsoft gave me $2,000 in like Azure credits just for being a nonprofit. So I have
right.
I have money I can just burn on, and Microsoft owns OpenAI basically, or ChatGPT. I mean, they invest in it heavily. So
nice. I didn't know that.
Yeah, so all of this is hosted on like Microsoft servers, and I use that like grant or whatever they give me to then just run this through like the most expensive version of ChatGPT, and then it creates these nice little pictures of the solutions for people.
Yeah, I think that's pretty awesome.
But only after 2 days.
I like the system. I like the system too, where you kind of like tag it as like unsolved. So if I ever get a chance to like actually just randomly solve math questions again, I might just filter through the unsolved ones.
100%. Yeah, and that's another thing that I think is beautiful about the exposure we get on like YouTube and TikTok is it's basically a funnel. Instead of like going to those whatever you know like the math Reddit or something being like blah 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 what's unsolved, these are questions that like humans have tried to ask me, And if you're just looking for content to just churn through, there's like an unlimited amount of them.
Yeah, which is awesome. You've accomplished the thing that we've been setting out to do for like 3 years.
Where's the spigot? Where's the spigot of questions? Now we just need the streamers, which we kind of do. And like we're getting more people on. Like JC is streaming. I'm like, great, yes, nice. Let's get more people.
Yeah, Joseph's awesome. He's a great guy.
I love him. He's great for Kim.
All right, I just wanted to pop in and say hi. It's like,
so good.
You know how late it is. I gotta look at this question and then probably go to bed to get ready for the podcast.
I will be there at your podcast. I will get my 6 to 7 hours of sleep, and I will come by and see it. But awesome, I'm looking forward to it.
Amazing, brother. I am so proud of you for already putting in 8 hours of work. This is phenomenal.
Awesome. Appreciate you, Pen. Thank you. You the best.
All right, have a good night, Gold.
Night, dude. Yeah, Pen's another awesome person, another streamer. His stream, again, so if you're just watching us, I always tell people, I'm not the only person that does this. There are a lot of other awesome people in our community that stream math and science help and various interesting discussions. So if you go to the website where you're dropping the screenshots in, and you go to the streaming schedule, you will see everyone else on our calendar here who is streaming. So we're almost done. We're on the home stretch. I got an hour 48 left. But 8 hours after that,
Good job.
Penn Center, who was just here, is going to do a podcast with Zach, E2iPie. He's another great math streamer who's really dedicated into doing math education on Twitch. They're going to have a podcast at 10 a.m. Pacific time. So I invite you to go to that. Oh, wow, Penn. 5 tier 1 subs. Thank you, dude. Wow. More gifted subs today. Fucking love that, dude. We hit our sub goal of 30.
That's dope.
That's sick. Thank you, Pen. You're awesome. But yeah, go check out their podcast tomorrow. And then also we have more stuff on the weekends. All throughout the week. We stream 5 times a week. And everyone else streams a lot. So there's a lot going on. I love this, dude. I love these gifted subs. This is so cute. Love this. Look at that randomizer. See, it pays to watch. You get the subs. You get cool emojis. You don't have to watch ads on my channel. I don't want you to watch ads anyways, but they make it happen. The Twitch gods that be. All right. Side length of L. Okay, this is all side length of L. L over 4. Do they tell me? Algebra go, bruh. Do they tell me
It's a small block. Yes, gotta get the baby voice on the way out. That's dope. I love the baby voice. Oh, I see. I think we assume this is negligible size. I don't know what the A and B is, except that they're just points. Right. Okay. So the center of mass of the big block M.
That's gonna be located here, right? At, let's call this 0, 0. I'm gonna call it 0, 0. So the center of mass, due to the big block, let's call this like 1, and let's call this 2. That's gonna be equal to L over 2, comma L over 2, right? And then that's weighted by a weight M, big M. And then the center of mass due to the small block is going to be equal to small m. And that is going to be located at L over 4, comma L. All right. And so the key thing that I want is I need the mass to be such that the total center of mass in the x direction is basically at 0. Okay. So center of mass in the x direction is equal to big M L over 2 plus little m L over 4. And sorry, this is negative L over 2. Right? Because this is 0, 0. And that has to equal... And then it's always divided by the total mass as well. This is big M plus little m. It's a weighted average. Good joke. Okay. So... this helps me then determine little m, I guess. Right? Yeah. And then we got to talk about... Okay. Cool. Alright, now I apply a force, right, to this block, and there is friction, right? So when this happens, okay, this thing will start to move, but it will also feel a force of friction in this direction, right? Because friction will act on this in this direction, which will in turn mean that this is having a force exerted on it this way, right? I think that would help with the stability, though. Why would that cause it to fall? A sharp horizontal impulse, so it acquires a velocity b, a velocity towards b. What is the maximum coefficient of friction between... So if you apply a force to here, friction applies a force back. Oh, which... Yeah. Wait. That goes that way. Friction exerts a force to the left. So the force acting on the block has to be to the right. To the left, sorry. Yeah. So wait, what the hell? That should make it more stable. The cube does not rotate. It's not gonna rotate. Because if anything, as this moves this way, your center of mass is now more firmly over something that's nice. That's not causing it to tip. Interesting. Well, actually, I don't know what's going on here then. Is this just a poorly worded question? Alright, who in my engineering team here knows what's going on? Yeah, it should be fine. Alright. ChatGPT. Let's see. What do you got? Yeah, exactly, Bob, right? So, if I look at the forces acting on little block M, right? There's a pushing force, which means that friction is going to push on block little m to the right. But that force of friction is provided from big block M. And by force pairs, right, equal and opposite forces, Newton's third law, that means big block M must be feeling a force of friction to the left, which I think would help with its stability. You think I'm taking the direction of friction to be wrong? I don't think I am. I mean, unless I'm crazy because I've been streaming for 8 hours. But... yeah, when the block moves to the left, friction acts to the right, but that force is... that force is acting on the big block to the left. They want, like, no... well, it's not going to fall to the right. Oh, wait. Oh, they just want that it just doesn't rotate. Oh. Wait, but it still won't rotate. Because it's barely there. it can't rotate anymore this way. I don't think this is correct. I don't think it's correct. I think it's wrong. Tell me, Clanker. Ugh. Here we go. Condition on the verge. They say M is so big M's equal to little m. Is that true here? I don't think that's what we got. Tell me, Clanker. Don't tell him. Don't tell the. When they take over, dude, they're gonna know who was being nice to them. I say thank you on all my ChatGPTs. Okay, so this is negative ML over 2, right? Oh, so this is, all right, big ML over 2 has to equal little ML over 4. Cancel, cancel. I think big M has to be equal to, well, that's weird, 1/2 little m? That don't make no sense at all. Well, actually, it does make sense, right? In order for this to tip, wouldn't this have to be pretty heavy? This is only a quarter of the way off on the side, right? Like, look at all this mass here that does not want it to tip that way. Okay, I'm mad. Okay, with the small block at the right edge. Yeah, dude, what the fuck is ChatGPT doing? Big M L over 2. Yeah, this is it toppling to the left. It can't topple to the left. No. It can't topple to the left. Wait, what? I'm gonna debate with ChatGPT. I don't think it's right. Yeah, the pivot's at the lower right edge. I mean, yeah. GPT will switch teams now. Dirty, disloyal, cheating Clanker. Do y'all know about that meme? I love this. What was it? Stack Exchange Chat GPT meme. This is my favorite meme. Where is it? Or Stack Overflow? I thought it was Stack Exchange. Yes, this one. Yeah, what's up, Mugman? Thanks for the jewels, dude. And a party hat? Oh, we're partying today, dude. Does my hat get the party hat? This is ChatGPT in a nutshell. So Stack Overflow used to be like, everything you do is wrong.
You done messed
And
up,
then
Aaron!
ChatGPT just gaslights you into being like, not gaslights you, whatever. Just like, you're always right. I don't know what the psychological term for this is, but okay, you're right to put the rotation on the table edge. The only horizontally, okay, it's 0 table edge. The cube center of mass is a horizontal. Good. Yes, I agree. Or sorry, it's negative L over 4. Oh, okay, maybe I did mess up here. Okay. Yeah, sorry. This is located L over 4, not L over 2. Okay, so now this is the same. Okay, cool. Okay, great. So yes, big M equals little m. Okay, cool. All right, sorry. Clanker was wrong about the reason why I had the right answer, but okay. All right, cool. Right, so mg L over 4, mg minus L over 4 is that. Okay, so even though most of the bib Q, the combined center of mass is exactly above the edge, one more speck rightward and it tips. Exactly. From there, as the block slides left, the kinetic friction on the cube is a horizontal force to the left applied on the top face, creating a counterclockwise torque. Wait, okay. So how does that cause it to tumble, though? From there, as the small block slides left, the kinetic friction... This is just funny. Okay, I'm a little confused, Armand, how this is working. The block slides to the left. I agreed with that. Kinetic friction on the cube. Wait, which cube? The kinetic on the cube is a horizontal force to the left. Oh, okay, so they're talking about this is the cube. Yes. About the cube's bottom left edge. So we can only pivot around here once it moves this way. Sure. So its weight gives no stabilizing moment around the left edge. Dude, this sentence is giving me a stroke, dude. What? Right, and then when it's here... Oh, so, okay. So when they talk about any rotation, it's funny enough, they're talking about this rotation. They're talking about the box moving, like, this way. Which I agree, it could. Which, yes, okay, so as long as this thing is somewhere over here, it provides stabilizing torque downwards, right? Yo, good morning, JC. Did you have a nice nap?
Good job.
We were just talking about you, me and Penn. Okay, this actually makes sense. So when it's here, okay, so when the block is here, its force of gravity points straight down, reference to this rotation point, which means it's not offering any stabilizing force to keep it this way, because it wants to rotate this way around this point. Does that make sense, Armand? They're talking about they don't want it to rotate this way. Is it possible to get help with a phase diagram question? You can submit it, Mies, and I'll take the line is hella long, but I'll make exceptions to my Discord users. I see. Okay. So when it's right here, okay, you do have the force of friction, which, force of friction. So this has to equal this torque. Okay. Oh, very cool, actually. So this is now L over 2 away, big M. So you have big M G L over 2 needs to be equal to what this torque is pushing it this way, which is the force of friction, which is, it acquires a velocity towards B. Do they give me any mu? What is the maximum coefficient of friction? Oh, okay. But the maximum coefficient of friction is equal to mu k Fn for the small cube, which is mu k little mg. Uh-huh. Okay. G's cancel. So mu k has to be less than big ML over 2. Anyway, what do they say? F. Wait, there's still an L there. Oh, wait. No. But the torque, right? Oh, but the torque is acting at L. Oh, so that cancels too. Oh, so is it just big M over 2? Okay, I need one more thing. I need one more thing. I'm close. MGL over 2. Where are they getting this FL? Oh, and F is... Yes, F is little u mg. Oh, but little m equals big M. Oh my fucking god. Yes. So it's just 1/2. Oh, very cool. Oh my god. Oh, wow. Oh, wow. Right, yes, because big M equals little m. Okay. It's just a weirdly worded question. I thought for sure this thing would tip this way. But they were talking about it tipping this way. Very cool. Does that make sense, Armand? Do you want me to run through it? I can explain it. It's not too hard. Did Armand die on us? Come on, Armand. Come back to life, dude. You got it? Okay, cool. Excellent. Okay, very cool. See, that's why I like ChatGPT. Again, you have to use your brain. If you're just copy pasting shit down, you're not gonna learn anything. But if you're like asking questions and critical of what the clankers come up with, you will learn. I learned. I learned now to like look for rotation in both sides. Oh man, that's super cool. Alright, where's all the questions? See, everyone gonna assume it's gonna topple off to the right. I agree too. Yeah, but I understand now. It's a shit... Okay. Regardless, it's a shit question the way it was worded. Sorry, I'm trying to find... Where's my cue? Yeah. It was a shit question how it was worded. Oh, okay. You're good. You're good, Miza. You can drop your question. I'll do it right now. Just drop it. I'll look at it real quick. Ooh. Ooh, we're up to 10,200 followers on YouTube. Nice. Great, we keep going up. Sorry, I was trying to like download this question for Armand real quick. How's the stream been? Pretty good, dude. Yeah, it definitely has gotten good. Well, it's training on stuff. It's training on stuff for sure. Yeah, like Indian publishers mend down questions accounting to their own way rather than printing what the author gave it to them. Ooh, diopters? Someone has a optics question next. I hate optics. I really don't like optics. Without wearing, the farthest she can stand from a sign on the wall is 38 centimeters. She found a pair of sunglasses she likes, and the lenses will sit 2.2 centimeters from her eyes. What should be the power of the lenses rounded to the nearest quarter of a diopter so that she'll be able to clearly see distant objects? Hint, in this constant, distant means infinitely far from the lenses. The answer should be stated in terms of L and X, though not all of these are needed. As part of the representation, make sure to include a diagram containing the eye, the lens, the object, the image, and all relevant distances. Okay. So, gotta draw a lens first, right? A little lens. Cute little lens. Ooh, Pen, you already have some stuff on this. Wow. Look at Pen. Pen's like, I'm not going to bed, dude. Like, I'm gonna go solve some group theory. Oh god, what's happening here? You're gonna give me nightmares, Pen, before I go to bed. What is this? Oh god. Alright. Alright. This right here is the lens. So here, we'll say lens. And wait, when she doesn't have the lens, right? So here's like the eye. Do I have to do like the cornea? Eye. And we say this is equal to 0.022. And then, but like when she doesn't have anything, she can see 38. The furthest she can see is 38 centimeters. I think that tells me something about what's going on here. I think I want like 1 over di plus 1 over do, right? Okay, I need to know power. What is power for lenses? What's up, Pawan? Oh, okay, power lens is equal to 1 over f. Very cool. Oh, oops. Yeah, I like rotational motion. Okay. So, from the lens equation, right? we have 1 over f is equal to 1 over do plus 1 over di. All right? And I want to be able to resolve things that are infinitely far away. On like magic bird vision or something. Okay. In order to do that, that means do needs to be like infinity, right? Because this is always like the object. So this is what she can see naturally. This is the furthest she can see. But then I want to see someone really, really, really far away. Like do is equal to infinity. And then I think it needs to create a virtual image on my eye. So if do equals infinity, then 1 over do is equal to 1 over infinity, which is equal to 0. Okay? So that just tells me that 1 over f is equal to 1 over di. Or that f is equal to di. All right, so the focal length is equal to the image distance. Boom. All right, so let's think about this. Okay. So, I need... This is actually kind of cool. I need the lens to create a virtual image that is located... So here's what happens, yeah. You have person way out here. This is at, like, do is equal to, like, infinity, right? And then I have a lens that I need to create an image that is located 38 centimeters away from my eye. Because that's how far I can see. Naturally, right? So naturally, I can see this. 0.38. And actually, this is a little bit skewed. Let's do it this way. But the lens is sitting 0.022 meters away from my eye. Right? Because it's 2.2 centimeters from the eye. Okay. Cool. Ooh, okay. So, DI, in this case, because image and object distance are always measured away from the lens, DI is actually equal to (0.38) minus 0.22. Okay. So that means that F and then here's always my convention for like how the distances work. You always think about like which way the light wants to go. So for a lens, object light goes in this direction, right? So measuring out here is negative, but negative 1 over infinity is 0. It doesn't matter, okay? After it hits the lens, light still wants to move this way. So an image distance that's over here on the left is in the negative direction of what it naturally wants to propagate. This changes for mirrors, right? Mirrors object distance is this way, but then image distance is positive this way. For lenses, object distance is negative this way. And then it's positive this way. Oh, that's cool. Actually, sorry, object distance is almost always negative, right? Because light always emanates from the object. And we measured that thing opposite to that direction. Okay, DO is always negative. DI changes from negative to positive based on whether it's a mirror or a lens. So this is actually equal to negative 0.38 minus 0.022. So that's negative 0.358. Okay, so negative 0.358 is equal to F, but then power in diopter is equal to 1 over F. So that's 1 over negative 0.358. Oh, this is cool. I think we're going to get a cool number here. So 1 divided by negative 0.358. That's going to be 2.79. But usually, reading glasses or like whatever glasses is always like in increments of quarters. Very cool. Oh, so this would be negative 2.75. Very cool. All right, yeah. And then let's think about like how that works, like the lens, how that works. What type of lens must that be? That must be a concave lens then. I think so. Yeah, this is very cool. So actually your lens has to look like this. Kind of weird because I don't really feel like I don't feel like glasses look like that. I feel like they're rounded the other way. But yeah, what happens is, and again, if this is, I guess, like, so the focal distance was 0.358, so that's like right here. This is the focal distance. Nice. Yeah, no, I'll get to it, don't worry. So, I think it's like, this goes through here, and then like bends out like this. And then I want to say it does like that. And then it's something like the back of it like becomes this. I'm tired. But okay, cool. All right, cool question.
Well done! Well done!
All right, whose was that? Habaka. Habaka's question. Hey, what's up, Jaden? 10 hours. Yeah, we're on the last hour and 10 minutes. We've been streaming for 8 hours and 50 minutes. We're here. My brain is slowly turning to mush. Let's see, what'd you ask, Kushnat? I'll just look at it real quick. Oh no, it's JEE questions.
That's dope.
No, I don't like JEE questions. Zhangzhu, you need help with your math? Turn it. Yes, send it in. Turn up the brightness, dude. I can't even read this, dude. What the fuck? Yeah, send it in, Zhangju. I'll do it. I'll make sure I get yours done because you've been in our Discord for a while. I appreciate all the new people that have met us. Please join our Discord after you get home. Okay, you got an hour and 8 minutes before I'm gonna go. Okay, I'm trying to like read this. I feel like I'm reading like the Dead Sea Scrolls or something. A rectangle has a length that is 3 meters more than twice its width. Okay, that's correct. The area of the rectangle is 44. Okay. Yeah, this is a good way to say it. Yeah, length is equal to 3 more plus 3 than twice its width. 2w. Width is w. Area is 44. So then you multiply that together. So you get 44 is equal to w times 2w plus 3. So that's 44 is equal to 2w squared plus 3w. So I think this is probably where things might be messing up. Or maybe you got it right. No, you got it right. This is all right. Yeah, because watch. 2w squared plus 3w is equal to negative 40... minus 44 is equal to 0. It's kind of a weird one, though. You need factors of 88 that add up to 3. Oh, this is actually really cool. Here, I'm going to show us real quick how this works. This is a cool method to do this. So, that and that is negative 88. Factors of that that add up to positive 3. That's going to be positive 11 and negative 8. Because 11 minus 8 is equal to positive 3. So that works. So then you put these numbers on the diagonal. These are the factors. So you say 11x minus 8x. And then you put the minus 44 on the bottom right. And then you put the 2w squared or 2x squared, whatever, on the top left. And now your job is to just factor as much as you can. So I'm going to try to factor out of this. I can factor 2x out. And then I say to myself, oh, 2x times what gets me 2x squared? Well, that's 2x times x. And then x times what gets me 11x? Well, that's 11. And then 11 times what gets me negative 44? That's negative 4. And then the cool thing is these are now your factors. So now you have x minus 4, 2x plus 11 equal to 0. And then we want the positive solution for x because that's a w, right? And so that would be this one. So x is equal to 4. And then if x equals 4, which is the width, we know length times width has to equal 44. So that tells me the length is equal to 11. And you're done. Nice. That's a good question. Cool. Not bad. I like that. That was a nice one. Alright. We're rolling. We're rolling quickly. They keep coming in. Okay, cool. Next one is from someone who said, "Answer me, boy." I hope I'm getting some softballs. Okay. Aubrey has some pennies and some nickels. She has a maximum of 20 coins worth at least 56 cents. If Aubrey has 5 pennies, determine the maximum number of nickels she could have. Yeah, Mizan, if you submit it, I'll let you skip. Just submit it. I'll let you do it. Yeah, Etienne said, or negative e plus the root of b squared minus 4ac all over 2a. Yeah, you could have done the quadratic equation here, but this is one of these cases where it's actually, it actually factors pretty nicely, so it's just nice to factor. Factoring is beautiful. Okay, maximum of 20 coins. So whenever you get these questions, always assign a variable to something. I'm going to say x is pennies and y is nickels. And so I know x plus y is less than or equal to 20, right? Maximum of 20 coins. But then worth at least 56 cents. So that means 0.56 0.05 times x, right? Because 5 cents for every... No, sorry, fuck. Oh, wait, we gotta reload. We've hit the next marker. After 3 hours, this thing gets mad at me. Right, there we go. Come back. 1 sec. Okay. Sorry. It's 1 cent per penny. So 0.01 times x plus 0.5 cents per nickel has to be worth at least 0.56. Okay, so I already know x is equal to 5. That's kind of nice. So x equals 5. So then 5 plus y is less than or equal to 20. So y is less than or equal to 15. Alright, now let's plug stuff in here. 0.05x... No, x is 5. So 0.05 plus 0.05y has to be greater than or equal to 0.56. Okay. So, I can plug that into that. Or subtract that, right? So I get 0.05y has to be greater than or equal to 0.51. And then I can divide by 0.05. Divide by 0.05. So y has to be greater than or equal to... This is like 10 point something. But you can't have a fraction of a nickel. So the minimum number of nickels is 11. But can't have fraction of nickel. So y equals 11. Nice. Cool question. I like that. Who is that? Answer me, boy. Okay, fine. You guys leave nice messages for your usernames for me. Okay, there we go. Where's my post? Sorry. I'm losing my mind. Okay, we're getting down to 18 questions. And we're entering the final hour. What's up, Cold Gold? What's crack-a-lackin', dude? Alright. How does differential inequalities work? I'm not sure. You mean diffie-q with inequalities? I mean, probably just like other ways we work with inequalities. Just set it equal to each other and then just test points in between. Home stretch, final hour.
Good job.
Yeah, we're gonna make it. I know we're gonna make it. It's funny. The clocks are like not synced amongst my TikTok and my Instagram. They're actually different. All right, Mizan, what's the question here? What the fuck is this? Looks like ooh. Where does coarse versus fine perlite form? Oh, I have seen this before. This is some interesting engineering stuff, by the way. Oh, I've done this. Is it thermo? What university question is this? This is probably a college level question. Oh, it's materials. Properties of materials. So, yeah, is that engineering? It's not thermo. All right, one sec. Let me eat some soup so I can regain some knowledge real quick. Like a soup. Engineering materials. Okay. I'm assuming one of these symbols here is between coarse and fine perlite. Let's go find it. Etienne says, yep. This is like a diagram. Not necessarily. I think you have to check the bounds. Oh no, perlite. Yeah, here we go. Okay. Yeah, there are still people asking questions. That is correct. Yeah, I remember this. It's like, it's how you heat stuff and cool stuff down, right? Yeah. It's if you cool stuff down like too quickly versus heating it up too quickly, you get like weird shit happening. Yeah. So yeah, let's go find this. Go find me this diagram. Temperature versus hardness and time or something. Yeah. So how's this work? Yeah, this is like Martensite. Bane. Dude, what are all these things? Dude, what the fuck are all these ites? Wait, that image is a godsend? No, I think you just like fucking pick something. You're just like, well, this is where it is. Oh, I remember that. Wait. Yeah. You have to like stay within this zone or something. Like, there's a curve that you have to like as a function of time and heating, you have to like stay within this, I think. It tells you the lower temp is fine and the higher is coarse. W. Oh, okay. Yeah. Okay, so this is like fine perlite and this is coarse perlite, I guess. Oh, my TikTok is like screwing up. I don't think TikTok has been used to someone streaming for this many hours. We've got 112 followers. Yeah, you couldn't find this? Okay, cool. W, dude. Nice. All right, I'll send this in the chat for you too. It'll go in the thread. So. What question were you? Number 17. Yeah, sometimes Google's your friend. Just works. The only reason I know about this Meeson, by the way, is I remember tutoring somebody literally in that class. Here. There you go. There's the diagram for you. I'm gonna tag you in it. Ooh. Am I like drunk, dude? How am I supposed to read this? Excuse me? Dude, what? How do you get this effect on your phone? How did you do this? One sec. I need to get my chat working again on. Come on. Bro is still using... Dude, Penn Center, you're still here. Go to bed, Penn. I love you, dude. That's so funny. Penn, you have a podcast to get ready for in 9 hours, 8 hours and 45 minutes. Yeah, dude, what flip phone is this, dude? What is going on here? Is it the 8th or the 3rd? What do we think? What do we think, chat? What is that? I want to say it's the 3rd. The 8th route wouldn't make any sense for 108. You can't really find 8 things that go into 108. Right? Sorry. I think this is the 8th route, the 3rd route of 108. Cool. These are called surds, by the way. So all I'm going to do is I'm just going to like break this up into a bunch of different factors. So I'm going to say 2, 54, 2, 27, 3, 9, 3, 3. This is called prime factorization. Because at the end of the day, I could also write this as the cubed root of 2 times 2. So 2 squared times 3 times 3 times 3, which is 3 cubed. That's like another way you could do it. What I like to do is, because we're cube rooting, I look for where I got groups of 3 right here. And those are going to come out as a single number 3. And then whatever is left and lonely has to go back inside the house of shame. So this has to go back inside. But these go back in as like multiplying by each other, not as like one number. So you end up getting 3 times the cube root of 4. And there you go. Nice. Yeah, Kubi, where are you? What's your name on the queue here? I just answered a question from someone who asked it. Jesus, look at that. That's almost 6 hours ago. Kempi, okay. I'll come help you, because yeah, you are begging on my chat, I guess. I don't know. Because it's okay. I know the line is long. We're doing it. This is a special event. We've been celebrating getting to 10,000 subscribers on YouTube. So I did a 10-hour stream today, or I'm doing one. Y'all are in the final 10th hour. In 51 minutes, we will have done 10 hours. I think I could do 24. I feel good. I could do 24. I might need like a lot more coffee. I'm pretty sure I could do it. Or maybe I'm just getting delirious at the 10th. All right, Kempi, what do you got? What do you got for me? Oh, nice. Oh, these are fun. Cool. Okay, this is the graph of f prime. So this is the graph of the derivative. And it has horizontal tangent lines at x equals -3, so this is cool. So this is a horizontal tangent line. So that's at 3, 2, and 5. Yeah, this is probably Calc 1. And 5. Great. Cool. Find all values for which x attains a relative minimum. Okay. So minimums occur when the first derivative is 0. So local min when f prime of x is equal to 0 and f double prime of x is positive. Because if f double prime x is positive, that means it's concave up, which is happy face. If it was negative, it would be concave down. But we want happy. Right? Happy face. And that means this right here is the min. Okay, so let's look. Where is f prime of x equal to 0? So that's not the slope of this graph, because this is f prime of x. I want to look at where the value of this graph is equal to 0. And that happens at 3 points. It happens here, it happens here, and it happens here. Okay, now what I need to do is I need to see what is f prime of x at those points. So f double prime of x. So f double prime of x is the slope of an f prime of x graph, right? So let's write that, right? So f double prime of x is equal to the slope of an f prime graph. Because the primes, like the derivatives, those are just taking slopes. So let's look here. What is the slope here at -5? That slope is down. And if the slope is down, that means that f double prime of x is negative. So here, f double prime of x is negative, and that's not going to be a minimum. Right? Because I need f double prime of x to be positive. Let's look here. At x equals -1, the slope of the f prime graph is positive. So that means f double prime of x is positive. And so this is a local minimum. Okay? So I do have a relative minimum. You can say at -1, x equals -1. You actually don't know what the y value is because you'd have to know some other stuff for that. And then at this point, well, the slope here is equal to 0. That's not positive or negative. You're going to find out later. That's called an inflection point. Although this isn't an inflection point because the sign of... No, yeah, the sign of f double prime does change. Okay, so it is an inflection point. So it's only at x equals -1. So relative maximums, that's when f prime of x is equal to 0 still, because this is like critical points. But f double prime of x is negative. The reason why it's negative is because it's concave down. Sad face. And if things are concave down, here, this is a max. Right? And I always talk about like the vertex because that's where the derivative of this graph is equal to 0. Okay. So where is f prime of x equal to 0 but f double prime of x equal to being negative? That happens here. And so that's at x is equal to -5. Final intervals when f double prime of x is less than 0. Oh, that's cool. So this is where the slope of f prime of x is negative, or like down, for instance. So where does that happen? Oh, okay. Well, that happens... Well, here it's pretty negative. Negative, negative, negative. And then it's 0. Okay, so I can say... From here to here, f double prime of x is negative. The slope is positive as we keep going up. Then it eventually levels out to being 0. So then the slope is negative again from 2 to 5. Right? Because look, slope is pretty downward. Very downward, not so downward, but still downward. And then eventually it's 0. So here, f double prime of x is also negative. So if you want to write that out in interval notation, that would be from -7, comma, -3. And then you have to say union because you're like this area plus this area. And that's from 2 to 5. Okay, great. For what values does it have a point of inflection? So inflection is where f double prime of x is 0. That only happens in one place. X equals 5. X equals 5. You can say because f double prime of x is equal to 0. Also, double prime of x changes sign either side. In this case, it changes from negative to positive. So look, this is where the inflection point is, because the derivative of f prime, which is f double prime, is equal to 0. But more importantly, I need f double prime to go from being negative, here it's like slope down, to being slope up. Inflection points, they have to change. If it did this, that's not an inflection point. Or if it did like, I don't know, like that. That's not an inflection point. It's a saddle point or something. Okay. Cool. Kubi, does that make sense to you? You want me to explain any other parts of that? Let me know. Oh, which one were you, Kempy? 14? Makes sense. Very helpful. Nice. Yeah, good job. Alright, cool. I'm gonna send the screenshot of this in our Discord. So make sure to go join our Discord if you wanna get the download for this. It's gonna show up right here. So I'm gonna put it in here. I'm just gonna upload. Kubi. There you go, dude. There's your solution. Cool. What level maths are you doing right now? We're doing everything. I've done everything from linear algebra to group theory to, you know, calculus 1 to pre-calc to all sorts of stuff. It's been 10 hours of fun, math, and adventure. But again, if you're just joining us and you haven't found us before, how this works is go to this website. It's called actualofficehours.com. It's linked in almost all the streams. And all you have to do is type in a username you want to be called and drag and drop in a screenshot of your homework question or test question or whatever you want help with. And then it'll get added to the queue. So, yeah, Oliver, if you want to drop me a screenshot of an example question, I can try to do it. Davvy's next on the list. Ooh, this is great. Love this. This is a physics question. Banked curves. Okay, a banked curve is, okay, as shown in the diagram, if a 1 kilogram car navigates the curve at 65 kilometers per hour without skidding up the curve, what is the minimum coefficient of friction of the static friction between the pavement and the tires? This is actually kind of a tricky one to do. It's weird because this is an inclined plane where you don't rotate the axis. Almost always when we have these types of questions, we like rotate this to make it like this. And then there's like, you know, this is gravity, but then you have like this and this and this. In this case, you don't. The reason why is because this thing has acceleration in this direction because it's going around in a circle. The way I like to like kind of draw that. So imagine from like a top-down view, right? You have a car like going around this way. And then let's imagine you start to look at it from the side, which would be like looking at it like this. Now the car goes around like this, but it has centripetal acceleration always like inwards, directly inwards. And now to make things even crazier, this is on like a ramp. And it's pointing inwards. Yeah. Okay, so let's draw some forces on things. So you have, oh, let's get a thinner thing. You have theta here. You have mg pointing down. If it's trying to skid up, that means you're going to have friction trying to pull it down so it doesn't skid. So here, this is friction, Fs. You have normal force. And then that's it. And then there's this centripetal acceleration that's occurring in this direction, okay? So we're not going to rotate our frame here because I need to account for things going to the left directly, which is that. Okay. Would you use an NT axis? What is an NT axis system, Bob? NT axis system? What's NT? Oh, normal tangential, yes. Yes, exactly. But these you usually use for, like, looking at something from the top. Right? I get it. Yeah. That's cool. Yeah, in this case, the normal tangential thing is usually when you don't have banked curves, and we're just talking about something, like, sliding this way or sliding this way. Usually it helps to not describe this axis as our axis of motion, because that has components in the x and y direction. But because I need centripetal acceleration to point straight into the left, you actually leave it like this. I'll show you what I mean. So, if this is theta, then this is also theta. Yeah. This is also theta. Right? By like, you remember transversals? Okay. And if that's theta, I think this is also theta. Right, because this makes a 90-degree angle. So this is the complement of this 90, but then this is also the complement of this 90. Okay, so this is theta, this is theta. The other way I always think about this is think about what happens if this theta goes down. So if, for instance, if this angle were to like decrease, then I would need the angle between my horizontal axis and my force of friction pulling me like down this way on the ramp. This would need to like close up to this, right? So as this gets smaller, this would need to get smaller. So this angle must equal this angle. And then also this would start to like right itself that way. The normal force would stop pointing at an angle, it would start pointing like straight up if it was just flat. And so that tells me that this angle must decrease as this angle decreases. That's kind of my way of doing it. All right, so let's do sum of forces. Sum of forces in the x direction. Okay, so you have this. So you have, I'm going to describe this distance as positive. This distance, this direction is negative. This is positive. This is negative. As long as you set the convention ahead of time, you're great. So Fs cosine theta plus Fn sine theta, right? Because I need the component of this that points in this direction. That makes a right triangle where this is the adjacent. That's why it's cosine. Here, this has components this way and this way. So I need the sine, the opposite of this angle. Cool. And then this all has to equal the mass times the acceleration in the x direction. But the only acceleration this thing has in the x direction is the centripetal acceleration pulling it towards the center of the rotation you're doing. So this becomes, instead of max, it becomes mac, but centripetal acceleration is equal to v squared over r. Cool? All right, let's look at the sum of forces in the y direction. That's going to be, so this is pulling down, this one's pulling up. So you have Fn cosine theta minus Fs sine theta minus mg, right? So I need the component of this pulling down. That's the Fs sine theta. I need the component of this pulling up, which is Fn cosine theta. And this, and then mg is also pulling down. But this has to equal 0.
Good job.
Because I need the car to not move up or down. It needs to stay where it is on the ramp. Okay? Now, I need to solve for mu somehow. So, where this comes into play is that Fs, let's remember, is equal to mu s Fn. Okay? This is frictional force. How fried is bro? I'm doing okay. I could do more. Alright, so we have mu s Fn cosine theta plus Fn sine theta is equal to... Alright, I solved the abstract algebra question. Okay, thank you, Pen. I'm gonna look at it before I go to bed as like a little like nightmare. No. It's gonna be a nightmare for me, dude. Thank you, Pen. I appreciate that. Okay, and then this is Fn. It wasn't too bad. Okay, then I'm gonna learn from it. And this is equal to mg. Good. Can you explain why my professor means that centrifugal is a fake, fictitious force? JC, look, someone says centrifugal is fake. It is fake. It is fake. What does it have to do with inertial coordinates and stuff like that? Yeah. So, here's how I like to think about it, right? If you're in... Let's say you're in a car, right? And the car's going around in a circle. Your body, like, technically wants to keep moving in this direction, right? But in order for it to not keep moving straight, you need to have some force that provides for the centripetal acceleration towards the center, okay? So what happens is, you as a person, you want to keep moving this way, so you end up feeling like you're getting pushed out because you're accelerating inwards, but you don't want to go inwards. So in your frame, right, in your inertial frame, if this were like to keep, as this like moves in this direction, you feel like you're getting pushed out of it because you want to like keep going straight. So people sometimes say, oh, well, yeah, the centripetal force is then mv squared over r, right? And it's just like, no.
No.
The sum of the forces provides a mass times acceleration that points in that direction, but that's not centripetal force. The other way this works is, what is it? If you're like a person, right? And you're swinging like a bucket, and you swing the bucket around in a circle, right? There has to be some like tension in the rope that keeps the bucket on this path. But if you were in the bucket, you feel like you're getting pulled out. Yeah, swingling. Yeah. So, again, because in your frame, you want to just keep moving this way. But you feel like you're getting pushed, like, against whatever, like, border you are, because you're being forced to move in a way you don't want to. Yeah, in general, I don't like, don't talk about, like, forces. Don't talk about centripetal forces or centrifugal forces. Just talk about what forces do there need to be to provide an acceleration that points in the centripetal way that I need to move. That's how I think about it. JC, do you have a better explanation for that? About why it's like a fake force? Because nothing's really like exerting a force on you. You just feel like you're getting a force exerted on you because you're going where you don't want to go. It's kind of like weight is like a fake force, right? That's like the normal force acting up on you. Like how heavy you weigh is not like gravity pushing on you. It's how much the ground is pushing back up on you. It's how much the ground is pushing on you. It's kind of weird. And that's why when you're in an elevator, you feel lighter and heavier based on which way the elevator is accelerating, because that determines how much normal force from the ground pushes up on you. And that's how you feel heavy. Yeah. Omcot says, you up at almost 2? Yeah, almost 2. We got 30 more minutes. We're getting there. We'll get there. Alright, I need to solve for some shit. What am I solving for? Coefficient of static friction. Coefficient of friction. Okay. Oh, I remember what I do here. Oh, wait, do I? Ew, banking the curve. Yeah, I know, this is a gross one. I'm trying to remember the algebra you do here. I guess everything has Fn in it. Like if I divided these two functions by each other. Let's just try it. This is 1, this is 2. So we do 1 divided by 2. I get this. This is cool because the mass doesn't matter, actually. It's actually really dope how this works. This is why I prefer to do everything in terms of variables. I know it's very tempting, especially when they give you, like, all of these, like, numbers and shit. You're just like, oh, let me, like, start plugging numbers in. Don't do that. Because you might not need those numbers. If you leave everything as variables, you get to see really awesome cancellation happen. So watch, this is really cool. Because look, I have fn times fn and fn, fn and fn. I could pull an fn out of the top and the bottom, which means I can just get rid of it. So that goes away, that goes away, that goes away, that goes away. Cool. And then m over m means I can cancel the mass out. Right? So now I'm left with mu s cosine theta plus sine theta is equal to v squared over r over cosine theta minus mu s sine theta is all over is equal to g. So then we can just say it's just equal to gr. Okay. I want this to like turn into something fun. That's a bingo. Alright. I think I'm just gonna cross multiply. I'm tired. Alright. Mu s gr cosine theta plus gr sine theta equal to v squared cosine theta minus mu s v squared sine theta. So group the mu s's together. So I get mu s gr cosine theta plus v squared sine theta is equal to v squared cosine theta minus gr sine theta. Okay, cool. So then mu s is equal to v squared cosine theta minus gr sine theta all over gr cosine theta plus v squared sine theta. Nice. Okay, so let's see like some extremes. I always like to check out extremes on this. If v is very big, well, mu s is going to be very small. That doesn't make any sense. And then if, let's think, if theta equals 0, so if theta equals 0, then this goes away, and I just get that mu s is equal to v squared over gr. I think that makes sense because mg mu s needs to equal to m v squared over r. And look at that. Yep. That's the correct response. Right, that's if it was flat. So this is always the cool thing when you have physics is to start taking limiting cases. Think about like, okay, what if it was flat? What if the curve wasn't banked at all? What if mu was equal to what if theta is equal to 0? Do I get the traditional result? And I do. So I'm tempted to say this is actually correct then. The other case is that theta becomes like really big. But in that case, then mu has to be like infinite. So yeah, there's the case where, yeah, same concepts are applied for fluid dynamics as well. It's cool on EBH. Let me see if there's a formula for this one. What is it? Let me see. Banked curve, maximum mu. That's the other thing. This question has been done so many times. I guarantee you I can find the answer to it. Okay, cool. Oh, this is Vmax. Oh, yeah, look at this. See? Maximum speed on a... Yep, someone's already done it. This is it for V. So, yeah, I'm probably correct. Yeah, usually you solve for the velocity, not for the mu. Okay, I trust I'm right. It looks pretty correct to me. Nice. Okay, so last step is you need to plug the values in. I'm gonna save that for an exercise for the reader. And notice how it doesn't depend on mass. So I never needed to know mass. The other thing you need to do is you need to convert your velocity to meters per second. So you have to say like how many meters per second is equal to 65 kilometers per hour, right? Fast conversion for that is that 1 kilometer is 1,000 meters, and then that 1 hour is 3,600 seconds. So dividing by 3.6, I think, is what does it. Yeah, just divide by 3.6. And that's equal to V. And then you should plug that in. And you should get some answers there. Yeah. Random question, but what's your favorite unit? Feel like every chem or physics or engineering guy has their pick. I really like E&M. I think E&M's really cool. So especially like F equals QVB. And like Ampere's law. All that stuff is like really wicked to me. I enjoy teaching mechanics a lot, mainly because I've done it so much. I've taught so much mechanics at UCLA. I've taught so much mechanics over just like tutoring. And then I would say related rates. I know everyone hates related rates in calculus. But I really like related rates. I think they're fun. I think it's a very cool demonstration of like applications of calculus. All right, this was Dabsy. If you want to say my least favorite thing is Epsilon Delta. I hate Epsilon Delta. I think it's garbage. I don't know why we go over Epsilon Delta. 91 watching. Yeah, no, nice. Dude, we hit 330 the other week. Yeah, welcome everyone from YouTube if you're watching us. We've been doing a 10-hour stream to celebrate 10,000 subscribers on YouTube. Looks like we're up to 10,216. So if you want to support what we're doing, we're a nonprofit that helps kids with math and science by doing free office hours tutoring streams, and we buy them gift cards for like doing well in school and shit. Students all over the world. It's not like any school. We help everybody. Everyone likes really late till the snow starts dropping down. I agree. Yeah, it's tough. It's tough, dude. Okay, whose question was this? Davsy. All right, Davsy. I'm gonna put the screenshot of your question right here. So there you go. It's yours. All right, let's see what we got next. What we got next on for the last 20 minutes of the 10-hour stream. We're getting close. What's going on here? Jesus. Is this just like what the range equation is? Oh, okay. Ooh, this is actually really fun. Oh, this is actually kind of a hard one. What do you know about thermal heat transfer, boiler, and steam and gas turbines? I know you use a lot of tables. No. I've helped with that like years ago. I don't know too much of it anymore. I remember, you know what's funny? I remember teaching a bunch of people from the UAE who were here at UCLA for engineering, whatever, like exchange program, and I remember having to like teach them turbines. I was like, man, this stuff sucks. No. Okay. A ball is thrown vertically with U equals 21 meters per second. Calculated which at what wait what at calculate times at which the ball is 2 meters above the release point. Okay, cool. Well, this is not too bad. Thankfully, it's thrown vertically up. I thought they were gonna do this, like in terms of X and Y, and they were gonna like have me figure out where this happens. That would suck. Yeah, PV TV. Yeah, I've done them. I don't remember them. You could submit one, and maybe one of the engineers in my stream would love to help you. Do you have a friend like an energy engineer manager I can get a recommendation about my career? I would say, yeah, if anyone in chat, I know a lot of people in chat here are engineers. Help Mustafa out. Or feel free to join my Discord. I have a bunch of other people that are in various stages of their lives and careers. Again, if you're just watching, you just found us. The website, if you want to submit screenshots of questions, I can't guarantee I'll get to it because we're at the last 19 minutes. But in the future, this is how you submit screenshots for us to go through. And then also, if you want to figure out the times we stream, there's a schedule that shows all the times we stream and all the times our other awesome friends stream. And then you can also join our Discord here. Very easy. Yeah, for sure. Yeah, join, DM me or something. I can probably put you in touch with someone who's an engineer in whatever you're doing. Okay, so this is not too bad. So y is equal to y naught suvat. You know, I didn't know it was called suvat until like a couple years ago. So that was way after my PhD. I still hadn't. I'd never seen it called suvat. To me, that's kind of like a European thing. All right, v naught y t plus 1/2 at squared. Yeah. 2 meters above the release point, so that means y is going to equal to 2. Initial height we assume is 0. Initial velocity is... Oh, this is why it's suvat. Because you guys do this. S equals S naught plus... Or I think they do this. I think they say delta S, which is really y minus y naught, is equal to u plus 1/2 at squared. And then also v is equal to u plus at. Like v is like the second velocity, the final velocity. Which why is it a different letter? I like using like noughts and like 1s and 2s and stuff. It comes in handy, especially when there's more than just 2 situations. Where was that question? We did it earlier. Where was that bitch of a question? This one. Yeah, this one. So this question had 5 different situations that were happening. So in this case, I needed like V0, V1, V2, V3, V4. Because we talked about a ball like hitting it right before it hits it, after it hits it, and then like this, like hitting a spring and then compressing a spring. So in physics, when you have a bunch of different, I say like critical time points happening, a bunch of different events, you really want to be able to label your velocities as like V1, V2, V3, V4. Not like X, Y, Z, U, V, M, purple. I don't know. Like what? Anyways, okay. Initial velocity is 22, and then this is t, and then this is going to be 1/2 a, so that's minus 4.9 t squared. Bingo. Okay, this is going to be a quadratic, unfortunately. So I'm going to move that over. I'm going to get 4.9 t squared minus 22t plus 2 is equal to 0. And I gotta figure out when this is equal to 2. Cool. I don't think there's an easy way to factor this, unfortunately. It's not anything nice. So when that happens, pull out the calculator. We're gonna throw this in as an equation. So I'm gonna say 4.9 t squared. We're gonna say x squared minus 22t minus 22x plus 2. Trace. See what we get. Cool. I'm gonna zoom a little bit just so it looks nicer. There we go. Oh, actually, we zoomed in too far. Okay, let me do my x min at -1, my x max at like 5, my y min at like -2, my y max at like 5, whatever. There we go. That's better. Okay. So then you just go second calc. And you just tell it the zeros, and it'll solve for the zeros. You just gotta make sure you give it like the right bounds. So here, when I say left bound, I need to make sure I'm like to the left. You see this little like spider icon that comes up? The little spider needs to be to the left of where you think the 0 is, and then you need to make it to the right of where the 0 is. Guess you get a time, which is 0.09 seconds. So that's on the way up. So after you launch it up, after 0.09 seconds, it's hit 2. And then it goes up, and then it comes back down, so we can calculate the next 0. Okay, but that one we need to go start looking over here somewhere. So again, I'm going to get something just to the left of where I think the 0 is. If it wants to go find it. Come on. How many times I got to click this? Right, okay, so right to the left of it. Right to the right of it. Hit enter. And we get 4.4. So, or 4.4 seconds. Here, and then I'll put a little calculator thing so you can see it. Cool. Nice. Good question. That was one Zab. Oh, you're from Jamaica, one Zab. One Zab was on here really, really late. A really long time ago. I hope he's still okay in Jamaica. How many questions can I solve in 13 minutes? That's the question. Yeah. It's been a bender. I don't know if I like went through how many questions we went through today. I can actually probably check it. Probably pretty cool. I can probably see. Nice. The number keeps going up. Statics. Oh dear. Okay, so I'm gonna do what's called like my like burner heater mode, which is I'm gonna just try to answer things I think I can do quickly in whatever order I can. So like for instance this, I can't answer this quickly. This is statics. But it's like kind of weird statics. But don't worry. Just because I don't get to it doesn't mean that it won't be covered, because everything here will get sent to my Discord, and it's a big public forum, and we have a bunch of really awesome people who like to just solve problems in their spare time, and so they'll probably take a look at it for you. Ooh, I like this. This looks fun. I think I can do this. I like trig identities. Yeah, fuck yeah, these are great. Except cosecant of 2 theta. Ew. That kind of sucks. Let me get some trig identities. This thing, whoever this is, whoever made this table, I use it so much. Bless you. Okay, secant squared minus tangent squared. So what I know, right, is that 1 plus tangent squared is equal to secant squared. So secant squared minus tangent squared is equal to 1. So right off the bat, this is 2 times secant squared of theta minus tangent squared of theta. But this is 1. And then this is over cosecant of theta. Cool. So now I have 2 over cosecant of theta. Okay, but cosecant of theta is 1 over sine. So 2 divided by 1 divided by sine, that's equal to 2 sine theta. Alright. Fuck. 2 sine theta. Oh, here we go. Double angle identity. Still going, dude. Last 11 minutes of the 10-hour stream. Last 11 minutes. Okay, so this thing tells me it's been 9 hours and 50 minutes. Sine of 2 theta is equal to crazy stretch. Yeah, I said I'd do it because we hit what was it? We hit 10K on YouTube. So I said I would do something special. I'm a man of my word. All right, 2 sine theta cosine theta is equal to sine 2 theta. So that tells me right away that 2 sine theta, 2 sine theta, if I move this over, is equal to sine 2 theta over cosine theta. So 2 sine theta is equal to sine 2 theta over cosine theta, okay? Which this is the same thing as 1 over sine 2 theta. And then this is, what is this? 1 over cosine theta. This is how like you write this as like more fractions. Cosine theta is secant theta. 1 over cosine theta is secant theta. 1 over sine 2 theta is cosecant 2 theta. Nice. That's the correct answer. See, I knew I could burn that one. That one's easy. Who was that? That was Aham. Okay. What's up, clickbait? We're still here. How's your studying been, dude? Clickbait's always doing like ridiculous like quantum mechanics questions and stuff. Are you the referee, though? Is that the ref? You about to call time? Final 9 minutes. My body is ready, dude. My body's ready to, like, go to bed. I mean, I went to bed at 5 a.m. last night because I was vibe coding all night. But... I don't think I've been using my brain for this long in a while. Okay. This I can't do fast. Ooh, I can almost do this fast, but not quite. Exponential functions. No, quite. Willy-nilly, what do you got? Find all the critical points. Ooh, this is tricky. Tricky. Okay. Also, long, willy-nilly. I need something... No. That's like group theory. Almost. A lot of these I could almost do. I don't want to do the JEE questions, though. Oh, and then this is tensors? I love you, dude. This is funny. Okay. I think I will do this one. I've been hammering out spherical Laplacian lurking through most of your stream. You got to be cooked by now. I am slowly roasted for sure, dude. Here we go. Last 7 minutes. Okay. Find the app. So you should always check the boundary. Always check the endpoints. One is always like check endpoints. Especially if it's bounded. Okay. So f of -3. That equals -3 squared. Plus 2 times -3 cubed. So that's 9 minus 6. I was about to say -8. So that's 3 to the third. So that's 27. Okay. Let's check f of 1. That's equal to 1 plus 2 cubed. Also equal to 27. Okay, so these are cool. Sorry, check derivative. Okay. F prime of x. This is a chain rule. Because I don't know the derivative of this, of what x squared plus 2x all to the third is, but I know what the derivative of something to the third is. So that's equal to 3 x squared plus 2x to the second times 2x plus 2. Right? So I did like, okay, 3 comes down, drop the power. That's this. Then times the derivative of what's inside. And then this all still has to be equal to 0. Okay, so this gives us some cool solutions, right? So either this equals 0 or this equals 0. This equals 0 when x is equal to -1/2, which is within the bounds, so we're okay. And this equals 0. You can factor this. So this is x plus 2. So that's at x equals 0 or x equals -2. What's up, Panda? 4 hours ago. Welcome back, dude. Last 5 minutes. Still up. Still kicking. Okay, so then I could check the second derivative, but the even easier way is just check the points. Just check the y value. I think because bro is crunked. How do I mistype, bro? Yeah, I'm the one that should be mistyping.
Good job.
Bing bong. Okay. I always need to can I just see this? Let me just see it again. 2x plus 2. Wait, where do we get 2x plus 2? Oh yeah, I fucked up. Thank you. Thank you. I'm tired. Yes. There you go. Good. Yes. I don't know why I said 1/2. Check the points. So at x equals 0, this equals 0. So that's probably a minimum. Right, so f of 0 is equals to 0. F of -2 is equal to 4 minus 4, also equal to 0. These are all probably minimums. F is equal to -1. That's kind of a weird one. That's 1 minus 2. It's -1 to the third. That's equal to -1. Oh. Right? Oh, so this is like the absolute minimum, I think. Okay. So your max oh, so the absolute max. Okay, so this is absolute minimum. Is at, so absolute min is at -1, -1. And absolute max, or global max, I guess, or whatever, like on the bounds, at -3, 27, and 1, 27. Yeah, nice, cool, nice, good question. It's fun. Love to see it. Who is that? Is Mofongo? Mofongo. My brain knows that the end is near. We're getting there. Alright, so this was 4. Post 4. Delete 4. What do you want me to do with that, baller? You want me to just like factor it? Factorize, he says. Maybe. That looks kind of ugly, honestly. You know what? Since I have 3 minutes left, I'll look at this one real quick for you. Cause I don't think I had any other ones in there I can do like real quickly. There you go. All right. So x, y minus 2xy. First of all, I'll do it this way. And then we're multiplying that by x, y, and minus 2. X squared, xy, negative 2x, negative 2x squared y, negative 2xy squared, 4xy, xy, y squared, negative 2y. Okay, so what do I get? I get x squared. Not in the next 1 minute. We've been streaming for almost 10 hours, so I'm going to end the stream after this. I'm tired. Oh, actually, this is 2xy and 4xy is plus 6xy. 6xy. Actually, and let's leave stuff here. So, minus 2x squared y, minus 2xy squared, 6xy. Minus 2x, minus 2y. This is just ugly, dude. What? And then this is going to be plus 1 plus x squared, y squared, minus 2xy. Okay. So, that cancels. So you get 4xy. Minus 2x, minus 2y, plus 1 plus x squared, y squared, x squared, minus 2x squared, y, minus 2xy squared. I think we do is take x plus y as a. Oh! And xy is b. Oh, so this is a minus 2b. Oh, that's actually really cute. A minus 2 plus 1 minus b squared. Oh, okay. So what is that? That's a squared minus, all right, plus 4b squared. Next special stream will be 100k subs. Yes, 100-hour stream. Oh my god, dude, I'd kill myself. It wouldn't really work. I want to see one sec. 1 squared minus 2b plus b squared. And then this is a squared, and then this is minus 2a. This is actually really interesting. Minus 2a, minus 2ab. Right? I don't see anything nice there that really works. A squared plus 5b squared minus 2a minus 2b minus 2ab. You're right, 4b. Yep, you're right. Thank you, JC. Oh, okay. A squared plus b squared plus 2b minus 2a minus 2ab. Still too many terms.
You done messed up, Aaron!
Still too many terms. Okay. Oh! We're at 10 hours. We've done it, ladies and gentlemen. I'm going to close the stream out. Alright. Awesome. Thank you, everyone, for coming to the Actual Education 10-hour 10K party event. Yeah, I'm done. I'm done. Yeah. Like, I'm done, dude. What? Awesome. I appreciate everyone if you came by. I know some people even like took naps in between. Like, you know, awesome, JC. Appreciate you being here. Shout out to JC. He's a cool guy. Yes. I hope if you guys are just joining us and you just found us from the internet or you've never heard of us before, my name is Dr. Gold. This is Actual Education. We're a nonprofit that helps kids out with math and science, and we do free tutoring a lot on live streams just like this. So yeah, no, thank you everyone who came for the journey. We had so many fun questions that got asked. I will tally it later. It's probably close to like 40 or 50 that got answered. And also, yeah, ooh, the numbers went up. Nice. 10,221 subscribers. Yeah, it's been cool. It's been a crazy journey to get to 10K. I didn't think we were gonna hit 10K this year, but we did it. And I said we're gonna do the damn thing. We're gonna do 10 hours. So yeah, don't worry. If we didn't get to your question today, we will get to it at another point in time. I encourage you to go to the website www.actualofficehours.com. There you can see the streaming schedule on the next time that either we stream or our other awesome friends stream. So good night, Ryan Gosling. I do appreciate that. So next stream coming up, we just ended this in a couple hours. That's gonna be Zach. He's got a cool little podcast he's doing on Friday, and then with Penn Center. And then Zach also has a math help stream on Saturday. And then we're back at it next Sunday. Our next stream will be on Sunday at 3 p.m. Pacific, 4 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. He deserves more. Yeah, we'll see. I mean, you guys are great. Yeah, if you like the channel and you want to support it, again, like, subscribe, notifications, share. All that stuff helps us immensely with the algorithm. And then the more people that YouTube sees that are watching us, the more people it wants us to be seen by, or something. I'm at loss for words right now. I've been teaching too much. My brain's mush. Okay, sweet. So if you're watching us on Twitch, which I highly recommend you guys go watch us on Twitch. It's a supremely better experience because it's horizontal and stuff. You can always go here, click watch live on Twitch. Also, if we went through your question and you want to like look at the answers, go click on join our Discord. We have a whole channel dedicated to all the questions that went over today, and so you can look at the solutions and you might even learn some new stuff. Good night, Buff Ryan Gosling. Appreciate that. Yes, and thanks, Laz. Thanks for everyone who donated subs, gifts, prizes. You guys are dope. This is a nonprofit. All the money goes towards us incentivizing more students to learn math and science, and you know, figure out it's actually cool to like be involved with STEM. But that being said, I'm gonna leave us on Twitch with a raid. So if you're watching us on Twitch, what that means is we're gonna go say hi to another person who's streaming. I don't know who the fuck's streaming at this hour in LA. Looks like we're gonna go say hi to Draw Curiosity. She's been on for 4 hours. She's fun. I met her at TwitchCon. Looks like she's playing video games. Go say hi to Draw. All right, awesome. Enjoy the rest of your week. Have a great fucking weekend. Thanks for coming by. We will see you on Sunday. Peace.
I don't like Stunfisk. That's a very tiny Stunfisk, though. So maybe we'll come back.